Hello, I'm Svetlin Nakov from SoftUni, the software university. I'm very excited to introduce this first part of my free full Java Foundation course, which teaches important concepts from Java programming, such as data types, arrays, lists, methods, strings, sets, and maps, one of them streams, classes and objects, and object-oriented programming, OOP principles, exception handling, and common Java APIs. And it prepares you for the Java Foundation's official exam from Oracle, exam number 100811. Let me introduce myself first. I'm Svetlin Nakov, a PhD and an experienced programming instructor who helped more than 100,000 young people to begin coding, learn software development, and start a tech job. Just Google my name and you'll find more about my achievements, awards, programming books, video lessons, software academies, conference talks, and other teaching activities. Check out the SoftUni alumni on LinkedIn to see the profiles of my students who have already learned programming and started a tech job. I will teach this course together with my colleague George Gurkiev, who is a senior Java developer, our winner, and an experienced programming instructor. I should warn you that this course is not for absolute beginners. So, if you have no prior experience in programming, make sure to go over my full Java Basics course first. You can see the link in the description box below this video. In this first part 1 of 3 from our Java Foundation course, you will discover many interesting programming concepts such as data types in Java, primitive and reference types, and type conversion. The next topic will be working with arrays and lists to process sequences of elements, and the next will be about defining and invoking methods with parameters, and returning results from a method call. In the next two parts, we shall cover the rest of the course topics, which are maps, which hold key-value pairs, which are also known as associative arrays, also sets, strings and text processing using Java LangString and the string builder class in Java, objects and classes, defining simple classes, constructors, instance and static members, methods and properties, etc., and the principles of object-oriented programming, OOP, encapsulation, inheritance, abstraction in interfaces, and polymorphisms, the exception handling concepts in Java, the try, catch, finally construct, and Java exceptions hierarchy and how to throw exceptions, and basic Java APIs such as the mat class, random, arrays, formatter class, big decimal and big integer, and the Java time API. All these topics are essential for your further development as a software engineer, so make sure to solve the hands-on exercises in addition to this video. To learn coding, you should code, no other way. Exercises are more important than the videos, so solve the exercise problems, submit them in the judge system, and you'll get the practical skills and experience from this course lessons and topics, not just the knowledge. In case you have a question or a difficulty solving some of the exercise problems, or you have a bug and you don't know how to fix it, we are here to help you. Join the SoftUni community at softuni.org and ask for free help from our mentors. Yes, you can ask everything about this training and you'll get a free answer. Now, let's start with these course lessons. Let's start with the course content. What shall we learn from this Java Foundations practical training course? We'll start from Introduction to Java, where we'll talk about the basics of Java programming, things such as the Java syntax, creating simple programs, using the integrated development environment, the IDE, comparison operators, the if-else switch case statements, creating expressions, statements, and simple calculations with Java using the logical operators like the if, else, switch case, etc., and loops using the for loop, the while loop, the do while loop, and other loops, the break operators, and also debugging Java programs using the built-in debugger and using breakpoints, watches, and others. The next topic will be about data types and variables. Data types in Java, including the integer, the real numbers, float double, int long, and also type conversion and type casting, how to switch between types. For example, how to cast double to long or in the opposite position direction. And I will also introduce the Boolean and character data types and the string type from the built-in Java types. Arrays is the next topic. We'll talk about processing sequences of elements, ordered indexed sequences of elements. We'll explain how to read arrays from the console, how to process arrays, how to iterate over arrays, how to use the for each loop, which goes through each element from the first to the last, how to print arrays, and some simple array algorithms such as finding the minimum, the maximum, and others. The next topic will be about methods and what is a method, declaring and invoking methods, using parameters, passing arguments to the parameters of the methods, value types and reference types and what's the different, method overloading, and returning values from the method. This will be in the first part, and in the next part we'll continue with lists, which are editable sequences of elements, where you can append, you can insert, you can delete an element, and we shall explain how to work with lists, how to read elements, how to print elements, how to process lists, some basic list algorithms such as reversing list, traversing a list, finding minimum, maximum, finding subsequences, sorting lists, sorting arrays, and similar operations. The next topic will be about text processing in Java and working with strings. I will introduce the Java LangString immutable class. We'll explain how we read strings from the console, how do we print and format printed and print formatted text, as well as printing strings, how we process strings by finding substrings, finding some occurrences of something in a string, for example, a word or a letter, how we can extract a substring, how we can do some other operations like removing a portion of the string and some other things. We'll talk about the Java LangString class and using its standard methods, and also the Java Lang string builder class, which is designed to build strings, and it works faster than Java LangString because it's not immutable. The next topic will be about associative arrays, the so-called maps, and one the functions and the streaming API, which allows to process with less code sequences of elements called streams, such as, for example, arrays, lists, maps, and others. We'll talk about the map data structure, which maps value key to value and holds key value pairs, and its implementation, the hash-based maps, hash map, and the linked hash map and tree map, which are three different styles of implementing a map, the map interface. We'll then talk about lambda functions, which are anonymous functions which take some arguments and transform them to some result. And then we'll deep dive into the streaming API, how we can filter a collection of elements, how we can map a collection of elements to another collection of elements, maybe from a different type, and how we can process sequences, maps, and others. This is a very important topic because it's about processing elements in Java. The next topic will be about objects and classes. It is the first from the OOP, object-oriented programming sequence. We'll talk about objects, classes, the built-in classes in Java, and how to define simple classes, how to define constructor, method, and other pieces of the class and how to instantiate the class from and create objects from it. In the next topic, which will be in the last part of this course, we'll talk about defining classes, how we work with constructors, fields, properties, public and private members, how to define getters and setters, how to implement encapsulation and hide the internal object state behind getters and setters, how to use instance methods, constructors, and also using static members such as static methods, static fields, and also static constructors. In the next topic, we'll discuss in details with a lot of examples the principles of OOP, object-oriented programming, which are encapsulation, inheritance, abstraction, and polymorphism. We'll talk about encapsulating data behind and hiding data behind properties, getters and setters, inheriting classes and interfaces to transfer fields and data and methods from one class to another, to a child class, abstraction and working through interfaces and abstract classes, and polymorphism, which allows a variable to hold of base type to hold data from a child type. And also we'll talk about object comparison, abstract classes, abstract interfaces, and class hierarchies, and also about how to use the equals, compare to, and other common object related functionality in Java. The next topic is about exception handling. We'll talk about exceptions in Java, how to catch an exception, how to use the try-catch constructor, try-finally construct, try-catch finally in its full form, and how to throw exception using the throws keyword, as well as defining a custom exception class, and also using declaring throws in the method signature, and how do we deal with this runtime exception, also the compile time exception, and the others. Finally, the last topic from this course will be about Java API classes. We'll talk about the Java LangMath class and basic mathematical functions, random numbers and Java util random class, the arrays class, which works with arrays and provides some utility functions, formatter, which allows system out print ln and string.format, formatting string by pattern, and calculating with high precision and with big integers using the class big integer and big decimal, and how to deal with money calculations and others, and why we should be careful about this. And finally, we'll talk about and demonstrate how to work with dates and time and all of these time-related calculations, such as parsing dates, such as calculation of the dates between 2 days, and some others. So let's go ahead with this course topics, because I believe they will be interesting for you, and as a developer you need to understand them very well. Before the start, I would like to introduce your course instructors, Svetlana Nakov and George Georgiev, who are experienced Java developers, senior software engineers, and inspirational tech trainers. They have spent thousands of hours teaching programming and software technologies and are top trainers from SoftUni. I'm sure you will like how they teach programming. George Georgiev is a senior technical trainer at SoftUni. Most of this course will be taught by him. He's a senior software engineer with many years of experience with Java, JavaScript, and C++. George enjoys teaching programming very much, and he's one of the top trainers at the Software University. He have delivered over 300 technical training sessions on the topics of data structure, algorithms, Java Essentials, Java Fundamentals, C++ programming, C# development, and many others. He is a developer at the virtual racing schools, where he writes Java, JavaScript, and C++. He has 6 years of experience in training, maybe more, and more than 20, maybe more than 15 years of coding, because he codes from school years. And he wrote a driving simulator in the high school from scratch without Unity or a framework. And he played around OpenGL, Physics, SDK, WinRT, and many others. I have no doubt you will benefit greatly from George's lessons, as he always does his best to explain the most challenging concept in a simple and fun way. Let me introduce myself. I'm Svetlin Nakov, PhD, an experienced software engineer, programming instructor, tech entrepreneur, and motivator for thousands of young people to learn programming and become software engineers. You can look at LinkedIn in the SoftUni alumni to see how many people have been influenced by me and SoftUni to start programming and get a tech job. I love teaching programming, and I believe that everyone should try coding and see if it could become his passion and profession. Over the last 20 years, I have spent more than 3,000 hours teaching coding and software development. I know how to explain complex topics with simple words and real-world examples. Over the years, I have written more than 15 books along with my colleagues on computer programming and software technologies, and I have a bachelor and master's degree and doctoral degrees in computer science, and tech education is my passion, my real purpose in this world. I'm co-founder of 3 successful tech educational initiatives attended by more than 200,000 students. The National Academy for Software Developers, which I started with colleagues in 2004, the Telerik Software Academy, which were founded in 2010, and the Software University SoftUni, which I found with colleagues in 2014. And SoftUni is the biggest of these initiatives. It is the largest tech education provider in Southeastern Europe, and it is expanding globally. Over the last 20 years, I have developed an award-winning practical training methodology for software engineers based on high-quality teaching content, intensive hands-on exercises, and hands-on projects that combines computer science, engineering concepts, and software technology to build solid developer skills. I like my students to get everything required by the software companies and then start a job. I'm happy to teach programming all over the world, and I have helped thousands, tens of thousands, maybe hundreds of thousands of students to learn coding and start a job. So that's why it's my passion to train software engineers and to give them a profession and job. That's why I'm teaching this course, because I want to share my knowledge and skills, and I'm really happy when I see my students to become good software engineers, start jobs, and get a career growth over the time. Before we dive into the course, I want to show you the SoftUni judge system, where you can get an instant feedback for your exercise solutions. SoftUni Judge is an automated system for code evaluation. You just send your code for a certain coding problem, and the system will tell you whether your solution is correct or not, and what exactly is missing or wrong. I'm sure you will love the Judge system once you start using it. Thousands of students are using the Judge every day, and I'll show you how useful is it for you as a beginner in the software development with Java. So you can test your code at the Judge system using the link provided in the code lessons, and it looks like this, and you put your code in this field here, and you click the submit button, and you'll get an answer. I'll make a demonstration for you. So you open the judge system, and there is a contest. This is called contest, which consists of a set of problems, and these problems are here. So you click practice, and you choose a problem, for example this one or this one, and you write your code, and in IntelliJ IDEA you paste it here and click submit. And once the submission is sent, you wait a bit, you click here refresh, and the result comes here. So your code could be either correct or not, and if it's not correct, you can see what are the mistakes. For example, here the mistakes are that you have 1 0 in addition, which is not required in the output. So looks like it is correct, but you have 1 0 exceeding 0 that is not needed, and you should check, change something. So for each problem we give you as a hands-on exercise, we have one separate problem, and you paste your code and you submit it to check your solution. So the judge system is very helpful for you. This is something which obviously doesn't work. So use the judge system, because practice is very important. In fact, people were coding by coding, not by watching videos. So you are highly encouraged to solve your hands-on exercises and submit them in the judge to check them for correctness. This first lesson aims to briefly go over the material from the Java Basics course and revise the key concepts from Java coding. If you have basic experience in another programming language, this is the perfect way to pick up on Java. If not, you'd better go through the Java Basics full course. We'll go over Java Basics syntax, input and output from the system console, conditional statements such as if, else, and switch case, loops like for, while loop, and do while, and debugging and troubleshooting Java code. If you are well familiar with all of these concepts and you don't need a revision, feel free to skip this section and go to the next one, where we talk about data types and type conversions in Java. If you don't have significant experience in writing Java code, please solve the hands-on exercises in the judge system, because learning coding is only possible through coding. You cannot become Java developer without writing significant amount of Java code. Let's start.
Hello everyone, this is George. I am your technical trainer, and today we will be talking about the Java programming language. We will see its basic syntax. We will learn about the ways we can declare variables, the way we can branch our execution of the Java code we're writing. We'll talk about how we can loop our code, meaning execute it multiple times. And we'll see other interesting things we need to know about Java before entering into the full part of its features. So most of the topics for today you should already have some idea about, but we will do a brief overview of all of them so that we're all on the same page and we can get everyone up to speed, so we can then continue on to the more specific and more difficult topics. So what are we going to talk about today? We're going to start with the introduction to the Java programming language and its basic syntax, things like declaring variables, where the entry point of your program is, and so forth. Then we'll continue on to the operators, and specifically the comparison operators, meaning how you can do operations with data inside Java with basic data types. Then we will see how we can branch our program, because every reasonable program has some branching in it. It's not just a sequence of events. It's a sequence of events that split off into different sequences of events depending on some conditions or some input. And then we'll see how we can use the logical operators to extend that branching and do more complicated checks and decide what needs to happen in different circumstances. Then we'll talk about loops, meaning how we can execute a piece of code a random number of times. And in random, I mean a number of times which is not determined while writing the code, but rather determined, for example, at execution by input from the user or by some other conditions which are generated during the program execution. And then we'll finish up by talking about debugging and troubleshooting our programs. Now, we will be doing some debugging and troubleshooting throughout the lesson, but we will focus in the last part of the lecture on the tools which the Java integrated development environment, which we will be using, called IntelliJ, offers us. So we'll see what that gives us, how we can use it, how to use it optimally, and so on. Okay, so let's get started. These are topics which you should have some understanding of, but we will cover them again, just so we're sure that everyone is on the same page. So, what do we need to know about Java? Well, Java is a modern programming language which has a huge community behind it, an international community, and a let's say not exactly monetized community, meaning it's the specifications for Java are generated by sort of an open committee. It's a modern language which gets updated all the time. There was a period in the early 2000s in which Java didn't really get a lot of updates, but currently it's getting updates every year or so. So it's really an up-to-speed programming language which has a lot of the features other newer programming languages have introduced. It's flexible, meaning that you can write code in different paradigms and in different ways, although the preferred way of writing code is through object-oriented programming, which we will cover further on. It's general purpose, meaning that it isn't specifically for, let's say, games, or specifically for business, or specifically for desktop applications. It's a language that can be used for pretty much everything you need, although its major usages are in business applications, in larger company software, although it does have some entries into the world of mobile development. Actually, a lot of mobile apps are implemented in Java. And it has some really neat libraries which allow it to even function as a client-side scripting language like JavaScript. So there are libraries and frameworks which allow you to write Java code which is executed inside the browser directly. Although it is actually Java code translated into JavaScript, but let's not dive into that right now. So the preferred way of writing Java is object-oriented programming. And Java is actually object-oriented by nature, meaning that everything you create in Java is a class or an object, and classes and objects are concepts which are created in programming to represent the real world. So we will be talking about that further on. But for now, what we need to really know is that Java is statically typed, meaning that once you create a variable of a certain type, for example, an integer, that variable remains an integer. It will always contain an integer inside it. It can't contain anything else, meaning that Java checks for incorrect assignments of data, meaning if you have a variable somewhere and you accidentally assign it a value which isn't of the type of that variable, you will get a compile time error, and compile time errors are good things because you don't have to debug them. The compiler just tells you what's wrong. Whereas runtime errors aren't that easy to debug because you need to execute the program again and again until you find the issue. Okay, so Java is also a compiled language, meaning that there are two steps in running a Java program. The first step is compilation, meaning that you compile, you gather up all the code you have written, and you create an executable file from that. And then, after compiling that, you run the Java program. So during compile time, you can the Java compiler can detect errors in, for example, data variable type assignment. Or other stuff which will help you write your code error-free, and only then, after all of the compile time checks are done, does the program run. So in compiled languages, there are also two descriptions of time, let's say. There's compile time and runtime. meaning that compile time is when you hear that something is known compile time, it means that it is known while you're writing the code. For example, if you're executing something 10 times, and it's always 10 times, it doesn't depend on user input or some calculation, that's compile time information. That's information that is always the same regardless of the execution of the program. Whereas if something is runtime, for example, user input is runtime, then you don't know that during compilation, meaning you don't know that when you're writing the code. It is something you need to handle during the execution, meaning that your code should be able to handle different situations of user input and handle them correctly. So when we're talking about compile time and runtime, that separation comes from the fact that Java is a compiled language. Okay, so how does a Java program look? Well, every Java program begins with a class, some class. It's usually going to be the class main in our examples, but further on there are going to be other classes once we cover the subject of objects and classes. And inside that class main you will have a public static void main, and this is called a method. This is the entry point of every Java program, meaning that it doesn't matter what code you have in your program will always start from here. It will compile everything else, but the execution, the runtime of your program, will start from here, from the first line inside this static void main method. Okay, and here, of course, we now write our source code so we can implement Java code. Further on, we will learn how we can create other methods which accept parameters and have return types. We will see how to use them, how to call them from main, and so on. But for now, all we need to know is that every Java program starts over here. That is the first instruction executed by any Java program. Okay, so when writing Java, we will be using the latest Java development kit, which is the JDK 12 currently. However, you could even fall back to JDK 8. That's what I'm using currently. The subjects we will be covering in this course will not be needing all of the advanced features from Java 12. That's because a lot of the code which we're going to be using is fundamental computer science concepts which have been implemented in Java since a long time ago. However, we will be using some new stuff like lambdas, for example, which are available in Java 8. So you will need at least Java 8 and preferably Java 12 so you can access all of the new functionality if you decide to use it, but we won't be requiring you to use it. Okay, so what will we be using for development? We're going to be using IntelliJ IDEA. This is a powerful, very powerful development environment for Java. This is how it looks like. It's a product of JetBrains. It's one of the best editors I've ever used as a programmer, and I've used a lot of them, including a lot of Microsoft ones, a lot of open source ones. IntelliJ is pretty good at guessing what you're about to write and giving you hints on how to write it faster and saving you time doing that. So, you know, as programmers, a lot of our work is actually typing in code. Well, IntelliJ helps you type in less, meaning that it can auto-generate a lot of code you would be needing. Okay, so IntelliJ, we will be seeing it in a bit, and for using IntelliJ, you would need to create a project. So in IntelliJ, everything is bundled up inside projects. How do you create projects? Well, you open up IntelliJ, and you're going to get this screen if you haven't created any projects yet. If you already have created a project, you will probably get that project loaded in, and you can say File, New Project, which creates a new project. Now, for now, we will only be using the default Java project type, meaning that you don't need to be selecting anything over here. These are frameworks which are for more advanced application development, but for now we're going to be writing code which executes and reads input and writes output on the console, so we will not be needing any other frameworks to add into our project. So you pick your Java version here. If you've installed JDK 12, that's what you're going to get. Since I'm using JDK 8, well, my JDK version is 1.8. That's how Java numbers them. Okay, and then you click next. You don't need to use a template. We will be doing command line applications, but you don't need to be generating the command line template. We just need a simple project, and we're going to type in next here, and then we will just create our classes one by one. So once you have that created, you will just have a simple package generated over here, and then you will have a main class generated here, and this is actually what our code will look like. All of the code we're going to be writing in the first few lessons is going to be located inside this public static void main method. This is our entry point, so any code you write here will be executed. You start your program by using these icons on the top here, top right. The play icon you see is just executing your program without the debugging feature, meaning that you execute your program the way it would execute on a normal PC if you've deployed that to someone's computer, if you've deployed your program to someone's computer. My suggestion is that you use primarily the debugging mode, which is this icon over here, which allows you to place breakpoints, to inspect the data types of variables and their values, and so on. So my suggestion is use the debugging mode, although you could use the run mode if you are confident that your program is running correctly and you won't be needing to analyze any errors it might run into. Okay, so if we just run it, we will see that this program executes, and it actually does nothing. It just finished with exit code 0, which means it finished successfully. It does nothing because we haven't entered any code over here. Now we'll see how to do that in a bit, but before that, let's see what else we have to discuss from the slides. Okay, so this is how you create a new project. Oh, you could, if you want to save up generating classes, you could select the command line application template. That will generate you this main class. Otherwise, you would have to add it manually. So if you don't use the command line app template, you would need to go over here on the source folder, add a new package, name the package in some way. In this case, we just got a package automatically, which is named com.company. That's the standard way of typing packages in Java. You usually begin by your company website in reverse. So if your company is named company, you go like com.company.something. That's just a convention. It's not really necessary. Your code will still compile even if you don't write it that way, but that's sort of convention. That's how people usually do it. Okay, so from there on out, what do? Well, you click on this package over here, which you've just created, and you just say new Java class, and pick the name of that class. In our case, we automatically got a main class generated because we chose the command line program template. And then you just need to write the main method inside it, which is just this called public static void main, these parameters inside it, and the method body. Now, we will be talking about methods and what all of these public and static and void mean later on. But for now, all you need to know is that you need to have this method so your program can be run by the Java runtime, and your code comes over here. Okay, so from here on out, what do? Well, let's see how we can actually do some programming over here. Now, you probably know that programming is just creating, and it's actually processing information. It's not exactly creating information. It's just processing information from one type of information into another type of information. So one type of input into some type of output. Okay, so how do you process information? Well, you need to get that information into processable items. You need to have an item which you can process. And the items which you use in Java to process information are called variables. Variables are things which you, let's say, read from the console or initialize with some value, and then you can use to edit that value, to access that value, to print it on the console, and so on. So the typical way of initializing variables in Java is naming the data type of that variable, then telling the Java compiler what you want that piece of information to be called, meaning that you can, if you want to store integer numbers, let's say you want to calculate the sums of integer numbers or calculate how many apples you have left or something, you would create a variable called int number of apples. So what we tell the compiler here is that we want an integer data type, meaning that we will have the integer numbers inside this variable, and name the variable in some way so that we can refer to it later on. So Java knows how we call this piece of information, and then after we create this variable, we can give it a value, meaning we can place apples inside this number of apples, and let's say our apples are 6. Okay, so doing this will create a piece of information inside the computer. It will name it number of variables that will be allocated somewhere on the program stack in the RAM memory of your computer. And in that piece of memory, the value 6 in binary will be added. And you can use that value 6 from here on out with this number of apples variable. For example, you can increase it by saying number of apples plus plus, meaning increase the number of apples by 1. This would change the value of the number of apples, of the memory which is pointed by number of apples. It will change that memory address to contain the number 7. Okay, so this is how you create variables, and again, this is something you should already know by now, but we're covering it just in case. So here's an example of initializing an integer number which has the value of 5. Okay, let's actually do that in the IntelliJ IDE. By the way, IDE, whenever I say IDE, what I mean is Integrated Development Environment. What does Integrated Development Environment mean? Well, you could actually write code in just Notepad, meaning that you can start a Notepad and copy this code over here, and this would still be valid Java code. However, you would need to manually, using the command line, call the Java compiler, tell it to compile this file, first off save this file, then tell the Java compiler to find this file in your file system, compile it, and after compiling it you would need to manually call the Java runtime to execute the compiled class file you get from your Java code file. So there's a Java code file, this is the Java code file, in this case main.java, and actually I have some other Java code files opened up here in the IntelliJ editor. For example, this is another Java code file somewhere in the Java libraries. You can guess that by the fact that it has a yellowish background. Okay, so this is a Java code file somewhere in the Java libraries, and if I want to use that Java code file, I just type in, let's say in this case, random, which is the name of the Java class and the Java code file. Random, let's call it random. Let's just import this, and IntelliJ automatically imported it, meaning that IntelliJ automatically told the compiler that it needs to go and fetch this Java code file when it's compiling my main.java Java code file. Okay, so when you're writing code like this, if you're writing in a simple notepad, it's still Java code. It can still be compiled by a Java compiler, and you can do it manually on the command line. You type in, if you've installed Java and the Java development environment, the JDK, Java Development Toolkit, you just type in Java C, as in Java compile, Java C, and then type in the path to the file, and that will generate the compiled class file from your .java file, meaning that you will get a main.class file somewhere next to your main.java file. And then on, you can use the Java runtime environment to execute that class file. And in each step of writing your code, you would need to be manually adding the features you're using from Java. Whereas if you're using an integrated development environment, the development environment does all that for you. So you don't need to think about typing in stuff manually, or compiling manually, or debugging manually, or attaching files together, and so on. So this is all handled by the integrated development environment, and all integrated development environments have such features. Okay, so this brief sideways explanation was intended to demonstrate that actually you don't need a program to write another program. You just need a way of writing text and converting that text into into operations which are executable by your machine, meaning that you need to convert it into machine language in some way, into ones and zeros. That's something that the Java IDEs do automatically for you. So that's why we're using them, but it's not obligatory to use them, although it's almost obligatory if you want to be a fast developer. Okay, so let's create some variables. Let's create our int number of apples, and we can shorten it like this. It's a fine way to shorten it. It's understandable. Num is a frequent enough usage in programming that people understand that num means number. Okay, so num apples, this creates a variable. This creates a piece of data, and we will be talking about data types later on. This creates a piece of data inside our random access memory of our computer and names it num apples, meaning that every time we access num apples in some way, for example increasing it by 1, this increases the number of apples by 1, increases this variable by 1. Every time we access it, it will access that part of memory for which this variable was allocated. Okay, now you don't need to initialize a variable immediately after creating it. You can also have this split. So you can have an integer number of apples and then followed by a semicolon, and then have the number of apples set to some value, and you can set it to values as many times as you want. Okay, so this is how you create variables, and this is how you give them value. And if you want to do that in a single step, you just say number of apples, int number of apples equals the number you want to initialize it to. Okay, so that's initialization of variables. Now if we start this program, it will still do nothing because we haven't, it will actually do something, but we won't see the result of it doing something unless we inspect memory. Okay, so let's continue on from here. Now the code I just write contains an integer data type. This is the type of your variable. Remember when I said that Java is a statically typed language, meaning that this number variable will always be an integer. It will never be another data type. It will never contain anything else than integers. Okay, and this is its name by which we access it in our code, and this is its value, which is the data which we write into the random access memory of our computer. So this number variable name actually isn't really seen by Java. It is only available compile time. Runtime, this number variable is just an address in memory. So the computer just sees this as an address in memory, and addresses in memories are just numbers. So your random access memory is numbered 1, 0, 1, 2, 3, and so on. And every variable you create is translated into one of these numbers later on in compilation. Okay, so once we've created our variables, let's see how we can use them actually, because I actually did use my variable. I increased it by 1, I changed its value by 1, but since we're writing console applications, there isn't really any way to view the results of our program unless we use the console input and output functions which Java provides. So Java has a built-in scanner class and other libraries which allow you to read and write to the console. Now in our case, the console will be this part of the IntelliJ integrated development environment, meaning that this over here is the console. But when you're deploying your application to actual users, which won't have IntelliJ, you will be sending them files which are executable through the Java runtime. And if they start your program from the Java runtime or from its icon, if they're using, for example, Windows, and they double click it and they have Java installed on their computer, their program will start in this command prompt, or something looking like this command prompt window. So it will look like this. So your program will be executing something like this if it's running on Windows. So this is just a text input and output system which your program will access to read its input data and to print its output data. Okay, now how we will be deploying applications to actual users we will cover further on. It's not something really interested in right now because we're just learning how to use the Java code. But we will learn how to read and write our input so we can see what our programs are doing. Okay, so Java has the scanner class, which allows you to write and read from the console easily, meaning that instead of writing your own code to access the console and read bytes from it and so on, you have a java.util.scanner, which if you import, you will get that Java code file compiled with your Java code file when you start the compilation process. And you use this scanner to read input from the console. Let's do that actually. So instead of having our number of apples initialized with a compile time value of 6, which will always be 6 if I don't change it to something else, instead of that, let's use a scanner. So I'll say new scanner, which initializes an object which reads from somewhere. Where does it read from? Well, I supply that as an argument to this scanner initialization. So I'm saying, scanner, please read from system.in. This is the standard input-output for the system, meaning this is the console input. Usually the standard input-output for a system is the console. Okay? And now once I've asked Java to create this reader, I can say, okay, once I've created it, I want to be using it. In order for me to be using it, I need a variable by which to use it. Same way as when I had a number of apples, my 6 apples when I had them, if I wanted to touch that number and change its value, I needed a variable for that number, which holds the value of that number. Well, in the same way, I would need a variable which holds the value of this scanner, so I can use it to scan. Okay, so what do I say? I say this is a scanner. I'll just call it scanner because that's the name of the class. Okay, so scanner equals new scanner reading from system.in. And now instead of initializing my apples with a fixed number of 6, I can say scanner.give me the next integer from the console. Okay, so let's now increase this number of apples by 1 and now put a breakpoint over here. Now we'll be talking about debugging at the end of the lecture, but briefly, when you start your programming debugging mode, it will stop its execution on each of these breakpoints you place. You place them by simply clicking between the line number, between here and the start of your code. So you click somewhere in between. Placing a breakpoint here will cause the program to stop its execution over here and wait for you to allow it to continue its execution. Now, why would you do that? Well, because when you stop at the breakpoint, you can examine the state of your program, meaning you can examine the value of the variables which you have in your program and their values. Okay, so starting this, what are we going to get? Well, our program is now waiting for input from the console. And now we can input a number, for example 42, and when I press enter, it will finish executing this line of code. It will get the integer from the console and write it into this variable, because I said that this variable needs to be initialized with this value. Okay, and then it will stop before it increments the number of apples by 1, meaning that number of apples will be whatever I entered on the console. Okay, so if I enter 42, the program will stop here, and I can see in this variables view down to the right, I can see that I have a numapples variable and its value is 42, which I entered on the console. Okay, and if I want to continue on, I would need another line of code and another breakpoint. Let's see if we can do it like this. Now, to continue to the next breakpoint, what you do is you either press this resume program button up here to the left, or you just press F9, and this continues on to the next line of code. And since we have a it continues actually to the next breakpoint in your code. And since we have a breakpoint on the next line, well, we stopped over here, and now we can see that number of apples is actually increased to 43. And IntelliJ also lists this in line, so you can see over here I have a numapples column 43 describing the value of apples currently, and you have the other variables too. So here, over here, we have scanner, which is something a bit more complex, but still it's a value which IntelliJ shows you so you can view it more easily. So the variables inside the program, once you've stopped at the breakpoint, can be viewed from this variables window. And in addition to that, you can also write expressions here. So you can go over here and say insert, or press this button, okay, and say, let's say for example, num apples plus 10, and this will just calculate this sum. So this will return 53 in this case. So here it says num apples plus 10 gives the result of 53. Okay, so that's what debugging actually is. You stop your program at breakpoints and examine the values of your program at that breakpoint. Okay, continuing on from here, we had a program which read an integer from the console, assigned it to the variable numapples, and increased that numapples by 1. All things that you should have seen by now, but we're covering them so we can formalize them a bit. Okay, so you have other ways of reading input from the console. The scanner, in addition to reading integers, can read entire lines. So you can say, instead of reading apples, you can say scanner.nextLine, and this will read the so-called string variable, and let's call this variable line. So a string variable just contains a sequence of symbols. So a line from the console is a sequence of symbols. So you can enter anything you want on the console and then read it with next line, and that will give you that sequence of symbols. Okay, so if I place a breakpoint over here and start this program now in debugging mode, and I enter some line on the console, let's say hello, and I press enter, the moment I press enter, the next line operation will finish. It will get its value and set it to the line variable over here. And now if we examine the line variable, we will see that its value is hello. And again, we can examine it from here down also. Okay, so that's how you read from the console. Next line gives you strings, and you can use that string either to say, for example, a name or some other input, some other sequence of symbols input, or you can convert that input. For example, if someone enters a number, you can get the number, let's say 42, and this is a string currently because you read it with next line, and to convert it into the value of 42, notice the lack of quotes in this value over here, you use integer.parseInt, and you supply this value inside parseInt, and it returns an integer variable. Okay, so one way of reading numbers from the console is using nextInt. Another way of doing it is by using scanner.nextLine and then converting that into an integer. Let's say int number is equal to integer.parseInt, and you supply the line you just read. Or you directly say scanner.nextLine and you place it over here inside parseInt. Both would work. This is a bit more descriptive. So now if I start this program, we will see that line will contain the string 42, whereas number will contain the number 42, the integer value of 42. So I type in 42, and here I see that line is the string 42. It's just a sequence of symbols. It can't do arithmetic on it. However, number is the number 42, and we can do arithmetic on the number variable. Okay, so that's reading from the console, and of course there are things like next double, next line, or simply scanner.next, like this. This will read the next sequence of characters, which isn't separated by some of the separators. Now, what are these separators? Well, spaces, new lines, tabs, and so on. Other white space characters are separators, meaning that if I say scanner.next, then I initialize a variable string input equals scanner.next. What will happen if I place a breakpoint directly after that is if I write hello space world and I press enter, what I'll see is that input got only hello. And if I say scanner.next again, I can do that actually while I'm in a breakpoint. I can insert a watch here and say scanner.next, and this just read world. And if I edit it and press enter again, it will get the next value and then the next value and then the next value. So scanner.next reads words. You can think of it as reading words, reading by a word. Okay, so let's stop this program. We don't need it anymore for now. You can also parse lines into doubles by using double.parseDouble, or you can use scanner.nextDouble, which effectively does scanner.next and then parses it into a double through double.parse. Okay, so how do we print to the console? Well, you can use the system.out libraries or system.out collection of methods, and there are various ways of printing to the console. System.out.print just prints whatever you give it. So if you add a number, it will print a number. If you supply a string like this one, it will print a string, and so on. Print line will print the same way as print does, however it will add a new line character at the end. It will just move the cursor on the next line after printing whatever you supplied to it. Okay, so the more interesting usage of printing is formatting. So you can do system.out.printf, f short for format, print with a format, and then you supply the format string, meaning how you want the values you're printing to be displayed. And in this case, we want to have the string name followed by a space, followed by some string. Which is the string? Well, the first string after the format which we described. So this over here is the format. The first variable, the first thing we supply to printf is the format. And then it starts accessing the variables after it. So over here we have this format, which contains the string name and contains the digits described by age over here. So this is what printf does. It just prints formatted output. So if we wanted to say enter a number and write on the console, let's read a line with the scanner, read a number from a single line on the console, parse it into an integer, save it into the variable number, and then I want to print out system.out.printf. You just entered column, and I want to print my number over here. How do I do that? Well, I need to tell Java where I need this number to appear in this format. Well, I need it to appear at the end of the format. So if I start this program and input a number, I will have this message printed. You just entered and the number I entered. So if I enter 42, I got you just entered 42. Now notice that from here on out we don't have a new line. Why don't we have a new line? Well, because printf doesn't print a new line. If you wanted to print a new line, you say %n, which means print a new line over here. So if I start this over here, like this, I actually just click the start with code coverage, which will do some stuff I don't really need to. Starting with code coverage just analyzes which parts of your program are executed. We don't need that right now, so let's start the normal debugging mode. So if I enter 42, now I got you just entered 42, and the other messages on the console which I get due to the debugging mode are printed on the next line. And that's thanks to this %n I added at the end of the format string. Okay, so this is how we print formatted output. So printing with the symbol D prints digits, integer digits, and you can pad that with a certain amount of leading digits if you want. And if you add F, that prints a floating point number. So D is for digits of an integer number, whereas F is digits of a floating point number, meaning a number like 5.3, let's say. Okay, so if you want to print with the string %03D, that means write the number I supplied to you, but pad that with zeros so that it has at least 3 symbols in it. Meaning that in this case we got 055 instead of just 55 on the console. And for printing floating point numbers, you have the .2, meaning write this number with 2 digits after the dot of the floating point number. These are just specific formatting strings, and then you don't need to really remember them. You just need to know how to look for them. How do you look for them? You type in Google Java format strings or Java format floating point. into string, or Java format floating point string, and that will give you a lot of results on how you can print in various ways. Okay, now string.format does the exact same thing as system.out.printf. However, it doesn't print to the console directly, it just generates a sequence of symbols, it just generates a string. So exact same mode of operation like system.out.println, exact same way of supplying parameters. However, it doesn't really print to the console, it just creates a string, which you can then print to the console or use for something else. The use of string.format is to create a string which you can use for other purposes, for example, to connect it with other strings. Okay, so we have a task here and we'll do it briefly. We will have 3 input lines entered, a student name, an age, and an average grade, and we need to print it in this format. Okay, and we want the grade to be printed to 2 decimal places, meaning that we would need what? %.2f. So we're printing a floating point value, and we want that floating point value to be printed with 2 digits after the decimal point. Okay, so how do we do that? Well, we already have our scanner, and what we need to enter is what? The student name, their age, and their average grade, and each of these will be on a separate line like so. Okay, so let's say that the string name is equal to scanner.nextLine, and the age is equal to scanner.next. We could use nextInt, but let's use nextLine because we're informed that it's going to be an entire line containing just that number. So let's read that entire line and convert that into a number using integer.parseInt. And the last thing we need to enter is the grade, meaning that we need to enter double grade, which is equal to double.parse a double from the next line after that. Okay, and how do we print that out? Well, let's use that string.format function and then print the string we just got. So we will do string.format, and here we will have the input string, and I'll just copy this I got here, and then I'll convert it into a Java format string. So I'll paste this, I'll provide the parameters, the name, the age, and the grade we want printed, and I'll just change whatever I need so I can get the correct output. Okay, so instead of name, how would we print a string? Well, %s. How do we print digits of an integer number? We say %d. And how do we print the grade? By the way, I guess that there's a missed column here. So the grade, and what do we have here? We have %f for printing a floating point number, but in order to print that to 2 decimal places, we need to say decimal places 2. Okay, so running this program will just allow us to input information like the one we have here, and I will actually copy that and paste it into the console over here. And what did I get? I didn't get anything. Why didn't I get anything? Well, because I just formatted a string, but that doesn't print to the console, that generates a new string. So this is a piece of information I'm not using. Why am I not using it? Well, because it's not sent into a variable. I need to send it into a variable and then send that variable to the console, or directly send this result to the console. Meaning that here we just generated a result, but we're not using it. Okay, so let's use it. String output equals string.format this, and then system.out.print a line. Let's print a line with this output. Okay, so print this output on the console, and now we're using this value. So we have a value somewhere in memory, and we're telling the Java runtime that we're going to be addressing this value through this variable. So when we talk about this variable, we're talking about this value. Okay, and now we're just saying print this value on the console. So if I start this code again, and if I copy the input again, and paste it into the Java console, when I press enter, I'm going to get name John, age 15, and grade 5.40. Is that correct according to the input over here? Yes, it seems correct. Okay, so continuing on, we can test this program a lot more, of course, but let's not play around with it right now. We have other stuff to cover, and here we have a solution which is pretty much similar to what we already did. However, in this case, it's printf instead of string.format and then print. Okay, so Another thing we need to discuss are comparison operators in Java. So, what we had up until now was just reading variables. If we want to do something with these variables, we use operators. So we use operators which operate on the data which we have. Operators are just parts of Java syntax which execute actions on some data we have. Now, comparison operators in specific are things which can compare values inside our Java code. Now, of course, we have the normal operators which are adding numbers, subtracting numbers. So if you say int sum equals 4 plus 3, well, this is an operator. It's an arithmetic operator which sums two numbers which are to the two sides of that plus operator. So these operators, the arithmetic operators, are the same ones you're used to from mathematics class. So they're nothing special. Well, what are comparison operators? Well, comparison operators are a way to examine values against other values in Java. So what you have is equality checks, inequality checks, greater than or equal, less than, and less than or equal. So the mathematical operations basically, however, the way we write them is a bit different. So if you want to check for equality, you use double equals sign instead of single equals sign. Why? Well, because the single equals sign just changes the value. So this single equals sign means change the value of the memory which is pointed to by this name variable. Whereas the double equals sign checks whether two things are equal. And that returns either a true result, meaning that two values are either equal or they are not equal. So there are only two possible answers to the question A equals B. So this is just a check. And the result of this check, since it's only two possible values, is a Boolean result. So R equals A equals B. So this might seem a bit confusing at first. So what we're saying here is you just need to know that you shouldn't be reading this as equals. It is a sign. You use this equal sign here as the word assign. So what we're saying is R equal, this piece of information, gets assigned with the value of does A equal B, and this is either true or it's false. And in this example, it's what? It's false, right? Because 5 isn't equal to 10. So the R equal variable will contain the value false. Okay, so you can save that into a Boolean variable and then print it out, for example, or use it in a conditional statement. We will see that further on. Or you can just print it on the console. So if you say is A less than B, then you get the result true for these two variables. And here we have other examples. You can play around with these ones at home if you want, and you can check other values. But again, this is something you should already know by now. So we're just formalizing this information and gathering it up in a neat little place where you can go and check later on, because what programmers do isn't remember. What programmers do is remember how to search. So programmers are good at searching for information, not at remembering for information. So that's why we have an entire lecture which has this information summed up, so you can find it easily if you need to. Okay, so we've reached the conditional statements, which will give us the answer to why do we need to compare numbers, why do we need these comparison operators. We saw what conditional operators are. Now let's see how we can use them in if-else statements. Now what is the if-else statement? It's something which you see in this picture. So an if-else statement, a conditional operator, a conditional operation, a branching operation in programming, is where you check for some condition, for some comparison, for let's say between two variables, and then you output you execute either one piece of your program or another piece of your program, or you just do nothing. So this is what the if-else statement does. This is the way you can branch your program. Now typically programs don't just read input, do calculations on that input and write output. That's not a program, that's a calculator. That's what calculators do. Now computers can be calculators, but they can also be much more than calculators. They can do different things based on different input, meaning that they can handle different input differently. Okay, so what does the if statement do? It tests for some condition. Now, like we had over here, we entered a name, an age, and a grade for a student, and all of these are potential targets for an if statement where we can check something about those variables. Now, let's simplify these examples a bit, and let's just see how the if statement works. So the if statement is just the if keyword followed by these curved brackets and then followed by these curly brackets. And inside that if statement, you place the condition which you want to check. So if you want to check something, for example, let's say you have two numbers, the number A, which is, let's say, 5, and the number B, which is, let's say, 10, like we had in the slides a bit back. If you say if A less than B, then system.out.print B is larger. What will happen if we execute this code? We will see that the output B is larger is printed on the console. Okay, so now we have that on the console. Now, if the values were different, if the values were reversed, let's say, what would happen is that this code will not be executed. So we have a branch of code over here. We have our program running and doing sequences of operations, and then it does a check. And if that check is true, it executes some other code, and then it returns to wherever it was. So returns after it executes that code. Now, this is just an if check. So this code will only be executed if A is less than B, which is always true in our case, since that's what we create as variables. That's why, by the way, IntelliJ marks this code in a deeper yellow, indicating that this value is always false. So IntelliJ warns you about stuff like this, where you might not be doing what you're thinking you're doing. Now, if these were numbers that are read from the scanner, next int, and B is also equal to scanner.nextInt. If these two are numbers read from the scanner, read from the console, this warning highlight disappeared, because now this isn't something that's always going to be true. In this case, it might be anything. That's actually the use of conditional statements. You check for conditions which are usually determined by the input in some way. So the user, for example, in our case, enters two numbers, and we check which of them is larger. Now, if this isn't true, the rest of the code will just execute. So if we say system.out.print line program exiting, this code will be executed. So whether or not A was less than B, this code will execute normally, just like it would have if the if condition didn't exist over here. So now if we want to, let's say, read two numbers and then print in one case one output and another output. So in this case, if we say 5 and 10, like we had initially, we're going to get B is larger, and now I noticed that we missed the new line symbol in this output. So we're going to get B is larger in this case. However, if we input them in another way, let's say 10 and 5, we're not going to get anything, we're just going to get program exiting. Now if we want to print A is larger, if A is the larger value, well, that's the case in the else statement, in the else branch. So the else branch gets executed only if the if branch didn't execute. So if you say if, and this expression over here is false, then the else branch will execute without the if branch executing. Okay, so now what would we want to print here? Well, we want to print A is larger than B or equal to B. Why do we say that? Well, because if A isn't smaller than B, so if this is false, then A is either equal to B, because this would be false if A is equal to B, or A is larger than B. So we can't just say A is larger, because if they are equal, well, they are equal. So executing it like this, what we'd get is, if I enter 10 and 5, I'd get A is larger than B or equal to B. So only this part of the code executed. Now, one thing you can do with if-else statements is use, if you're going only to have one line of code in them, one statement, not exactly one line of code, but one statement, one thing that gets executed, one piece of code followed by a single semicolon. That's a neat way of figuring it out if it's one thing or more than one thing. Each statement in Java ends with a semicolon. So if you only have one semicolon, that's only one thing. Okay, so in this case, you can remove these brackets. So you can say if no brackets, else no brackets, because both of these do just one thing. If they do just one thing, it's okay for you to use no brackets. Now, my suggestion is don't do this. It's really easy to make a mistake if you don't always add your bodies. These are called the bodies of the conditional statement in this case, but it can also be the body of a loop or the body of a method like we have here in main, and so on. So always add these, because it's very easy to make a mistake. It's very easy to add another statement over here and think this other statement is part of this else, but it actually isn't. It's a part of code which will always execute if you add it like this. So always place the brackets so you are absolutely certain which parts of the code are executed when. Now, that actually gives us a neat way of chaining if and else method, if and else checks. Now, before we see that, let's try to separate this into a more specific output. So let's say that if A is less than B, then if A isn't less than B, then we want to print precisely whether A is larger than B or whether A is equal to B. So in our current situation, we print one or the other, but we want to be specific. We want to be concise, whether it's equal or it's larger. Okay, so how do we check that? Well, if A isn't less than B, then there are checks we can do. What check can we do? Well, we can check if A equals B inside this else. So we only enter this part of the code if A is not less than B. So this code will only execute then. And then I say, if A is equal to B, then execute this code. Which is this code? Well, this code is going to be system.out.print line, and this line is going to be A is equal to B. That's what I'm printing. And if it isn't equal to B, what's left? Well, what's left is that A should be larger than B, because we know that if we got to this part of the code, then A wasn't less than B. And if we got to the else over here, so if we got to this part of the code, then A wasn't equal to B. Well, the only other option is for A to be larger than B. Okay, so you can place if-elses inside other if-elses in any way you like. This is just a part of code that executes. When the code reaches here, it doesn't really care whether it's in an if or an else or whatever. It doesn't know, it just executes. So you can nest these all you want. Now, a more optimal way of writing this, so it takes up less space and is a bit easier to read, is, what did I say about not having to add these brackets when there's only one thing over here? Is there only one thing over here? Well, yes, this is only one thing. It might seem like two things, but it's part of the same if-else statement, so this thing goes together. Yes, there is code inside it, but the whole piece doesn't have any semicolons after it. Now, if there was another statement over here, then it wouldn't be a single thing. But there isn't. There is only a single statement over here. So this else only contains a single statement. And I can remove the braces from this if statement, and even IntelliJ allows me to do that automatically by pressing Alt and Enter over here. And if I do that, look what I got. I got an else if. There's actually no such thing as else if like a keyword. It's not a separate keyword. It's just a sequence of an if followed an else followed directly by an if, which has its own else. So this code is absolutely identical to this code. So what am I doing here? I'm saying if A is less than B, then print whatever message I want to print. Otherwise, if A is equal to B, so otherwise if this wasn't true, but if this is true over here, then print that they are equal. And if this thing isn't true, what's connected to this not being true? Well, this else over here. So we're chaining them. You can think of it as a chain. You check this, and then you check this, and if nothing matches, you go to the last else. Okay, and how it gets structured in code, I just showed you by typing them out before I removed the braces. Okay, so if I start this program, it will now list whether A is larger, equal, or less than B. Okay, so if I enter 10, what I'm going to get, am I going to get something? Well, I'm not going to get anything because I haven't entered the other number. Then I'll enter 10 again, and what did I get? I got A is equal to B, so I got this part. And if A gets larger than B, if I say 10 and 9, then I'll get A is larger than B. Okay, so this is what conditional statements look like. So here's another example. We're reading something from the console, and we're checking whether it's larger than a certain number. And if it is, then we print something out. Otherwise, if we want to do something else, we can use an else condition. If we want to react to the statement not being true, this check not being true, we add an else statement. In some cases, we want an else statement. In other cases, we don't. So in some cases, we only want to execute a piece of code if some condition matches, and if that condition doesn't match, we just don't execute that part of the code. In that case, we just use an if. If we want to execute one piece of a code if the condition matches, but another piece of the code if the condition doesn't match, well, then we need an else. Okay, so this was the example for passing a grade. Let's see what we have here as a task, as a programming problem. So we have an hour entered, a time entered as an hour and an amount of minutes, so hours and minutes. And what I need to print is 30 minutes after that hour. Now there are a lot of ways to do that, but let's do that with if-else, since that's what we're learning right now. So we're doing that with if-else. How are we doing that? Well, what's going to happen? Let's solve it in the simplest way possible. So when you're trying to solve a programming problem, you don't need to think of the entire solution at once. You just need to think of the parts of the solution and then wire them together. So I'm still going to have two numbers. The first number is going to be the hours, and the second number is going to be the minutes. Okay, and what am I supposed to do? Well, I'm supposed to calculate 30 minutes from here on out. So if I get the 0 hours, 1 minutes, I need to print out 0 followed by 31, 30 minutes after this time. Okay, how do I do that? Well, I just increase the minutes, right? So I say minutes equals minutes plus 60, right? Okay, well, not 60, but 30. We wanted 30. Okay, and I would print this. Again, this is not the complete solution, it's not accurate yet, but it doesn't need to be. Let's implement a sort of working solution which can read the input and write the output, and then we'll figure out how to fix it. Okay, so system.out.printf. Why am I using printf? Well, because I'm going to be formatting a string. I'm going to be printing the hours and the minutes, and I also need the minutes to be padded with zeros if there aren't enough digits in them. Okay, so how would I write this format? Well, I have an integer over here, the digits of an integer, followed by a column, and then followed by the digits of another integer. But I want these digits of the second integer to always be at least 2 and padded by zeros. Okay, and now what do I need? Well, I need that integer, those integers. So the first integer is hours, the second integer is minutes. Okay, so let's see if this program works correctly. It won't work absolutely correctly, but it will get some of the job done. So let's enter some input. Let's say 0 and 0, 1, like we had in the second example. Okay, so we printed 0 column 31, and I don't have a new line over here, so let's add that, %n. Okay, so we know that part works correctly, but what part doesn't work correctly? Well, if I overstep the minutes, so if the minutes get more than 60, so if the sum over here gets more than 60, if I enter 159, for example, or even 131, or even 130. If I enter 130, 30 plus 30, actually the input is like this. If I enter 130, well, 30 plus 30 is 60. So if I press enter here, I get 1 and then 60, but there's no such thing as 60 minutes past 1. There's 59 minutes past 1, and then 60 minutes past 1 is 2 o'clock, right? 2 with zeros after it. So how do I calculate that correctly? Well, what would I do? I would need to check something. You know, if my minutes change in such a way, normally I just sum them up. But in some cases, they will, in half the cases actually, because in any case after 30, from 31 to 59 inclusively, what would happen is that I'd need to change not just the minutes but the hours. So when the minutes change above or if they become above or equal to 60, then I'd need to change the hours and to reduce the minutes by what? Well, in this example, with 160 would become 200. Okay, so what happened? Well, I increased the hours by 1 and I reduced the minutes by 60. Okay, so let's do that. Now, when do I need that? Only when the minutes are larger than or equal to 60. Okay, so if the minutes are larger than or equal to 60, I say minutes equals minutes minus 60, or I can shorten that into minutes minus equals 60, the same way I can shorten this one to minutes plus equals 30. Okay, and what else do I need to do? Well, I need to bump the hours. Okay, so hours plus plus. Okay, anything else? Let's test if this code works correctly. We start it, we wait a bit for it to execute, and I enter 130, and I get 2 o'clock. By the way, ignore this error over here. This is just an error coming from the debugging software in IntelliJ, or the debugging environment in Java. It doesn't really matter. All you care about is this green input and this black output. You have all the other messages you can ignore. Okay, so 2 o'clock, that's correct. Okay, is there a case in which this code won't work? Well, look at what I'm bumping. Like, when I'm bumping the minutes, there is a case in which I need to also bump the hours. Now, if I'm bumping the hours, I'm changing something else in my in the state of my program. So I'm changing the hours. Is there a situation in which when I change the hours, they aren't a valid number for time representation? Well, there is. If it was 23:30, so if I start this program and enter 23:30, what do I get? 24 o'clock. But there isn't such thing as 24, because the time begins from 0 hours 0 minutes and ends with 23 hours 59 minutes. So 24:00, that thing doesn't exist. We've gone to the next day, so 24:00 is actually what? 0000, right? So what I need to do is, after I've changed the hours, after this code has executed, if it has executed, I don't really care if it has executed, I just need to check, okay, so the hours here have changed, and now I can add another if statement. This if statement is unrelated to this if statement. It's just another check coming after it, which is, if hours are larger than 23, or if hours are larger than or equal to 24, then what do I need to do? Well, I need to reduce the hours by 24, the same way I reduced the minutes by 60. Now, in our task, I can just set them to 0, so I can just say hours equals 0, because I'm only adding 30 minutes. But if I want to be adding not just 30 minutes, but any number of minutes, well, then I'd probably need to subtract 24 from the hours, because we could jump up with more hours than a single hour. Okay, so it could become more than, let's say, 30 minutes past midnight. Okay, but in this case, it's completely sufficient to just know the hours, because I know that I can't get to 1 o'clock in the morning by just adding 30 minutes from the previous day. It's not possible arithmetically. Okay, so let's test this situation. Waiting a bit. 23, 30, and I got 0, 0. Okay, so seems like my program works correctly, and of course I should test with all of these sample inputs and try to think of my own sample inputs so I can test out my program sufficiently. But since we're in a lecture here, we won't be wasting that time for that too much. So the checks over here are pretty much the same which we had in our program, and the logic is pretty much the same. Okay, now in addition to branching using the conditional statement if, you can also do branching with the switch case statement. Now the switch case statement is usually applied to situations where you have a fixed number of values which you want to handle in a fixed number of ways. And you can easily count these values, and each of these values has a distinct way of being handled. Now what do I mean by that? Well, let's say we have a task where we get a day of the week entered from the console, like 1, 2, 3, 4, 5, 6, 7, and we should print the name of that day of the week. How would I do that? Well, using just branching the conditional statement if, what I do would be if day of week equals 1, then I'd print on the console system.out.print line, print on the console a single line containing Monday. And now if it isn't Monday, then it's going to be something else. What else could it be? Well, it could be Tuesday. So if day of week isn't 1 but it's 2, then system.out.print line Tuesday. And so on and so forth for all the values of the week. And after all the checks, I would have an ending else, so I would have other checks over here. So there would be other if day of week equals 3, if day of week equals 4, if day of week equals 5, and so on. I won't be writing all of these down. But at the end, I'd probably have system.out.println unknown. Because if someone enters 8 or 9 or -1, well, what should I print? I don't know. I don't know what day that is. So I should inform the user in some way that their input wasn't correct. Or maybe I should say, incorrect number, please enter a number between 1 and 7. Okay, so this is a way to solve that test, but it's a bit of a hassle. Why? Well, because I'm doing a lot of if-elsing. Now, since we're checking against specific values, exact specific values, what I can do instead is say switch, use this day of week as a switch, which has positions. That's where switch comes from. So this is my switch. My day of week is my switch, like a switch in a control room, a switch for something. Okay, and in the case in which the switch is in position 1, meaning day of week equals 1, then do the following and then break. Now, this break is very important and I'll explain it in a bit. Okay, so case 1, break. So if day of week is equal to 1, do some stuff over here. I'll implement it in a bit. And then stop, meaning exit this switch case statement. Okay, so break out of this switch, exit this switch. Okay, so the cases over here say that if this value equals this case, then start executing the code from here downwards. Okay, so what do I need to execute? Well, I'd execute system.out.println Monday. And then the other case would be for value 2, system.out.println Tuesday. And so on. And my final else, which is the unknown case, is handled by the default case. So anything other than the cases I mentioned here will enter this code. By the way, I forgot the break here, and I'll explain why I really need this break over here. So the default case would be system.out.println unknown, and another break again. Okay, so this effectively replaces the if-elses I had downward. Okay, so the if-elses I wrote previously are completely replaced by this switch case. Okay, so starting this code, what I'd get is if I input 1, I'd get Monday, if I input 2, I'd get Tuesday, and if I input anything else, I'd get unknown. Of course, there are other cases to be added here, but I won't be adding them now so we don't waste time on that. I think you understand the concept up until this point. Okay, so that's what switch case does. It just checks values of a variable against specific cases and executes the code following that label of the case. Now, why do I say that you always need to add break? Well, because if you don't add break like this, what happens is the code continues to execute. So let's say I remove this break over here. Instead of printing just Monday, this code will also print Tuesday. Why? Because that's how switch case works. Switch case just enters over here and starts executing code from here on out. It doesn't care about the other cases. So the cases are actually just markers which say start from here. Let's see this in action. So if I enter 1, instead of just Monday, I get both Monday and Tuesday. Why? Because Java saw that case 1 starts here and it just started executing code from here on out. It doesn't do any more checks. And the break I add, the break I want added here, is a signal to Java to get out of this switch and continue after it. So that's what break does. Now, in some cases, you do want to continue executing downwards, but in most cases you don't. So the way I suggest you write switch case statements is always case, then the case you want, and then immediately break, and then you can start creating the code you want to have handle that case. So always the case, then the dots, then the break, and then in between you add the code. Now in some cases, again, you would want to fall through to the other case, like we just demonstrated without this break. In some cases you would actually want that behavior, but in most cases you won't. So let's ignore that for now. Okay, so this is the switch case statement, and what it does is just handle a specific value of a specific variable. It's just an equality check. You can't use it for range checks. For example, if you're testing whether a person is less than 18 years old, you would need an if statement for that, or you would need to write 18 cases in a switch, which isn't really practical, and that's for a relatively small number. Let's say if you're checking a person whether they are 65 and older for some program which calculates something about coupons for, let's say, people which are in retirement, for example. Well, in that case, you can't really do that with the switch case, because there are a lot of switches and a lot of cases you need to write, which you need to handle. So if-else statements are used when you have range checks and other more complicated checks. Switch case statements are only used when you have very specific cases which you need to handle, like these months of the year we have over here. Okay, so we have a problem, which is if we're given a country, we need to, well, if we're given a language, we need to print the following countries for that language. Okay, so for English, we need to print England and USA, and for Spanish, we need to print Spain, Argentina, and Mexico, and for others, we don't know. So, if we get England, we should get English. If we get Spain, we should get Spanish. So this is a bit, the description is a bit in reverse of what the input actually is. So we get England and we print English, and we get USA and we print English again. Remember when I said that switch case has some situations where you actually do want to not have a break? Well, this is exactly one of these situations, because for two different cases we will be executing the same code. Okay, so let's do that. We're getting a language, we're getting a country. Since we're getting a country, we're getting, this is what? A string variable, a sequence of symbols. So here's a string country, which we're reading from the console. So country is equal to scanner, give me the next line from the console. Okay, and I'm switching my country now, and the switch for my country will be, if the country is England, then I'll do one thing. I'll figure out what that thing will be later on. I'll write out all my cases, and then I'll see how I can handle them, and I'll write them with breaks. Why am I writing them with breaks? Well, because I don't know how exactly I'm going to be handling it, and I already said that when I'm writing a switch case, until I figure everything out, I just place breaks everywhere. Okay, so what are the other countries? USA, then Spain, Argentina, and Mexico. Okay, so this thing, we get it copied, we paste it, we say Spain, then we say Argentina, and then we say Mexico. Okay, and do we have a default case? Well, if we get something else, we get unknown. So we should probably print unknown or something. Okay, so we can check that output, what it should exactly be, and in a well-described task it would be a bit more specifically stated, but let's print unknown like we have here. Only they had it with lowercase letters. Okay, so now what do we do? Well, we start printing. So for England, we do system.out.println English. But for USA, we do the same, right? So we do the exact same code. Now, since switch case can just continue on downwards, we can do this. Instead of breaking on England, we can just say, if the country is England, start executing code from here. And that will come over here, execute the print, and break then. Okay? And then if we get USA, it will still start from here and break then. So in both cases, we will actually execute the same code. And for Spain, Argentina, and Mexico, it's the same deal. So if it's Spain or Argentina or Mexico, then system.out.print of what's the language? Spanish. Okay. So that's the solution of this task. Now, one thing I still don't like about this program and about the one we had for the days of the week is that I'm repeating code. Where am I repeating that code? Well, I'm repeating system.out.println. So here and here and here, I'm doing a repetition of code. The only thing that changes is the string I'm printing. So whenever, as a programmer, you see something repeating, and if the repeating thing is a value, if a value repeats, what you need to do is extract a variable. So let's create a variable language, and now we'll just say, instead of printing it, we'll say that language equals English in this case, otherwise language equals Spanish, and otherwise language equals unknown. And then I'll have a single print after the switch case. So here is the beginning of the switch case, here is the end of the switch case, and now I'll have a single system.out.println and supply that language as a parameter. Okay, so now I eliminated the repetition of the system.out.println code, and it could have been longer code. This is just an example. It's not like this was a really big issue of repeating code, but the concept applies. If you see that a piece of code is the same and it only has its value changed, well, extract that value into a variable and then add the piece of code after the different values of the variable are determined. Okay, so now if I type in USA, I should get English, and that's what I got. Of course, I should test out this program a lot more, and I suggest you do that at home, but for now we're going to continue on with the lecture. Okay, so this is pretty much what we have in the slides for the solution for this problem. Okay, now, we've already seen the logical operators, the comparison operators, and we've seen how they can be used in if statements, in conditional statements. what we need to add to that are the logical operators. The logical operators are what allows us to combine true and false values into a single expression. So let's say that we had, let's say we have the following situation. We're going not to be reading countries from the input. We're going to be reading the age of someone and their money. What am I implementing? I'm implementing a bar. So we're going to be having a bar, and in this bar only people which have enough money and which are of legal age can buy a drink. It seems logical. Okay, so what I'm reading from the console is I'll read an integer, which is the money of the person. We'll not go into specifics of whether this is cents or something. We'll just have a hard limit on the price of the drinks. And this is the age of the person, scanner.nextInt. And what is my task? My task is to determine whether this person can buy a drink which has a price of, let's say, 50. 50, we don't say what. Let's just say 50. Okay, $50, for example. Okay, so the price of my drink is 50. And the age needs to be larger than or equal to 18 for the person to be able to buy a drink. So if I don't have the logical operators, how would I do that? Well, I'd say if money is larger than or equal to 50, if the person has enough money, and then if the person has enough age, let's say, if they are legal age, then I'll print system.out.print can buy. Now, if they aren't at least 18, I need to print that they can't buy. So this is going to be, let's say, get out. Let's say we're forcing this person to leave. Okay. And if their money isn't enough, we're also printing get out. So this is a solution to this task without using the logical operators. But as you see, first off, we're repeating code over here. In both cases, we're printing get out. And this code is using nested ifs just so it can check a sequence of things. And it does the same thing if one of the checks fails. So if one of these checks fails, it prints gets out. And in both cases, it basically prints gets out if one of the checks fail. So it's actually a single expression, right? Both of these need to be true in order for the program to print can buy. Otherwise, it will print get out. So this is a single expression. It acts like a single expression in our program. So what we have for handling such situations is, instead of writing a separate branching, so we can check each of these, and imagine if there are 3 variables or 4 variables we need to check, it would get even harder to read and to code. So what we have instead are logical operators. Logical operators combine Boolean expressions like this one, combine checks like this one, into single expressions. So if I want to say that their money needs to be larger than 50, and at the same time their age needs to be larger than 18, this is how I do it. Now, the AND operator requires both of these to be true in order for the entire thing to be true. So if one of these is false, the entire thing will be false, regardless of the value of the other thing. Okay, and by the way, if the AND operator works like this, if it sees that this is false, it's not going to execute this part. It doesn't care. If the first part isn't true, it doesn't need to evaluate the second part. It doesn't need to waste time evaluating the second part, because the entire expression will be false regardless of this value over here, if the first part is false. So this is called short-circuiting. Once it knows a result, it doesn't care from there on out. Now, if this is true, if this part is true, then it needs to check the next part, because that one could be false. Okay, so this is how we solve that task with the AND operator, the logical operator AND, and there's also a logical operator OR. That one is the less restrictive one. So that says if either of these is true, the result is true. Whereas for AND, it's if both of them are true, then the result is true. So if both of them are true, the result is true. Otherwise, the result is false. Here, the only way for the result to be false is if both are false. So the logical OR is sort of like a reverse of the logical AND, a reverse in concept. And in what cases do we need to use that? Well, let's say we want to check if the person has money, or they are of the correct age, and they're of the correct age, or if they aren't of the correct age, they may be getting, they may have a person with them, so someone which is of the correct age, which can buy them the drink or something like that. So if there's another person. So in cases in which if either condition suffice, that's when we use the OR statement. Okay, and in addition to that, there's also the logical NOT statement, which just reverses a value. So if a value is true, it reverses it to false. Okay, so we have a task over here which requires us to check theater promotions. Well, how do they work? How do these promotions work? Well, if the day is a weekday, we use this part of the table. If it's a weekend, we use this part of the table, and if it's a holiday, we use this part of the table. So what does it look like? This over here is what? These are 3 fixed values, exactly 3 fixed values. And in each of them, we have different handling for different ages. So we have a weekday, we have a day, or whatever we call that. We have a day, and we have an age, which are entered. Okay, so for one weekday, for one day value, we have the check of whether the age is larger than 0 or less than 18. And then we have the check for between 18 and 84 and 64, and then we have the check for between 64 and 122. Okay, so how does this look like? Well, to me it looks like a switch case, in which the first case would be weekday, and then in that switch case I check the age for being in one of these ranges, and since I'm having ranges, what will I be using for the check? Well, I'd be using a conditional statement. Okay, and in each of the checks I just determine the value of the price of the ticket. Okay, how do I do that? So let's say we have the string for the day entered. So we have a string day, which is scanner dot next line, read the next line, and then the age is scanner dot next int. And what do I need to do? Well, I need to switch on the day. So this day is going to be in my switch, and I'd say if it's, by the way, it's not exactly clear whether these are capital case or lowercase or capital case or whatever they are. One way to check without caring for lowercase or capital case and so on is just switch the day, but not exactly the day, but the day dot to lowercase, which will convert this day to lowercase symbols, and then each of my switches will just be a case lowercase, in this case weekday with lowercase. Okay, and then I add the break here, and then I have a case for weekend, and then I have a break again, and then I can have a case for holiday, and then I have a break again. And I probably have a default value which prints, for example, no such result. Okay, so what do I do for these? And I forgot the break over here. So what would I do here? Well, if it's a weekday, now I just need to check the age. If the age is between 0 and 18, then I need to say that the price is $12. Then I need to say, well, if it's larger than 18, then the price is $18, and so on. Okay, so how would I do that? Well, that's simply a sequence of if statements. If the age is larger than or equal to 0, and now there are two checks. The age is larger than or equal to 0, and it also needs to be less than or equal to 18. So it needs to, we can't just check if it's larger than 0, we need to also check if it's less than or equal to 18. So how do I do that? Well, how do I combine checks in Java? Well, I use the AND operator if I want both of them to be true. So, and if age is less than or equal to 18. So this would give me a price of $18, right? That actually $12, sorry. That's what I have in the table. And the next check will be else, if the above isn't true, if the age isn't within that range, but it is within the range of age being larger than 18. By the way, why am I adding this, since the age is definitely not in this range? Well, I'm adding it because someone could have entered -1, and that won't get into this check. Okay, so if the age is larger than 18 and the age is less than or equal to 64, then I'd be printing out the $18 tax. And so on. I do the last else for if age is larger than 64 and age is less than 122. Okay? And then I'd be writing some code for the $12 tax again. Where are my dollars? Here are they. Okay, here they are, actually. Here are my dollars. Okay, so of course this isn't the actual code. This would be printing to the console or setting a value to a variable, which I'd prefer, and then printing that value on the console over here. Okay, and we need to do the same for the weekend, and we need to do the same for the holiday. I'll leave that to you to do at home. So I'd expect you to handle this. Oh, and here we have what happens if there's a negative value. So we need to print error. So there's going to be a last else over here, right? So in this else, there's the case error. So in this case, we need to print error like this. So what I do is create a string variable, which is string ticket price info or something. I will intentionally not give it a value, and I'll give it a value in each of these places. So in this case, it will be ticket price info equals $12 as a string. And I do that the same for 18, and I do that for error too. And now, if I go over here and print it, system.out.print line, and provide ticket price info, notice that it underlines it as an error. Why does it underline it as an error? Because it might have not been initialized. Why might it not have been initialized? Well, because I'm not initializing it here, 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 and in each of these cases, I'm not initializing it. So in this way, you're ensuring that there's always a value for ticket price info. So in this way, you're ensuring you're not missing a case, basically, because everywhere you need to set a value to ticket price info, otherwise your code won't compile. And that's how you know that you've met every condition correctly. Otherwise, if you miss it somewhere, for example, we miss it here, well, this will be a compile time error. You won't need to start your program to find out that it doesn't work. The program will check for itself and see, okay, you haven't given a value to this, and I can't print it. And you will just find where you haven't given a value to it and fix that. Okay, so I'm leaving this to you to finish up. They're just the same checks done over and over again. Okay, so this is the code for the solution. You can check with it if you don't manage to solve it. By the way, this code is different than what I just wrote. It's if-else checks, so that's fine too. But since we have fixed values, I use the switch case. So play around with one of these two solutions and write them yourself. By the way, any task we encounter here, you really should solve by yourself. It's really important, even if you've seen the solution, to write it by yourself and try to not look at the solution while you're writing it. The only way you become a good programmer is by programming. There is no shortcut. There is no way you can just listen and learn. It's just writing code. You just need to write a lot of code until it becomes so intuitive that you don't really need to think about the more simple concepts like how do I write a conditional statement or how do I write a loop, which we'll be talking about in a few moments. So really do the tasks which you see in the lectures and do them by yourself. Now, if you can't manage it by yourself the first time, help yourself with the code which is in the slides and see what you missed, see why you didn't think of that, and then do it again, and then do it again until you manage to do it. Not by learning it by heart. Don't learn it by heart. Don't learn which part of code follows which part of code. Learn to think. Learn to examine the problem as a collection of parts which you need to assemble together and which you need to build. You need to build each part and then assemble these parts together. That's how you solve programming tasks. Anyway, now we already saw how to branch our program, and that's a very important part in coding in order to have something more complex than a calculator and something that actually reacts to input. But how do you handle code which needs to execute multiple times? So let's say you want to print the numbers from 1 to 10. Well, what you do is you use a loop. Now, you'd probably say, okay, well, I can actually print the numbers from 1 to 10 without using a loop. I can just, let's get rid of this code. I can just say system.out.println1, and then I could do print line 2, and then I could print line 3, and then I could print line 4, and so on until I reach 10. So that's a valid way of printing the numbers from 1 to 10. So what do loops give me? Okay, so they're another part of Java and of programming languages in general, which allow me to repeat some code. But why do I need to repeat code with a loop when I can do it manually? Well, first off, manually really doesn't, look very well, because you just have repeating of code and repeating again and again and again. And second, it actually can't achieve everything you want. So if you don't have a loop, you have no way of reading a number and executing a piece of code that number of times. Like, I guess you could do something like read a number and number to which we want to print. So max number. So let's say we read that max number from the scanner, and then we print until we reach the max number. So you could hack it. So you could say int current number equals 0, and then if current number is less than max number, well, system.out.println print that current number, and then increase that current number, and then write another if, which is exactly the same, and another if which is exactly the same, and another if which is exactly the same, and so on, and so on, and so on. But do you know when you need to stop? Well, if you know what the max number could be, and let's say if it's 100, you could repeat this if statement 100 times, and yeah, that would probably solve the task, because none of the following if statements will execute. You will only execute as many if statements as increments you'd need. But that really isn't ideal, because that's only if max number is 100. Well, if it's 1,000 or 100,000 or 4 billion, that this could be a very large number. So, and it's really hard to write code which executes a fixed number of times in the program. Also, it's not efficient. If you have 4 billion as the maximum possible number which could be entered on the console, you need 4 billion ifs, which would create a pretty large program. But in addition to that, running that will always do the 4 billion operations. Whereas if you do it with a loop, with a structure in Java which allows you to execute a variable number of times, variable meaning a number of times coming from a variable instead of non-compile time like this code is, that loop will only execute as many times as you need instead of 4 billion each time. Okay, so loops are actually if statements that repeat themselves. So a while loop, let's use the while loop. A while loop is just what we wrote previously. So the multiple ifs chained one after another. So we had an if, and then we had another if, and then we had the same if, and the same if, and the same if, and the same if, and the same if, a lot of times. Well, that's exactly what a while loop is. Oh, however, you don't write it multiple times. You write it exactly once. Oops. Let's return to the while loop version. Okay, let's delete this if. Now, instead of writing multiple ifs one after another, you just write while. What does while do? It checks for the condition, just the same way an if statement does, and executes the code if that condition is true. But then, instead of continuing the execution of the program after the end of the body of this while loop, it returns to the condition again. The if statement doesn't return to the condition, while the while loop returns to the condition. So the while loop is exactly the same as the if statement. However, instead of continuing on, it returns to the condition. And the while loop has no else, obviously. Okay, so it returns to the condition and checks the condition again. Now, if we read a number like this and we start this program, what would we get? We'd get the number starting from 0 up until that number printed out, up until less than that number actually. So if I enter 4, I'd see 0, 1, 2, 3. So here's what I get. I enter 4, I got 0, 1, 2, 3. Again, only focus on the dark part of the output, ignore these blue messages from the debugger. Okay, so that's what that's what a while loop is. It's just an if statement which repeats its check until the check becomes false. As opposite to the normal if statement, which just calculates the expression once, and if the expression is true, it executes it. So yeah, an if statement that returns to the check. So that's how while loops work, and they're the simplest type of loop. So what are loops actually? Loops are so-called control statements, the same way that the conditional statements, if and else, are control statements. They control the execution of your program. An if statement branches your program and does one thing or another thing, whereas a loop does one thing if the condition is true, and then repeats to check the condition, and if the condition isn't true, then it breaks out of that loop. Okay, so that's what a loop does. And there are several versions of loops. The most popular version of a loop is the for loop. The for loop is actually a bit more complicated version of the while loop, meaning it's a while loop, but it has an initialization and an increment automatically added into it, whereas the while loop, you just continue on until something happens. So for loop, those are generally used for doing something a fixed number of times. Like in our case, we have a fixed number of executions which is clear at the moment of input. So when the user enters this number, we need to execute our code that amount of times. So a for loop is ideal for that purpose, whereas while loops execute until a condition changes to false, which is what the for loop also does, but the for loop is sort of designed for fixed number of times iteration. And the for loop and the while loop are completely interchangeable. You can do anything with the for loop with the while loop and vice versa. And there's also the do while loop, which is only different from the while loop by the fact that it always does something and then it checks. So it will execute at least once. So in our case, a while loop will first check the number, whereas a do while loop, do while, and the while goes after the body of the loop. If we now enter 0, the do while loop will print 0, whereas the while loop will not print 0 because it will immediately check this and not enter the loop. So if I start this, the do while loop will print, if I enter 0, it will print at least 1 0, meaning it executes at least once, whereas the while loop, the simple while loop, will not print 0 because it will immediately check, okay, current number is equal to max number, so it isn't less than max number, so this is false, so we continue on after the loop. Okay, let's test that and see that that's how it behaves. We enter the number 0 and nothing gets output on our console. Okay, so that's the difference between the while and the do-while loops, and do-while loops aren't really that used. The main usage of loops concerns while loops and for loops. Do-while loops they're a bit weird to read, and that's part of the reason they aren't used a lot. It doesn't mean that you shouldn't use them, but in most cases you would find yourself preferring the normal while loop. Okay, because in most cases you actually need to do a check before you do something. Well, just like the if statements. You don't do something, then do the if statement, then do it again. That's what the do-while loop does. There are some specific situations in which you would want a do-while loop, but anything you can do with a do-while loop, you can also do with a while loop by just repeating the code in the while loop's body. You know, this code right here is the exact equal to the code do while and leave only the method, the loop body, do while and so on. So your main approach to writing loops will be either write a while loop or write a for loop. Now, what is a for loop? A for loop is just something that is built to execute a fixed number of times, starting from an initial position and ending in a specific position, and doing that and incrementing the variable it uses to iterate on each execution of the for loop. So a for loop is just this while loop, which we just implemented, is absolutely equivalent to writing the following. For int current number equals 0, current number less than max number, current number plus plus. And I'll unzoom a bit and hide these a bit. Okay, so actually we don't need this project pane at all, so I can hide it. Okay, so now it highlights the current number over here because I've already have a current number initialized up here for the while loop, so it can't allow me to create the same variable name. But otherwise, if this while loop didn't exist, this code over here is absolutely identical to this code over here, with one small exception. The current number variable here declared here is visible after the loop finishes, whereas a number initialized inside the for loop is not visible outside the for loop. So this exists for the entire execution of the for loop, but it's not accessible outside it. Okay, so this is a for loop. A for loop has an initialization, it has a check, and it has an incrementation. And this part is executed last, after the body. Just like it is executed last over here in the while loop. The body is before it, so here we have the body, and here we have the for loop's body, and this current number plus plus is executed after the body executes. And that's how the for loop works. The point of the for loop is when you have a specific range of values which you need to iterate, that's how you do it. The typical way would be to do a for loop. You use a for loop whenever you know the number of iterations and it doesn't change, whereas a while loop you do if you need to execute operations on some data until that data changes in some way. Okay, so that's the for loop, and this, of course, I'm missing the printing part, the actual body. Now, this code is exactly equal to this code, with again the exception that the current number initialization over here is only visible inside the for loop if it's a for loop, whereas the current number initialization here is visible in the entire main method. Why? Well, because it's outside the while loop. Okay, so that's how the for loops work. You have initialization, which gives the initial value of the so-called control variable of the loop. Then you have a check. This check can be anything. It usually is a range check. It checks whether the control variable is less than something or larger than something. And this part usually increases or decreases the control variable, but these two can be anything. This can be any expression, which changes the control variable, or it can be no expression. You can miss this entirely, In that case, your loop will probably never finish, but you can. And this part over here can be any Boolean check. Just like you can add any Boolean check in an if statement or in a while statement, you can do that in a for statement over here. So any check over here is valid, but usually your check will involve the control variable of the loop, and will probably include a range check for that control variable. Okay, so let's print all the numbers that are divisible by 3 and all of them from 1 to 100. How do we do that? Well, it's a pretty simple task. We can do it with a while loop and we can do it with a for loop. So how do we do that? Well, we have our current number. Let's ignore this max number, or we can just say max number is 100, right? Because we're going from 1 to 100. Actually, since we're checking like this, let's say 100 plus 1, because we want to reach to before max number, just like we're doing over here. Okay, so until we reach max number, how do we print those which are divisible by 3? Well, we simply do if current number divided by 3 gives a remainder of 0, so that means it's divisible by 3, because 3 divided by 3 is 0, and 3 divided by 3 gives a remainder of 0, and 6 divided by 3 gives a remainder of 0, and so on. So that's our check. And what do? We just print the current number. We only print the current number if it is divisible by 3. If the remainder when it gets divided by 3 is 0. Okay, and how do we do that with the for loop? Well, we do the absolute same thing in the body, but we have the initialization inside our for loop and the incrementation inside the for loop instead of at the end of the body. And our task wanted us to print everything from 1 to 100, not from 0 to 100, so current number would start from 1. So this is the while loop solution, and this is the for loop solution. And since it includes the max number 100, I'd actually prefer not doing the plus 1 over here, but actually doing less than or equal to max number over here. Now, you've already seen loops in one way or another up to this point, so we won't be chewing on them much more, but here is the solution to this task. We have 3, we have 6, we have 9, because that's how the for loop works. On each iteration, it increases the current number and then checks. Actually, it starts from the initialization, so it starts from current number equals 1, then it checks the condition, and then it goes to the body. And then it increments the current number. So this part is last. So if you write a for loop like this one, it would be exactly the same if I remove this current number incrementation from here and place it at the end of the body. It's absolutely the same. That's what Java does. It takes the code you have over here after this semicolon and places it at the end of your body. That's effectively what it does. Okay, so this is what our for loop does, and you can achieve the same result with a while loop, just as I showed you a few moments ago. Now, instead of writing an entire for loop, what you can do is you can say for I. You can just type in for and then use the suggestion for I, press enter, and this creates a for loop for you. And then you can just fill in the blanks which it left behind. Now, my suggestion is don't use the auto-generated code. Write the code yourself, because you need to be able to write a for loop without thinking. It should be automatic. The same way when you're learning to drive a car, your driving should be automatic, as in turning the wheel, pressing the accelerator pedal, and so on. So for now, try to type a lot, because typing a lot, first of all, increases your speed of typing, which is important when you're in a hurry. And second, it teaches you to not think when you're implementing loops and conditionals and so on. It needs to be automatic for you to write code quickly. Okay. So when you type in for I, if you're in a hurry for some reason, you can use this template for live generation of a for loop. Okay, another task. We have a program which should print the first n odd numbers and then print their sum. Okay, how would we do that? Well, since we're doing n odd numbers, that's a fixed number of odd numbers. Okay, so how would we do that? Well, my solution would be the following. If I get 5, I know that I need to execute my loop 5 times, so that's what I'm going to control based on. So I'll start from the 5 times execution, and then I'd figure out which the odd numbers are based on where I am in my execution. So what does that mean? That means that if I have n entered from the scanner as an integer, what I do is I'd start a for loop which simply executes n times, meaning it will start from 0 and end at n. Okay? And how do I handle it from here on out? Well, I need to find that odd number. How do I find that odd number? Well, there are a lot of ways to do it. One thing I can do is keep track of the current odd number. You know, have this current odd number, and which is the first odd number? It's 1, right? And what did I also need to keep a track of? I need to keep a track of the sum. So I need a sum, which starts from 0, and the current odd number, which is 1. And for each iteration, what I do is I'd say the sum is increased by the odd number, meaning that we add the odd number into the sum. And then the odd number needs to change, right? I need to go on to the next odd number. So how do I go on to the next odd number? Well, I just say odd number plus equals 2, meaning increase odd number by 2. Why? Well, because odd numbers are 2 apart. So 1, 3, 5, 7, 9, and so on. So getting from 1 to 3 is an increment by 2. So I increase the odd number by 2. Oh, and I also need to print that odd number. So system.out.println that odd number. Now this is one way. Another way is to just use the mathematical formula. So what would the mathematical formula be? Well, I have I, and I times 2 plus 1 will give me that odd number. So for execution 0, I will have 0 times 2 plus 1 equals 1. For 1, I'd have 1 times 2, which is 2, plus 1 equals 3. And then for 2, I'd have 4 plus 1, 5. And then for 3, I'd have, you get it, 6 plus 1, 7, and so on and so forth. So that's another way to do it. And again, how did I think of this that quickly? I haven't thought about the solution before I just saw the task. I just thought it up on the spot. How did I think it up on the spot so quickly? Well, I have implemented a lot of loops. At some point, you just get an intuitive feeling for what the loop should do. You just need to solve a lot of these programming problems. And initially, it's going to be a bit slower, but from then on out, you will start figuring it out. But the main thing you need to do is focus on the number of executions and determine your operations based on that execution on which you're on currently. Okay, so this will solve the task, and I can print the output system.out.println. I already printed the number, and now I only need to print. I'd actually print formatted, and that format will contain sum column and then the digits and a new line of that sum, which I just calculated. So starting this again, I will enter 5, just like we have in this example. So I'm entering 5, and I see 1, 3, 5, 7, 9. Okay, that's 5 executions, correct? And the sum is 25, and as they have described for us in this PowerPoint slide. Okay, and I test for 3 and so on, but I won't be doing it now. Now, what I'll show you, in addition to this solution, is a for loop can have multiple initializations, and it can have multiple increments. So, what I can do is, since you see that I'm using that odd number too, it changes the same way the control variable of the loops changes, right? It increments on each iteration, and it increments at the end. We've already used it. We can consider this part the body, and this part the increment, we've already used it with its value, and then we increment it the same way we do for I, right? And the initialization is only once again the same way we initialize for I. So what I can do if I want, although this is a bit harder to read and I don't really suggest you do it, but you can. So if you initialize I like this, you can also place a comma here and initialize odd number here equals 1 and remove it from over here. No, or maybe I misled you. Okay, so maybe we can't, oh, no, we should be able to, let's see, yeah. You place a comma over here, and then you initialize another number of the same type. That's your limit. You need to initialize variables of the same type. So you initialize I with the value of 0, and you initialize odd number with the value of 1. And over here, we can do odd number plus equals 2. And you can remove it from here. So, summary, you can add multiple initializations and you separate them with a comma, but they all have to be of the same data type. And you can do multiple increments and you separate them with a comma. Now this is a bit harder to read, but I demonstrated what it looks like by writing it the first time. Now I just compacted it into the for loop. None of these is faster or slower than the other one, or at least not significantly so based on the input. So my suggestion is use the first option if you're going to solve this task in this way, and avoid multiple initializations in a for loop and multiple increments in a for loop. But keep in mind that you can do this. So I'm showing you this way of coding a for loop because you might encounter it somewhere, not because I'm endorsing you to do it. My suggestion is don't. My advice is keep the body a body and keep the increments only for the control variable of the loop. Okay, so that's how our for loop works. And let's continue on. We solved this task. Let's continue on to whatever we have next after this. So I already introduced you to the while loop, but just to recap, a while loop is something that executes until a condition changes. So it executes while a condition holds true. In this case, this condition will hold true 10 times. Why? Well, because n is 1 and the condition is n less than or equal to 10, and n gets incremented in the while. Now this is the equivalent of a for loop, which starts from I equals 1, continues until I is less than or equal to 10, and has an I++ in it, and does system.out.println does this operation over here. That's a while loop, and while loops are usually used when you operate on some piece of data until it changes. For example, one thing you can do with a while loop, for which a while loop is good, is printing out the digits of a number. So how do you print out the digits of a number? Well, let's do it. It's an interesting task. So let's read the number from the console. Let's call it number. And let's read it from the console and let's print out its digits separately. So we want each digit on a separate line. Now, starting from the last digit. So if we get the input of 142, what I want printed is 2, then 4, then 1. So print the numbers in reverse. How do we get that? Well, we can do the following. We can say, while that number is larger than 0, we will do the following. We will tell the number to give us the remainder of that number divided by 10. What is the remainder of a number divided by 10? Well, that is the last digit of the number, because in our numeral system, our decimal numeral system, what happens if you have 142? If you divide it by 10, that gives you what? 14. 10 multiplied by 14 equals 140. And we have a remainder of 2. So 10 times 14, 140, plus 2 equals 142. Okay, so this is the remainder. So 2 is the remainder. If we do 142% 10, that gives us 2. Okay, and then if we say 142 divided by 10, that gives us 14, and we've just removed the last digit. So using %10 gives us the last digit, and dividing by 10 removes the last digit. So it removes this 2. So this operation of division removes the 2, and it leaves us with just 14. So what can we do? We can repeat this operation now and do it for 14 and get by 10 the remainder when it's divided by 10, and that would give us 4. And then we do 14 divided by 10, so we get 1. And then for 1 we do get the remainder for division by 10, and that would be 1. And then 1 we would divide by 10 and we'd get 0. And for 0 there is nothing more to do. We stop it here. So that's why I said, well, we will start a while loop which continues until the number reaches 0. Now there is a catch here. We need to have an additional check. If the number starts from 0, we need to print 0 because the digits of 0 are 0. So there would be another check over here which says if number equals 0, then just system.out.println 0. Print at least one digit for this number. Otherwise, if it isn't 0, just start printing the digits. So, while number is different than 0, while it's larger than 0, and that would work for positive numbers, of course, but it would actually work for negative numbers too. It's pretty much the same logic. You can test it out so you can see for yourself. Okay, so the last digit is the number divided by 10. And from here on out, what do? Well, we print that last digit, system.out.println the last digit. And now we need to change the number so we get rid of the last digit. We already got it and printed it. Now we want to get rid of it. So we just say number becomes number divided by 10. And if I start this program, it will continue until it displays all of the digits of number, and then number will reach 0, and the while loop will stop. So if I enter 142, I just got 2, 4, 1, and the program ended after that. So that's how you split up a number by its digits, and that's useful for when you need to convert it into, for example, a string, or if you want to encode its digits in some other way. Okay, so that's usage for the while loop. While loops are usually used when they process some part of data, some part of information, some piece of information, and change it in some way, so they need to recheck what happened to that information. That's a pretty vague description, but we need more specific tasks so we can see more specific examples of that. Okay, so we have another task over here. We need to implement a multiplication table. What do we need to do? Well, we need to display the multiplication of a number by its multiplier. So we have a number we read from the console, and then we need to display all multiplications of that number from 1 to 10. Well, how would we do that? I'd actually do that with a for loop, not a while loop. But we can also do it with a while loop. We read the number. We start from times equals 1 and continue until times reaches 10, and then just print the number, the multiplier, and then the number multiplied by the multiplier, and then we need an increment somewhere over here, right? Because right now, does times change? No, it doesn't. So this code will actually execute an infinite number of times. This code over here has a bit of a catch to see if you're paying attention. So this code will execute an indefinite number of times because we aren't incrementing this times variable. So there should be a times plus plus somewhere. I'd add it at the end of the while loop. Or I just use a for loop which starts from times equals 1 and reaches times less than or equal to 10 and does times plus plus on each iteration. Okay, oh yeah, so here's the catch actually. I showed the part of the code up to here, and then here's the catch. If you don't do the times, this loop will execute an infinite number of times. Here, however, since we're incrementing the multiplier, and that's what we check for the range, well, that's the reason this while loop will actually terminate at some point. Okay, so that's one way to do the multiplication table. Again, I'd prefer the option with using the for loop. Okay, and the do while loop is just something that does operations regardless of, so it's the same as a while loop, but it always executes at least once and then it checks, and then it executes again, and then it checks and executes again and checks and so on. Whereas the while loop first checks and then executes. Okay, so we have another version of the multiplication table where we have the number of multiplications we need to display is entered from the console, and this is pretty much the same task but done with a do while loop. So this will always print at least once. So even if you enter times starting from 10, you would still see actually times starting from 11. If you enter times starting from 11, this do while loop will execute once and display the number multiplied by 11, whereas the normal while loop will not do that. And it really depends on what task you're solving, whether you really want that printed or not. Actually, our example with the with the division continuing until the number reaches 0, the case for 0 can actually be omitted if we change this into a do while loop, because for 0 it will still print the last digit. So you can play around with making this into a do while loop. That's one application of the do while loop. Okay, so now once we've talked about loops enough, we have the finishing part of this lecture, which is how do we debug code. Now, what is debugging actually? Now, we've done it in this lesson already. Debugging is the process of finding errors in a program and fixing them. And it's pretty important that you notice the first part of debugging. As I said, finding errors. A lot of people, when they start learning programming, start by trying to fix an issue. You know, you write a program and it doesn't work, and your immediate thought is, I didn't write something correctly, let's change this line of code. But you still haven't actually found what you didn't write correctly, what you didn't code correctly. So always keep in mind that there is no such thing as a correct and incorrect program. There is a program which does what you want it to do, and there's a program which doesn't do what you want it to do. Programs always do what you told them, so they do exactly what you wrote, but that doesn't mean that you wrote what you needed to write. So where am I going with this? Well, when you have some code execute and it doesn't behave the way you expected, the reason for that is that you didn't code it correctly. So you shouldn't start changing stuff. You should find why does it do what you don't expect it to do. So when you're searching for errors in your program, you're actually searching for code which you entered, which does something different than the thing you expected for it to do. So programs don't make mistakes. Programmers make mistakes. So don't think of your program as something that's doing something wrong. Think of your program as something that is very explicitly following your instructions and doesn't really know what it should be doing. The program just follows instructions. It doesn't understand what it means to solve a problem. So when you want to debug your application, when you want to find errors in your application, what you need to do is find out which part of your code doesn't behave the way you wanted it to behave, meaning which part of the code you didn't implement correctly in relation to what you wanted to happen. So for your first part is finding where the error is. So actually the first part is noticing that something isn't correct in your, for example, output, and then you need to find which part of the code causes that error in the output. And when you know that, you can start fixing that code. And always when you're fixing something, think about, if I change this, will I affect something else negatively? So any change you make to code that already exists, you need to consider whether that change will break something else in your code. And after you've done the fix, you start testing, and in addition to testing whether you have fixed the problem you noticed, you also have to test everything else which you know works, because you could always have broken something that previously worked with your fix. And debugging is pretty iterative and repetitive, and you just do it. There's a joke in programming that 90% of the program is written in 90% of the time, and then the other 10% of the program is written the other 90% of the time. So you always waste more time than you expect, because you have debugging, because you can't foresee what errors you're going to introduce into your code while you're writing that code. So always leave yourself a lot of time for debugging, even if you're very sure of what you're coding. So there can always be bugs. You by the way, you probably have noticed that in the tasks we solved, I repetitively missed adding the new line symbol at the end. Now, that's a small issue, but it's still an issue, and I saw it, and I knew what was causing it, and I fixed it. So even if you're an experienced programmer, you will still be doing debugging. Debugging is 50% or more of the work of a programmer. Writing code is fast, actually. Once you get the hang of it, writing code is fast, debugging isn't. It's just something you get better at, because you start getting better at finding errors. That's the slowest part of debugging. And once you get faster at that, fixing them is a bit easier, but it's always going to take time. So don't get disappointed if initially you're having a lot of issues debugging your code and writing programs that work correctly. That's actually good for you, because you will teach yourself debugging. No one can really teach you debugging as a concept. We can just show you what it is and how you do it and how you can use the tools in IntelliJ to do that. But it's really up to you to do a lot of debugging and examine the state of your program a lot of times in order to find errors, so you can really learn how to effectively debug your code. Okay, so IntelliJ has what's known as a debugger. Now, what do debuggers do? Unfortunately, they don't fix your errors automatically, but what they do, it should really be called a state examiner. A debugger is something that examines the state of your program. So if I place a breakpoint over here and I start my program in debugging mode, that starts the debugger, and that will stop the program at this breakpoint after I enter my input, because there is no breakpoint up to this point. So I enter my input, which is 42, and the program stopped over here. Now I'm in the process of debugging my program. Now, again, it really should be called examining the state of the program during its execution. A debugger is simply a tool which can stop your program while it executes, and it can display information about the data in your program. So in our case, this IntelliJ process seems to have failed for some reason. But what we do is we place breakpoints, and once I think I know what caused the failure over here. Let's start it again. Once we have some state in our program, in this case the state is all of the variables that are visible at this breakpoint, we can examine that state. So if I had an error, well, what's the usual case for an error? Well, some of the variables which I have don't have the correct value. That's what an error is. In programming, an error is simply a variable in your code does not have the correct value that it should have had at that point. And once you find which variable that is, you just check what changes that variable and where did it get that wrong value, and then you just start searching. So you notice one variable that isn't correct. Okay, you see how that variable is calculated, and then you see the variables which are used for its calculation. Then continue on to them and examine at each step, and at each step again, and at each step again, and see if you find something that isn't correct in the code itself. And you usually find that by just looking at values of variables. You think of what should the value of the variable be at this point of the execution of the program, and if it isn't that value, well, what causes it? And then you find the code which causes it and you fix it. Okay, so what does the debugger offer you? Well, it offers you this exact thing. It offers you examining values. Now, a moment ago, my debugger froze. Why did it freeze? Well, because I had a line which I added in the start of the lecture, which was scanner.next, right? I had this in the variables over here as an expression which gets evaluated. Well, the debugger froze because it couldn't evaluate this because I wasn't entering any input, because this reads from the console. So be careful with expressions like this one. I'd suggest that you don't add something that reads from the console directly as a variable here, but definitely use the variables which are already listed. These are the values of the variables you're looking at right now. Now, if I place a breakpoint over here and press F9, we will reach this breakpoint, and I will also have another variable over here which is last digit. So if I had an issue with my code which was finding the digits of my number, well, I'd look for it here, because if I wasn't getting the digits correctly, let's say if I didn't do the correct division, then I'd see that last digit was 0 if the division here was non-remainder division. If it was just division, I'd see that the last digit is 0, and I'd ask myself, okay, so number is 42, and I'm dividing it by 10 and I'm getting 0. It's actually not 0, it's 4 in this case. It would be 4. So last digit is 4, and I'd say, okay, so I have 42 and I'm dividing it by 10. Why am I getting 4? Well, I'm getting 4 because that's what I'm telling the program to do. I'm telling it to just divide by 10, which is 4. But what I actually want is to get the remainder of that. So that's one way I can find an issue. If I had an issue over here, if I had used the incorrect type of division, well, that's how I would find it. And if I had used the incorrect type of division over here, or if I forgot how to if I forgot to add this line, well, I'd add a breakpoint over here and I'd say, aha, so I'm not reducing my number if this line was missing. And so on. That's the process of debugging. Debugging is just placing breakpoints, telling your program to continue to the next breakpoint, and examining each variable. Is the variable which I'm looking at containing the correct value it should be at this point of the program? And if it isn't, what's causing that? And if I can't find it on this run, since I've skipped over it, well, I stop it, and then no, okay, this variable didn't get the value correctly, so I'll place a breakpoint earlier. If here it was already with the wrong value, well, I'd probably need to look for the reason for the wrong value in the start of the program. So that's what debugging is. It's just jumping around places in your code, using the debugger and navigating between breakpoints. How were we doing that? Well, we place a breakpoint where we want the program to stop, actually to pause, and then we just continue on to that breakpoint. If it's the first breakpoint, we just start our program, enter our input, and so on. And then when the program stops at the breakpoint, we examine the state of the code in this variables window. Notice, by the way, that when you go into debugger mode, the console gets hidden. This is the console. There is a different tab for the console, and you can go back to it by clicking on this tab down left here. Okay, so you can switch between console and debugger through these tabs. Okay, and then you check in the variables window what variable has what value. And you can even write expressions. I showed you that you can do, for example, number plus 10 and see what that does. Okay, so this is what debugging is. It's simply going around in your code, checking values of variables, and deciding, is this value correct? And if it isn't, how can I fix it so that it can become correct? Okay, so that's what we need to know about debugging, at least up until this point. Now, another thing which would be nice for you to know. If you start a program and that program doesn't finish, for example, that would probably mean that you either are waiting for input somewhere or you have an endless loop somewhere. Now, one thing you can do is use this pause function. What that does is navigate you to the current position in the Java execution where the program is located. Now, once you do that, notice that we ended up in some file input stream class, and we got paused over here. Okay, so how do we find where that is in our code? Well, we go back to the debugger, and you look at this frames window, the left part of the debugger. And all of the yellow text here are internal Java functions. The first non-yellow backgrounded text is the place in your program where this is located. So if I click here, I can see that, so this read bytes function which I was sent to earlier is part of scanner.nextInt, because look, in main, someone called nextInt. That's how the sequence of calls in programs work. We will discuss that in detail when we get to talking about methods. But this is how the sequence of operations works. You have main, and then on top of that you have the call to nextInt, and that calls something else, and that calls something else, and so on and so on and so on. And if you pause the code somewhere like we did, you get to the bottom of where it was paused, where it's waiting for input in this case. And if you want to find your part of the code, you just find the topmost white background in these lines and select that, and that would navigate you to the position where you stop the program. So if you're searching for which while loop didn't end, well, if you're seeing a program which you've entered all the input and it keeps executing it and it doesn't print anything, you probably have an endless while loop or for loop or something. And then you just examine with the debugger, you pause the code and you see where you're located. And then you can figure out, okay, so why doesn't this end? Well, what are the variables, what are the values of the variables currently? What should they be? Which variable doesn't have the correct value? Why is it getting that incorrect value? And so on. Okay, so IntelliJ has this debugger. It has these breakpoints which allow you to tell the program to stop at certain location, and it allows you to trace what happens after what, meaning you can jump around breakpoints. There are also other features like jumping over parts of code and jumping into parts of code, but really you would mostly be using the breakpoints. At least that's what I do. I just place breakpoints where I want my code to stop. And the most important aspect is it allows you to inspect what values you have in the variables at that point in time. Okay, so there are shortcuts for starting without a debugger. Over here you have this button starts without a debugger. This will not stop at breakpoints. The bug symbol over here will stop at breakpoints. This is starting with the debugger. Okay, so F8 would just continue your execution of the program from the position you're located. You can add stuff like conditional breakpoints too. So you can add a breakpoint, and you can tell this breakpoint by right-clicking on it. The condition for this breakpoint is if number, for example, is less than 0. Only then stop at this breakpoint. Don't stop at this breakpoint in any other condition. Now, this is something you won't be adding regularly, but it's something you could use for... conditional breakpoints are actually used when you have a lot of executions of, for example, a for loop, and you don't want to stop on each one of them. You only want to stop on a specific execution of a for loop, for example, when the index is 5, or when the index is 130, and so on. Okay, so let's examine this program and find what the bugs in it are. I'll copy the program, and I'll paste it into my main method, and I'll try to find what causes this program to run incorrectly. Now, what's the point of this program? Well, it should find the first n odd numbers and print their sum. So this is the task which we were solving a while back. Okay, so what does it do? Well, let's try some input for this program and see what it doesn't do correctly. Okay, so let's input something which we already know. Let's start it and input something which we already know. What is that thing that we already know? Well, we already know that the sum for 5 was 25, and the numbers were from 1 to 9, right? So 1, 3, 5, 7, 9, those are 5 numbers, and the sum of those numbers is 25. So what gets printed? Well, 1, 3, 5, 7, 9, 11, and the sum is 31. Okay, so there seem to be a lot of errors over here. So when you can fix something simple, start by doing that. What's the simplest thing we can fix? Well, all of these are printed on the same line. So we can find that pretty quickly. We don't need debugging for that. So we need print line over here. Now if we start this program again, we can test it, and let's see if it works better than previously. Okay, so now it goes 1, 3, 5, 7, 9, 11, and then 31. Okay, so why does it reach 11? So the first issue over here we have to solve is, why does this program reach 11? It should print only 5 numbers, but instead it's printing 6 numbers. Okay, so how would we check that? Well, we place a breakpoint here, we start the program, and then we check each of the conditions which happen. So the first condition, first we need to enter 5. So initially we can see that I is equal to 0 and n is equal to 5. So that seems correct. And then we're continuing. I is 1 and n is 5. So let's see how this will, since I started from 0, and n is 5, I should reach at most 4, right? So 0, 1, 2, 3, 4 are exactly 5 executions. And we want exactly 5 executions. So we should reach at most 4. So let's see what happens. I becomes 2, then I press F9 again, I becomes 3, and it stops at this breakpoint again. Then I press F9 again, and I becomes 4, and then I press F9 again, and lo and behold, I becomes 5. This is the 6th execution. Now, do I want the 6th execution? Well, I want exactly 5 executions, and notice how I'm adding numbers. I'm using the formula 2 times I plus 1. So for I equals 0, actually I can calculate it. I can say, okay, place this expression inside this variables window, and let's see what that generates. Okay, that generates 11. That's the number I didn't want generated. Okay, so I should have placed this actually in the beginning of the debugging process, so I can see what value is what. Okay, so I get 11, and I get that printed. So I don't want 11 printed. So why am I printing 11? Well, I'm printing 11 because I becomes 6. I becomes 5, so I should never become 5 because it started from 0. And if I was 0, so if I get this expression, I copy it, and I replace I with 0, that's the correct value for the first odd number, right? So for I equals 0, this is the correct value. So the formula is correct. The thing that isn't correct is I. I is 5. And it shouldn't be 5. It should never reach 5. It should start from 0 and reach 4 inclusively. Since why should it reach 4 inclusively? Well, since we have 5 executions, and the number of numbers from 0 to 4 inclusively is exactly 5 numbers. Okay, so why are we reaching 5? Well, if we're reaching I equals 5, since I is the control variable of the loop, one reason for reaching it might be that our condition wouldn't be correct, or our increment isn't correct, but the increment looks correct. So what remains? Well, the condition. And yes, if we look at that condition, if we copy it, and if we paste it over here, we'll see that that condition is true currently for I equals 5. Why is it true when it shouldn't be? Well, because we're using less than or equal instead of just less than. Okay, so we're changing that, and we're going to start the program again and see if the issues are fixed or if there are other problems. Okay, so we enter 5, and we got 1, 3, 5, 7, 9. So the output for the odd numbers is correct, but what isn't correct is the sum. So I have 21 as the sum. Why do I have 21? Okay, so let's do this again. We'll place a breakpoint over here, and we'll see what do I print and what do I add into the sum. Because I know that the sum isn't correct now. So the sum should be 25 if you remember from the last example. So we're going over here, and okay, let's see. I'm printing the correct number, so I know that this is the correct formula for the current number. Am I adding this to the sum. Well, no, I'm not. I'm adding something different. So I don't need to debug any further because I see that I'm printing one thing and I'm adding another thing into the sum. Now, if you're going to be adding the same thing to the sum and to the printing, well, don't have two expressions, have a single expression. Mark the expression, say Control-Alt-V, that would extract a variable, and I'd call this the odd number. This is my odd number which I'm adding. So the issue over here was that I wasn't adding the correct number to the sum. I had the formula copied, but I didn't copy, or whoever wrote the code didn't copy the entire formula or didn't code it correctly. Maybe they coded it once and then they tried to write the same thing again but missed adding the +1 over here. Okay, so let's try it again. Always when you're reusing some expression, you should, well, not always, but almost always when you're using some expression, you should have a variable for it. You don't need to write it over and over again. That's what variables are for. Okay, so let's enter 5. Okay, so now we got 13579 and the sum is 26. Why is it 26? Well, we know that we're adding the correct numbers because we're printing the correct numbers. So the only reason for the sum to be incorrect is if it's not in the loop. That's what I'm saying. It's not in the loop because what we're printing, we're also adding. So if it's not in the loop and it's not after the loop because this is just a print, it's got to be before the loop. And if we notice, sum starts from 1. But what should it start from? It should start from 0 because we don't know if the sum is 1. We will only have the sum of 1 when we add the first number. And that should be the last fix in our program, and that should finish the debugging session we have now. So entering 5, we'll see 13579 and the sum of 25. Now notice how at each step I examined the variables which there were in the code. So if you were watching carefully, you probably noticed all of these bugs before I mentioned them, and I did too. Actually, I didn't notice this one. I noticed it at the end. But I noticed all of the other bugs previously. But I wanted to demonstrate how I go step by step into the code and look at the problem spots. So the obvious problem spot initially was the lack of new lines. Then the next obvious problem spot was the incorrect iteration of the numbers. And then the next problem spot was the incorrect sum. And that finished up my debugging. So I went piece by piece and line by line in my code. And I found each obvious problem, I found what caused it, I found the values which it used, and I used that to debug the program. Okay, so that's how you debug a program. And again, the pattern is find an issue, find an error, notice that there is an error. After noticing there is an error, find which part of the code causes it. How do you do that? Well, you start debugger and start examining values of variables. You examine the exact places where you expect there to be an incorrect value of these variables. If you can't find it, you just look for it. You go step by step in your code and look for values that don't match up with your expectations. And then you just make the changes required to get the correct values. So we talked about how we can declare variables, and we talked about how we can print them on the console. We talked about what the structure of a Java program is, and we talked that the entry point is always the main method. We talked about conditional statements and how we can branch program logic. We talked about how we can repeat code multiple times based on input from the console or any other calculation. And we saw how we can use the debugger. Thanks for listening. As always, ask your questions in the channels we have provided. And I hope this was helpful for you, and see you next time.
In this lesson, your instructor George will explain and demonstrate the primitive data types in Java, how to declare, initialize and use variables, and how to perform type conversions from one data type to another. He will explain the integer types, int and long, the floating point types, float and double, the text types, char and string, and the special types, boolean and object. Along with the live coding examples, your instructor will give you some hands-on exercises to gain practical experience with the mentioned coding concepts. Are you ready? Let's start!
Everyone, this is George, I'm your technical trainer, and today we will be talking about data types and variables. Now, by this point you already know what variables are, but we haven't formally been introduced to them in connection to the data types they have. So today this is what we're going to cover. Now, what are we going to start with? We're going to start with what data types are and how do they relate to variables in Java, because in different programming languages, some concepts are different depending on whether the programming language is statically typed like Java or not, like JavaScript. So we will be talking about that. We will discuss the integer and the real number types, meaning integers in double and float. We will also be talking about type conversion, meaning how you can convert from one data type to another with and without losing data. We will be talking about the Boolean data type, which we've seen when we have made comparisons with the comparison operators when we're doing, for example, an if condition. Whatever you place in that if condition is actually a variable of the Boolean data type. So we will be discussing that. And we will be discussing the character and string data types and how do they relate to each other and how we can use them. So, let's talk about data types. What actually we need to know about data types is related to how computer science operates on information and on how computers actually access information. So, computers in their most basic form and their most general description are just machines that process data in some way. They process information. They get information from somewhere, they do some operations on it, and they output information somewhere else. So to handle this information, to process this information, computers need to store it somewhere. A computer needs to have a place where it puts information and then works on that information so it can give the results it gives after its computations. So what typically happens is you have some data coming in, some information coming into a computer. That information gets converted into computer memory through using the binary numeral system, i.e. you get ones and zeros in the computer's memory. And those ones and zeros are actually stored into transistors, which are the computer's basic memory unit. Each transistor has either an on state or an off state, meaning it either, that's simplification, but let's say it either has current flowing through it or it doesn't. It's more complicated than that, but simply put, there's an easy way in electronics to represent two values, a 1 and a 0, let's say. And that's why computers use the binary numeral system to represent information, because it's easy to implement in electronics from an engineering perspective. So the hardware limits the way computers access data to ones and zeros. So a computer contains, all of its memory is ones and zeros. Now, how it handles the information it has determines the data types we're using here. So ones and zeros are ones and zeros. They don't care about what you're representing in them. They're just ones and zeros. But how we handle those ones and zeros, how we treat a bunch of ones and zeros, determines what operations we can do on those ones and zeros. So when you have a bunch of ones and zeros sitting somewhere, what you can do with them is create a variable for them, name them in a certain way, and set that variable's data type. So when you have a piece of memory like, for example, 000000101, here's a piece of memory. This is actually a single byte because it contains 8 bits, 8 ones or zeros in a sequence, one after another, and this actually is the binary representation of the number 5. So this is the number 5, our decimal number 5, in the binary representation. So 101 is 5. Now, how that formula, how we get from 101 to 5, how does the formula work? We don't really care that much currently, but simply put, you just add powers of 2 where you see ones. So here you add the 0th power of 2. So this is index 0, this is index 1, this is index 2, this is index 3, and so on. Well, whatever the index is, if there's a 1 there, you just add 2 to the power of whatever the index is, whatever the position is, and then over here we won't be adding anything because there's a 0, and then over here we will be adding 2 to the power of, since this is index 2, well, to the power of 2. So that's 2 to the power of 0 is 1, plus 2 to the power of 2 is 4, and that gives us 5. Okay, so that's how an integer would be represented, an integer number, a positive integer number would be represented in memory in a computer. But if that exact same memory is of a different data type, it will be treated in different ways. So if we tell that piece of memory to get assigned by the value 5, that's what we're going to see in the first byte of that memory. So we're going to see exactly that 101 sequence. However, if the exact same sequence is interpreted as another data type, it will be some other things. It won't be the number 5, it will be, for example, a symbol, some symbol from the ASCII character table. So when we talk about variables, we actually, and specifically data types, we actually talk about not different storage into the computer. What we're talking about is different ways of treating that storage, different ways of treating a sequence of ones and zeros to get a different representation in for example, on the console. Okay, so you assign variables, and you know that already, by using the operator equals. So if you want to assign an integer variable named count with the value 5, just like we had in this case the byte containing the value 5, what would happen is an integer variable will be created, the memory for an integer variable will be created. That memory will contain exactly 4 bytes for integers in Java. We will cover this a bit further on, but 4 bytes will be allocated in computer memory. Each of these will have 8 bytes, so this will have 8 bytes, this will have 8 bytes, this will have 8 bytes, and this one will also have 8 bytes. So 8 bits, sorry, 8 bits. A byte contains 8 bits, and the integer data type is a 4-byte integer representation. So when you say integer, that's 4 bytes. Every integer you create assigns 4 bytes of computer memory to your program. And assigning a value to these bytes will set the appropriate bytes to the appropriate values so that they match the binary representation of the number 5 in this case. So this is what happens when you create a variable. Creating variables actually allocates memory, meaning it takes memory from the system and gives it to your program. Okay, so this is an allocation of a 4-byte integer on memory, and this is what happens when we assign it a value. The sum of the bytes in that memory change, so they represent the value from our program. So what we call an integer, an int here, is the data type. This is called the data type, and this is the variable name in this case, and this is the variable value. Okay, so if you do any operation with this variable, in order to keep the result, you need to either write it into the same variable or write it into another variable. So doing operations on data requires you to save them back into memory. Each operation a computer does needs to be saved back into memory, or otherwise printed on the console or sent over the network or something, so that that value is contained. Otherwise, what happens is that the processor creates that value, and if there's nowhere to send it, it just loses it. Okay, so the data type, in this case integer, in this example integer, a data type is just a domain of values. It's the type of values and the way we treat them that determines a data type. And it's not even the type of values, it's how we treat those values. So the same ones and zeros can be treated like an integer, they can be treated like a character, they can be treated like a string, they can be treated like a floating point number, and so on. It really depends on the data type you're using, but otherwise, underlying all of it is just the binary numerical system and ones and zeros in transistors in computer parts. Okay, so each data type from the point of view of a programmer, is a domain of values. So you see a data type as the possible values a variable can get if it is initialized with that data type. So if you initialize something with the integer data type, you know that this variable can get values which are integers, positive and negative integers in a certain range. We will discuss that range later on. Okay, so for example, we can store 1, 2, 3 or -1, -2, -3. Those would be the integer data type. If we want to store characters, we would be using the character data type, which is written like this, char or char. You can find different readings of this type. I would just call it char for now because it's easier to read like that. But this is the character data type. That's where char comes from. Okay, and you could also have Monday, Tuesday, and other real-world objects into your programs, and we will see how we can add those to our programs later on. Okay, so what does a Java data type contain? Well, it contains typically a name, the name of that data type, for example, integer, string, enumerations, character, float, double, bytes, short, and so on. It has a size. Each data type in Java has a specific size which represents it, meaning how much memory that data type uses. I already mentioned that the integer data type has a size of 4 bytes, whereas the char data type has a size of 2 bytes. Okay, and it also has a default value. Now, these default values will come into play when we talk about arrays or when we talk about objects. For now, these default values we can ignore. Creating a variable directly will not initialize it with its default value. So these default values we don't really care about for this part of the lessons we have. Okay, so integer is a 4-byte representation of an integer number. If we say int, this is a primitive data type. Primitive meaning that all other data types, all data types which are not primitive are based on the primitive data types. A primitive data type is a data type that can be directly processed by the CPU. So it's just a sequence of bytes which are usually a representation of a number in one way or another. So primitive data types are data types which are just chunks of information, and int is one of them, float is another, double is another. String, however, isn't a primitive data type. We will discuss that in detail later on. Okay, so it takes up 4 bytes or 32 bits, and we'll talk about that later on, and its default value is 0. Typically, the default value of each primitive data type will be either 0 or something that resembles 0, that is effectively 0 in computer memory, meaning just a sequence of zeros and no ones is bits. And that rule applies for the floating point data type, and it also applies for the character data type. Now, what does it mean for a character to be 0? Well, we will discuss that when we reach the part of the lecture that discusses characters. Okay, and since we've already created some variables, it's a good idea to now discuss how we name those variables so we match the conventions in Java. Now, every language has some conventions about how variables should be named. And depending on the language you're using, you should be using that convention, or at least a common convention in that language when you're naming your variables. In Java, what's accepted is that variables are camel case, meaning that each word is connected to the next word without any separators like underscore, for example, or something else. And each word in the variable name is capitalized except for the first word. So the first word has a small lowercase letter, and each of the next words in the variable name is capitalized. Okay, so hence camel case because it looks like a camel with a hump in its middle. Now you should try to name them with nouns and possibly adjectives plus nouns. So if you're having a variable which is preferred weight or something, or preferred color, preferred is the adjective, and noun is color. So, or just a noun. For example, apples, or students, or number of apples. That also kind of follows the adjective plus noun concept. You have a descriptor of what the next word means. But these over here don't really pay that much attention to them. You will get used to the examples we're giving in our lessons, and those examples will be descriptive enough for you to sort of parrot what we're doing in your variable name. So the most important thing is that the variable should explain what that variable contains. So when I see your code, if I haven't seen it before, I should be able to understand, okay, so this variable is called student, and it's an integer, so it probably contains the number of students which have been, for example, read from the console. Okay, so these are examples of good names or okay names. Again, how descriptive a name should be depends on the context in which it is used. So if you have a short program, you don't really need that much of descriptive names, but it's good practice to try and code descriptive names so that you have a good idea of how to do it further on when you create larger programs. And depending on where your variable is declared, its name can be shorter or longer depending on the surrounding code. For example, a for loop, which just executes something an amount of times, is completely fine. It's completely fine to use just int I there, like I is short for index, because it's something pretty standard in programming, and other people will easily understand what you mean. However, if it's not obvious what your variable means, like for example full bar p1 populate or last name like this. Last name in this case isn't non-descriptive, but it starts with a capital L, and it would confuse potential readers of your code with other types of variables, because there are things in Java which you name with a capital L in the start, and they're called classes. And if someone just sees a variable named like this, they will be confused whether that's a variable or a class, and they would have to look at that variable again and see what it does, where it's initialized, and so on. Also in Java, avoid underscores like this. Java code doesn't typically include underscores in names of variables, so avoid them. And again, these last ones are okay descriptions, but they're not okay formatting, whereas these don't really tell us anything. So avoid names like this, unless, for example, for P, unless you have some very short piece of code which, let's say, calculates the area of, or the perimeter. Let's say you're calculating the perimeter of a circle or of something else. Well, in that case, since P is often used in maths, you can use P, but again, it should be a short piece of code, a very short 2 or 3 lines at most, and if it isn't, you should probably name it a bit more descriptively. Okay, so continuing on from here, once we know how we should declare these variables so they're easy to be read from other users of our code, we should talk about something we haven't yet met in programming, and that's scope and lifetime of a variable. So scope is where you can access a variable. When we're writing code, let's open IntelliJ. When we're writing code and declaring variables, let's say we declare a number variable here and say its value is 5. That variable is visible from the start of this main method to the end of this main method. So all of these lines are that's the scope in which the variable is accessible. However, you can actually only, I'm actually talking to you about lifetime. You can only access the variable after you've declared it. So the scope of a variable is actually the method in which it exists, or the largest block of code and the smallest block of code in which it is placed. And that's okay. So this entire part, and then you cut from that the part to which the part before which the variable is initialized. So this whole thing is a part of code where your variable isn't visible. It becomes visible to other code once it gets declared like this. So if you have int number, even if you don't give it a value, from here on out you get the scope of your variable. So the scope begins from the declaration of the variable, from the place where you say here's a variable of this type, and the scope ends where the block of code in which your variable is declared ends. So the scope of the variable ends with the end of the block of code. And a block of code is just the code between two curly brackets like this one. It doesn't matter if these curly brackets are the brackets of a method, or the brackets of a condition, or the brackets of a loop, or the brackets of a class, and so on. So every time a variable is accessible within the brackets in which it is created. To access it from other places, you would need, depending on what those places are, you would need different code. So by default, the scope of a variable starts from where the variable is declared and ends where the first closing curly bracket appears, the first closing bracket which matches the opening bracket in which the variable was declared. So if we have an if here and say let's say number is 5 over here, and we have an if here and say if number is larger than 1, then create a variable int x which is 2, and then we go over here and say system.out.println number. Now this is code that doesn't really do anything, but we're illustrating a point here. Now the point we're illustrating is the following. I initialize the variable, and it's visible outside this if statement. It's also visible inside this if statement, and it's visible up until we reach this closing bracket. It's not, however, visible over here. You can't say if number larger than 5 over here. Why? Well, we're in the same block of code, but we are before the creation of this number variable. So this limits the access to the number variable from the start of the declaration onwards. Anything outside that can't access the number variable. Okay, and here we can access number because, why? Well, because number is visible from here on out, and it's visible until the end of the main method. However, if we try to print x over here, we'd get an error, a compile time error. Why would we get that? Well, because this x variable is declared inside this block of code, and it's visible from its declaration onwards to the end of the block of code, and that block of code ends over here. So because x is declared inside the if statement, it can only be accessed from inside that if statement. The same goes for loops. Now, an interesting thing is that if you create a for loop, starting from I equals 0 to I less than 10, let's say, it doesn't really matter what indexes you pick. In this case, if you try to access this I variable, it still won't be accessible, even though it's not between these curly brackets of the for loop. So it's not like the if statement. It's still not accessible, even though it's not within the curly brackets. But the reason for that is that the for loop is just a shorthand construction for a while loop, and it kind of cheats. So this, anything you initialize over here is only visible between these two curly brackets, only within them, not outside them. So things initialized inside, again, it's pretty much the same like with conditional statements. Things initialized inside the conditional statement are only visible inside the conditional statement, and things initialized inside the for loop are only visible inside the for loop. The only specific here is where actually inside means. Inside typically means the curly brackets, but for a for loop it also means these brackets over here. Okay, so that's the scope of a variable, and the lifetime of a variable is how long that variable stays in memory. Now the lifetime is the entire block of code in which the variable exists. So it may not be accessible before it is declared, but it's actually in memory from before it is declared. So that's how computer memory treats variables. So if you have a primitive data type variable, int, double, char, float, and so on, it will take up memory from the moment the code block which contains it starts. Okay, so let's actually play around with that a bit. Let's say we have a for loop and we create a variable in sum inside it and say sum plus equals I, and then what do you expect in this for loop to happen for the sum variable? What will the value of the sum variable be? For the first execution, it will obviously start from 0, and then we will add I, which is also 0. So sum will be 0. What will sum be on the next execution when I equals 1? So let's get to the point where I equals 1. So sum is what? Would it initialize again, or would it add I? Now, even though I've named the sum, it doesn't really calculate the sum. Why? Well, because what did we say about the lifetime of a variable? The lifetime of a variable is between the brackets that contain it directly. So these brackets of the for loop contain the sum variable, meaning that this variable gets created over here, and then its lifetime ends when the loop body ends, and the loop body ends on each iteration of the loop. You know, the loop starts over here, executes this part of the body, executes this part of the body, and then the body ends. And then the body is created again, and executed again, and then the body ends, and so on and so forth. So what happens over here is that the lifetime of the sum variable is one execution of the for loop. So each time this sum variable is created anew. So this is a new sum variable, it is created, it is assigned the value of 0, and then we add I equals 0 to it, and then I becomes 1, and then the sum variable is created again, and then we add I equals 1 to it, it becomes 1, but then it dies at the end of this for loop. And then it gets created again, sum equals 0, and then we add I, which is 2 at this point, and then sum becomes 2, but then it again dies at the end of this for loop. So if you have something between curly brackets, it dies whenever these curly brackets get executed, whenever the execution point of the program reaches the end of the curly brackets. Okay, so that means that you don't calculate sums like that. In order to calculate the sum, you have to have the sum variable outside of the for loop and do the calculations inside the for loop. Now, in this case, the sum variable gets increased each time by the I variable, and that gets stored. It doesn't get reset again because it's initialized inside the main body, not inside the for body. And then I can use it over here to print system.out.println, print the sum, to print the output. Okay, so that's lifetime. Lifetime determines how long the sum variable lives. And this means that the sum variable, if it's inside the for loop, not only will it not be accessible for print line over here, because its scope will end here, but also its lifetime will end here, and we don't really calculate the sum this way. We just reinitialize sum with the value of I on each execution. So that's lifetime. That's the lifetime of a variable. And here we have an example. Here's a string variable which is outside somewhere. It's actually outside the for loop, but it's inside the main method. And here we have a for loop which has an inner string variable, and this is inside the for loop. So this gets initialized each time the for loop runs, whereas outer gets initialized only once. And outer is accessible outside the for loop because it's declared outside the for loop, whereas inner isn't available outside the for loop, and if we try to access it, we will get a compile time error. Okay, now there's another concept which isn't exactly technical, but it's related to quality code, and that concept is span. Variables have span. What does span mean? Well, it means how much time the variable exists before it is accessed. So in my case, the span of my sum variable is 2 lines. So one line here where it's created, and one line here for the for loop, and then I directly access it. Okay, so this is the span of a variable. Now, I can move this integer I variable outside the for loop, like so, and I can initialize it here, but I can declare it here. In this case, the span of this variable became this line, then this line, then this line. It became a lot of other lines, and there's a variable here which is, it intersects the span of the I variable. So the span, the length of the spans of your variables determines how easy it is to read your code. So the shorter the spans, the easier it is to read. You notice that in this for loop it looks a bit weird, right? So I have an I variable, and that means that that I variable is declared somewhere else, and I need to look for it to see what happens with that I variable before it gets into my for loop. So using variables like this isn't really recommended, and a good practice is to keep your spans as short as possible. So you create a variable where you need it. You don't create it at the start of your program. You create it wherever you need that variable and use it at that place. So for an example, here outer is its span includes all of these lines up until the point where we print it. And we don't really need to do it like this. We actually could move the outer variable here, since it's being used here, and that way it would only have a span of 2 lines, and it's easier to search for it. Okay, so the main concept you should take away here is keep your variable span short. If you need a variable somewhere, declare it there. The only exception is if you want to create a sum, and yeah, we need the sum here, but we also need it outside. So try to keep the lifetime and the span of a variable as short as possible. The shorter a variable lives, the easier it is to read, because you don't need to look for it in a lot of places. You only need to look for it wherever it is used. Okay, so that improves readability. It's easier to read code which has shorter spans. And here we have more examples. You can check them out later on. Okay, so once we've covered what variables are and what their span is, let's cover the integer data types which we've already used, so we can see what their properties are, what their differences are, and so on. So there are 4 integer data types in Java. They are byte, short, integer, int, and long. And this is the order in which their size increases. So byte is the smallest possible integer data type, and it represents an 8-bit integer. Short represents a 16-bit integer, int represents a 32-bit integer, and long represents a 64-bit integer. Now, do you need to remember these values? No, you don't. What you need to remember is these sizes. And how do you calculate how many values a data type can represent? Well, it's pretty simple. Let's say we have a single byte data type, a single bit data type, so 1 bit, only 1 bit. How many values can you store in 1 bit? Well, you can store either 0 or 1. Okay, how many values can you store in 2 bits? Well, you can store 0, 0, you can store 0, 1, you can store 1, 0, and you can store 1, 1. So 4 values. We can play around with this even further. What happens with 3 bits? Well, you can store 0, 0, 0, then you can store 0, 0, 1, then you can store 0, 0, 0, 1, 0, then you can store 0, 1, 1, then you can store 1, 0, 0, then you can store 1, 0, 1, then you can store 1, 1, 0, then you can store 1, 1, 1, and that's pretty much it, right? So these are 1, 2, 3, 4, 5, 6, 7, 8 values. Okay, so do you see a pattern here? There is a pattern over here. The pattern is the following. If you have 1 bit, you can store 2 to the power of 1 values. If you have 2 bits, you can store 2 to the power of 2 values, right? 4 values, 1, 2, 3, 4 values. If you have 3 bits, you can store 2 to the power of 3 values, so 8 values. 8 possible combinations of 1s and 0s for that length of bits. So that's all you need to remember. You need to remember the sizes, and you need to just raise that to the power, raise 2 to that power. So a byte can store 2 to the 8 combinations of bits, 2 to the 8 values, 2 to the 8. Yeah, and you, as a programmer, you should probably learn the powers of 2. So 2 to the power of 1 is 2, to the power of 2 is 4, 3 is 8, 4 is 16, 5 is 32, 6 is 64, 7 is 128, and 8 is 256. So 256 possible values inside a single byte of information. This represents exactly 1 byte of information. Hence, 256 values split evenly between positive and negative gives you from minus 128 to plus 127 and 0. I said split evenly, but since we're including 0, that reduces the maximum integer value for a byte. Okay, compared to the minimum integer value for a byte. Okay, so this is how you calculate the size of a byte. And how do you calculate the size of a short? Well, it's 16 bits, so it's, and you start the calculator. You start a calculator, and that calculator, you input, you go into the scientific view, and you just say 2 to the power of 16 for short, and you get 65,536. And it's actually pretty close to the 64 number which we got to the 2 to the power of 6, right? So 2 to the power of 6 is 64, whereas 2 to the power of 16 is about 65,000. So that's a mnemonic you can use to remember that. Why is it like that? Well, it's because 2 to the power of 10 is 1,000, which is similar to 1. You can think of that as like that. So the powers from 10 onwards are similar to the powers from 1 onwards. So 2 to the power of 2 is 2,000 and something, and 2 to the power of 1 is 2, simply. So I didn't mean to. 2 to the power of 11. Yeah, I messed that up. So 2 to the power of 11 gives you 2048. 2048. And 2 to the power of 1 gives you 2. Right? So they look similar. This is to the power of, it isn't 21. This is 2 to the power of 1 gives you 2. So the values are somewhat similar before 10, before the 10th power, and after the 10th power. Okay, so that's it for short. And how does it work for integer? Well, 32 bits are about 4 billion values. And 4 billion split evenly between negative and positive gives you these values. You don't need to remember the exact values, and if you need the exact value for some reason, you can always do, let's say for integer, you can do integer dot max value. This gives you a variable. This gives you a value which is the maximum value for an integer. So int max equals max value would give you the maximum value for an integer, and if you print this on the console, you will see this number printed. Okay, so for long, it's an even longer, bigger number. Again, what you need to remember is the number of bytes or the number of bits for these data types, and to use the appropriate data type depending on how many bits you're going to need. Okay, so here we have an example of this, of using the appropriate data type for the appropriate maximal values we're expecting. So if we're going to be representing a date in the current century, one way to do it is to represent the number of centuries with a byte, because a byte can represent values from minus 128 to plus 127. So since we're in the 20th century currently, it's going to take a lot of time before our program starts working incorrectly, meaning that it reaches the 127th century. So we're okay with storing centuries in a byte if we're going to represent the current day, and storing years in a short, because 65,000 years we're going to have a lot of time until we get to the year 65,000, since we're currently in the year 2000, or approximately in the year 2000. And days, well, when you get to days, you kind of need quite bigger numbers, and when you get to hours, you need even bigger numbers, and so on. So what you can do when you're solving tasks is to minimize the amount of memory you're using by picking data types which can save lower values, but large enough values to cover your expectations for the maximum value. So this is sort of an optimization. It's not really done that often. People usually use integer for everything because there's plenty of memory these days and you don't really need to optimize for each byte. But if you do need to optimize for each byte, well, that's why you have the different data types in Java, and those allow you to optimize the amount of data you're storing. Okay, so we won't be playing around with this too much. You can try out creating these variables and see how they work. These data types act the same way that integer does, but the maximum value they can save is less. Okay, and I'm saying the maximum value and the minimum value, and I'm saying that because you need to be aware of the integer overflow problem when you're using lower values than smaller data types than the values you're trying to save. So what would happen if I create a for loop? But I create it not with an integer, but with a byte, and I say run this for loop until it reaches 130, and say system.out.println I. So print the number which I'm at the moment. Well, if I start this, since byte's maximum value is 127, I will never reach 130. What happens to I actually is, you can notice what happens on the console. The console keeps printing numbers, and these numbers rotate from positive integers to negative integers, and positive integers and negative integers again. Well, what happens is that if you have a variable let's say that's byte x, and that's equal to byte.max value, which is 127, and then you say x plus plus, x rolls around and it overflows. This is an integer overflow, integer as in the type of number, not as in the data type int. So what you get here is an integer overflow, and that causes your byte to jump from the maximum byte value to the minimum byte value. So if we place a breakpoint over here and start this program, we will notice that x is now, let's see, minus 128. That is byte.min value. What actually happens is, you can imagine the data types in the following way. You have 0 over here, and then you have sort of a circle which reaches for byte 127, and then it jumps onto minus 128, and then that goes back to 0. So if you're increasing a value and increasing it a byte value, and you reach 127, if you add 1 to that, it moves you to the minimum value minus 128. Now, why that works the way it does is based on how numbers are represented in binary, and it's got to do with something called 2's complement. And you can Google that to see why the plus operation works that way, but that's simply how computers implement integer numbers, whole numbers. So, by the way, that means that if you're at 127 and you add 2, so if you say add 2, that would give you not minus 128 again, it would give you minus 127. And the same rules go for integer and long and short and so on. It's absolutely the same thing. So if you overflow the integer, you get the negative values. And depending on how much you overflow it by, you will get that integer value, that offset of integer value. Okay, so beware of this. Be careful with this. So when you're working with close to the maximum value of your data type, well, you probably should change to the next larger data type and use that. Okay, so that's what you do for integer data types, and that's why you have to be careful, because this loop over here will never finish. It will keep executing until I reaches until the end of time, until we stop the program. It will never reach 130. Okay, so you keep this in mind, and again, the advice is use integer most of the time. Integer is your go-to data type for integer numbers. It's also optimized to work with the processor architecture of your computer, so you should be fine using integer most of the time. But be wary of larger, if you have a programming problem, and that programming problem tells you that the numbers which you're going to be using are, let's say you're going to be summing 10 integer numbers, and you have to output the sum, and the integer numbers can be any integer value, then you probably should make the sum a long sum. Why? Well, because if you sum integer.max value plus integer.max value minus 1, that will overflow. So if you're working if you're calculating a sum for integer values, and those integer values can be from minus 2 billion to plus 2 billion, then you probably want the sum to be a long sum. Okay. Now, another thing we need to discuss about integers are their literals. Now, what we're using over here when we say I less than 130, or when we're saying int number equals 5, this is a so-called literal. It's a literal value in the code, meaning that the value isn't read from the console. It's not taken from another variable, like if we have int x equals 5 and then number equals x. Well, x isn't a literal, it's a variable. But this is a literal representation of a numeric value in the code, and this in this case is an integer literal. So numeric literals written like this are by default integers. So this is an integer, it's treated like an integer. Now, if you prefix that with 0x or 0x capital, that means hexadecimal numeral system. So 0xf means 16. That's because f in the hexadecimal numeral system is 16. Actually 15, sorry. This is 15 because it's a hexadecimal numeral system, and the maximum value of any numeral system is one less than the numeral system's name would suggest. Just like the maximum digit in the decimal numeral system is 9, right? It's not 10. 10 is the numeral system. You get 10 by the digit 1 and the digit 0. Okay, so the maximum hexadecimal is f, and you can have multiple. So this is 255 as a value. And how numeral systems work is another subject, which we will cover further on, but it's not something we're going to be discussing today. And anyway, when you see 0x, that means hexadecimal numeral system. You're often going to see these values for addresses in memory. Addresses in memory are typically numbered with this hexadecimal numeral system. Okay, so all of these are hexadecimal values. Now, if you see L or L capital on value, that means the value is treated like a long number. So instead of int, when you say int x and you say that's equal to 5, well, that simply converts 5 into an integer and sets it into x. But if you place an L over here, that means this is a long number, and since we're trying to fit it into an integer, now we're getting an error. Now, the reason there is such a suffix for long numbers is in some cases you want a really big number. For example, let's say 4 billion. That's larger than the maximal int value. So let's say we have a long number here, and we want to set it to 4 billion. That's 4, 1, 2, 3 zeros, 1, 2, 3, 6 zeros, 1, 2, 3, 9 zeros, and look what happens. So up to this point, we have 4 million, and now we have 4 billion. If we lower it to 2 billion, it fits into integer, and that's why it compiles. However, if we raise it up to 4 billion, that's larger than the maximal integer value, and the compiler is not happy. Why is it not happy? Because this is an integer literal, and there is no integer number which matches this literal. Integer can't hold such a large number. So the compiler says, look, do you want a long literal here, or is this a mistake? So the compiler checks for us and sees, okay, this is a pretty large number. Maybe he made a mistake. He wanted an integer number, but a smaller one. So in order for me to indicate that I'm not making a mistake, I'm adding the suffix L at the end, which indicates that no, this is not a mistake. Treat that as a long number and save it into the long variable x. Now, using the lowercase l also works, but I wouldn't suggest it. Why? Well, because can you find the difference between 1 and L? Well, you can, but you need to look into it closely. And typically, you wouldn't be looking that closely. So use the capital L, because it doesn't look like the integer number 1. Okay. So we have a task over here, which is to write a program which converts meters into kilometers. So we have 1,000 meters, and we should print out 1 kilometer, 0.85. Okay, so how would we do that? We need to read, of course, that integer number from the console. We need to parse it as an integer, and since integers can't hold floating point data, what we need to do from here on out is to divide that by 1,000 and save it into a non-integer number which we can display. Now, it's not so much that this task is complicated, it's that notice how we're doing the division. We're dividing not meters by simply 1,000, we're dividing meters by 1,000.0. Why are we doing that? Well, because since meters is an integer, if we divide it simply by 1,000, an integer divided by an integer gives us a result of an integer. So dividing 1,852 by 1,000 would not give us 1.85, it would simply give us 1,000. So, sorry, not 1,000, it would simply give us 1, the value of 1. So, if we want to receive a result that contains a floating point, well, we need to divide by a floating point number. So if we divide an integer number by a floating point number, then the compiler decides, okay, so this needs to be a floating point result because it contains a floating point in the arithmetic. So whenever you're dividing something by, whenever you're dividing integers, keep in mind that integer division produces integer results. So any floating point parts will be cut off. Okay, and since we started talking about floating point types, the next place we're going to visit is how do we create these floating point types and how we use them. Okay, so we saw the integer data types, and now we need to discuss the real number data types. Now, what do we mean by real numbers? Well, we mean 1.25 minus 0.38, 2 to the power of 17, or 2.3 to the power of 17, and so on. That's what we mean by real number types. Numbers which aren't whole numbers, they're numbers which have a decimal part. So these are called floating point types in computing, and these floating point types represent the data we're talking about. So these floating point types don't exactly work like the integer data types, and we'll see why not in a moment, but the defining characteristic for these floating point types is their precision, meaning how many digits they can represent after the decimal point, and how much memory they use, how many bytes do they use in memory. So there are two data types for floating point representation of data, and those are float and double. So these float and double have different accuracies depending on their sizes. Float is the smaller type and double is the larger type, meaning that double gives you a higher accuracy, hence higher precision, because it uses more memory. Now, even with double, you will sometimes have abnormalities in calculations, and we will see that in a few slides. And the other thing need to know about the floating point types is that they don't really have, they do have a maximum value and a minimum value, but their maximum and minimum aren't sequential values like for integer types. Their maximum values can be stuff like this huge number over here and this small number over here. So floating point types are actually exponential types. So they represent a small number multiplied, or a number like 1.37, for example, multiplied by a very large exponent, so or very small exponent. So you may have stuff like 2.38 multiplied by 10 to the 20th power or something like that. So that's how floating point types are actually represented in computer memory. So float goes from about plus or minus 1.5 multiplied by 10 to the minus 45th power. So that means plus or minus 1.5 divided by 10 with 45 zeros. That's the smallest value for float, and this is the largest value for float. And this floating point data type is represented by 32 bits, which is, by the way, the same as which data type? As integer. So this is the integer size, so the size is the same, but the way we represent data in it, it's very different. Like I said in the beginning of the lecture, data types just describe how you treat the data at the variable's location, not the data itself. The data is still ones and zeros, and float has the exact same amount of ones and zeros as integer does. However, it represents floating point values because it uses those bits in a different way. So float is approximately 7 digits precise, so you can expect 7 digits precision for average numbers, like stuff from 0 to 1 million, for example. 7 digits precision after the decimal point. So actually not after the decimal point, 7 digits precision in total. So you can expect precisions of up to 7 digits, and from there on out the precision gets lost. So double is twice that, and it has a precision of about 15 to 16 digits. And again, using the digits this way isn't very descriptive of what you actually represent, because floating point values aren't stored in memory like a sequence of digits of the number. They're stored in memory like an exponent, like I mentioned previously. They're stored in memory like, for example, 1.7 multiplied by 10 to the 34th power, or something like that. That's how floating point values are stored in memory. So their precision is a bit arbitrary, and how accurate they are is also very arbitrary. So when you're doing calculations with floating point and with float and double data types, with floating point data types, you need to always keep in mind that the calculations may be wrong, meaning that they may not be exactly right. They will be correct within a margin of error, and that margin of error depends on how big or how small your numbers are. Okay, so the default values for them are respectively 0 for float and 0 for double, and notice how we have added the suffixes f and d to these values. So if you type in this literal followed by f, that would mean a floating point number, whereas if you type in just 0.0 without the d, or if you add the d, that means a double literal. So if these are literals in the code, this would be a float literal, whereas this would be a double literal. Okay, so float and double have different precision. If you really want to calculate for precision, you use double. So if we use a floating point representation of pi, we're going to get this cut to about over here. So actually, let's take this code and see how it works. We're copying this, and we're placing it inside the live demo over here. So what will we see when we run this code is that the floating point value will be cut off to about the middle. So here we go. The floating point representation of pi gets this value, whereas the double representation of pi gets this value. So what's the deal here? Well, the deal is that Float has less memory, hence it can represent lower accuracies. So you notice the 7 digits over here. So yeah, 7 digits after the decimal point, although I wouldn't count on those always being 7 digits after the decimal point accurate, especially for large numbers. So the takeaway here is not so much to remember how many digits float or double are accurate to. The takeaway here is that if you need to do more accurate calculations, quick calculations but more accurate, you use double. If you want to make really quick calculations, you use float. Now float is typically used for stuff like computer graphics because it doesn't really matter if one pixel is if a color is 1 pixel to the left or to the right. It's acceptable in favor of doubling the frame rate of, for example, a game. So usually computer graphics use floating point numbers to calculate positions in, let's say, in a 3D game. If you have a game with 3D graphics, those graphics are probably running on floating points because the resolutions of monitors aren't that large for floating point calculation errors to affect them. However, if you're doing more important calculations, for example, you're calculating, you're doing a physics simulation and you're calculating forces acting on an object, then you probably are going to be using double. Okay, so again, note this suffix which we have on this floating point number. If this isn't an f at the end, if we remove this f, this literal will be treated like a double literal. And since double is a larger data type than float, it can't directly be entered into a float because there will be precision loss. The same way we can't directly write a long number into an integer number because the long number may be larger than the largest possible integer number. Same here, however, it's not about being the larger number, it's more about the precision of the digits inside the number. So if you want to create a literal for a floating point number, you just place f at the end of that literal. Okay, so continuing on from here, we have a task. We have a task that gets British pounds and has to convert them to US dollars formatted to the third decimal point. So if we have 1 British pound, that's $1.31. Actually, that's the conversion rate we're using, and we want to print it as $1.310. Okay, so we have here 80 pounds and we need to print them as $104.800. And in this case, we'd be using floating point numbers. Although, if you're really going on for accuracy and you're working somewhere where financial operations are done, you would typically use another approach. And let's actually use the other approach, but we'll play around with it a bit. So we have 80 pounds and we have to convert them into dollars. Or we have some amount of pounds and we have to convert them into dollars. What do we typically do if we're doing financial operations? Is we don't use the dollars direct, or pounds or dollars, doesn't really matter. We're not using the dollar type directly. Most financial softwares use cents, meaning most financial software uses the smallest possible denomination of a currency. So the thing that can't be divided into smaller things. So a dollar can be subdivided into cents. Pound can be subdivided into pence. So that's what you would be using if you want to calculate, for example, exchange rates from pounds to dollars or stuff like that. But since we're playing around with double and float, let's just use that. So we have pounds to dollars to calculate, and we're going to get 80 or 39 or another number, and we have to convert it into dollars. So we're getting pounds. Let's implement this code. We're getting, and since this is a financial operation and speed is less important than accuracy, let's use double. We will be using a double, and we'll call that, those will be our pounds. Okay? And where will we get that double? Well, let's create a scanner and tell that scanner to read from system.in. save it into a variable and use that scanner to read. However, we don't want to read an integer for our pounds. We want to read what? We want to read a double. Next double. Okay? Because we're reading from the console and we want parsing from the console to take in any decimal points which the number may or may not contain. Okay, so we have the pounds, and let's get the dollars from that. Dollars equals pounds multiplied by 1.31. So that's our calculation to get dollars from the pounds. That's our exchange rate, and now we have to print it formatted up to the third decimal point. So we have to print with 3 digits after the decimal point. So how do we do that? We've done that before. So let's say system.out.print, and we're going to print not a line but a formatted string, and that formatted string will contain a single floating point number followed by a new line, so that it's easier to distinguish from the debug messages. Okay, and we'll be printing the dollars over here. And what did we say? We want the dollars to be formatted up to the third decimal point. So we're printing a floating point number, and we want how many decimal points? We want 3. So we say decimal points 3. Okay, let's see what happens if our program seems to be working correctly. Now starting this, I will input 80 and I'll see 104.800. That seems correct. Now it's best for me to calculate the other possible inputs and see if my calculations are correct. But since this is a lecture, we won't be playing around with that too much. So the solution which we're offered here in the slides is pretty much the same which we already did. We read the double number from the console, multiply it by 1.31 and print it as a result. Now again, if you're doing actual financial operations in actual software which will be working with clients, this isn't exactly a good idea. What you would be doing in reality would be, you would be reading the pounds as, let's say, a double from the console, but you would be multiplying them by 100 and be getting an integer pence. Was that the multiple of penny? Anyway, let's say that it is, even if we're wrong. Okay, now, yeah, this would actually not be an input of double on the console. This would be an input of integer, and I wouldn't be multiplying it by 100. I would just be reading the pence from the console, the number of pennies read from the console. I think we can use pennies in multiple like this, or maybe we can't, but it doesn't really matter. So I've studied it like pence before, or at least I think I've studied it like that before. So we're getting an integer from the console, and that would be the pence we are getting for our pound. So we wouldn't be reading a double number from the console, we would be reading an integer. And then those pence would be converted into cents by multiplying these pence by not 1.31 but by 131, and only then would we be probably dividing these cents by 100.0, because this would be an integer too, and then we'd be dividing by 100.0 so we can get the double number to display. Now, this would be if you're actually doing some financial calculations, or that's one option. Another option is to use the big decimal class, which we will see in a few slides. So we'll get to that in a moment. Okay, so another thing you need to keep in mind about floating point numbers is that they can be represented by literals such as these. So this literal is actually pretty close to how floating point numbers are represented in memory, and it means the number over here is 1 multiplied by 10 to the power of plus 34. So 1e plus 34 is actually equal to 1 multiplied by 10 with 34 zeros. So let's use something easier to write out. If you see 1e plus 3, that's 1000. Why? Well, because that's 1 multiplied by 10 with 3 zeros, multiplied by 10 to the power of 3, which is 1000. So 10 multiplied by 10 is 100, and multiplied by 10 again is 1000, 10 to the third power. So this is what this notation means. And if you see this notation, 20, it's the same notation, but it's a different example, 20e minus 3, that's the same as saying 20 multiplied by 10 to the minus third power. Now, if you have a negative power, what does that mean? Well, a negative power simply means that you have to divide instead of multiply. So it's what you get is 20 divided by 1000, because 10 to the power of 3 is 1000, and the negative power just means division instead of multiplication. So that's, what is that? That's 0.02 as a value. Now, these values exist and they can be parsed from the console. So if you create a very large number and print it on the console, Java's default behavior would be to print it like such a value. And that's why we're showing you this notation, so you don't get confused when you get a very small or very large value represented like this. And you can use it as a literal in your code, and you can even read it from the console. So scanner.nextDouble can read stuff like 20e minus 3, and that would give you 0.02. Actually, let's try that. Let's see if it works. So let's say we just have to get a number from the console and print it back on the console. So print line number, and this number will be a double number which we get from the scanner dot give me the next double. And if I start this, I should be able to enter 20e minus 3, or let's say 30e minus, let's say 42e minus 3, 42e minus 3, and that should give us what? That should give us 0.42 or something like that. Let's see, 0.042, sorry. So 42e minus 3 means 42 divided by 1000, which gives us what? Well, it gives us 0.042. Okay, so the reason we're showing you these representations of floating point numbers is both for convenience, because sometimes you want to represent a very large number as a literal, and you can use literals like this, or sometimes you will have input like these literals, and you can read it directly from the console. You don't need to do anything special to handle numbers such as these entered on the console. Now, something we already mentioned in a few slides back when we were talking about converting integers to floating point values is that floating point division isn't the same as integer division. If you divide integers by integers, you get integers and you lose the floating points. But if you divide an integer by a floating point number, you get a floating point number. So 10 divided by 4, and 4 as a floating point number, will give you 2.5, because 2.5 multiplied by 4 will give you 10. So floating point division calculates, I'd say accurately, but it's not always completely accurately, but its concept is to calculate accurately, but due to being limited by a fixed amount of memory, it can't always represent every number that's representable as a floating point, but it attempts to calculate without losing precision. So whenever you need to divide something into equal parts, you can get you can do that with floating point division. Okay, now there are other things which don't match floating point division with integer division, and those are the following. If you have a number, if you have an integer number, let's say we have an integer number, and we have an integer number divider. Now, if this number is, say, 42, but the divider is 0, and we try to print the number divided by the divider, what we'll get on the console is an exception. Java will crash and we'll get an arithmetic divide by 0 exception. So you can't divide integers if the divider is 0. So you can't divide by 0 for integers. However, if these are floating point numbers, if this is double and this is double, or at least if one of those is double, since an arithmetic operation involving a double will always result in a double. So if you divide a double by 0, you will get a special value called infinity. And here we got exactly that. A special, meaning if you divide by a positive value by 0, you will receive infinity. And if you divide a negative value by 0, you will receive minus infinity. And if you divide 0 by 0, you will get another special value called not a number, NaN. That's for floating point division only. And if you ever have a number with one of these values, whatever you do with it, it will remain its own value. The only exception being that if you divide infinity by infinity, you will get not a number. But if you multiply not a number by anything, it will remain not a number. And if you multiply infinity by anything, it will remain not a number. The only case in which one of these special values changes is when you divide an infinity by another infinity, and then you get not a number. So those are special values for floating point numbers, and you shouldn't be very surprised by them. They are a standard concept in the way computers handle floating point numbers. And the reason all of this is possible is that using floating point numbers were people who are actually scientists. So when floating point numbers were created, they were created for physics simulation, for example, calculating the position of a planet. In those cases, you don't need centimeter accuracy when you're calculating where a planet is in the solar system. You just need to calculate approximately where that planet is located and how fast it's moving and so on. And in calculations like that, physics calculations, infinities and not numbers and exponential notation are standard practice. Hence, floating point numbers are optimized for those types of calculations. So whenever you're going for fast calculations which need to be semi-accurate, you're using floating point numbers. Okay, and you need to just keep in mind these special cases. Okay, now there are things which floating point numbers do a bit unusually. So again, these are numbers which are they are made for not complete accuracy. So let's have an example over here with something interesting. Let's say we have a double number A and a double number B. Those are the high precision floating point numbers, not the floats. So A will be 0.1 and B will be 0.2. And we can even read them from the console if you like. Okay, so let's calculate their sum. And say that sum is A plus B. Now, if we now write if sum equals 0.3 and print on the console the result of this sum and say yes, for example. Okay, so yes meaning that this comparison was correct. And otherwise, if we add an else which says yes, but actually no, what would you guess would happen in this case if we start this code? Let's see. We'll start this code and we'll see what gets printed on the console. Surprise, we got yes, but actually no. But how did we get that? 0.1 plus 0.2 should be 0.3, meaning that since it's 0.3, we should get into this conditional statement and print a yes. Well, yes, but actually no, because in normal math, yes. In human math, yes, 0.1 plus 0.2 is 0.3. However, if we place a breakpoint over here, since floating point numbers represent exponential sums, and since they are limited in accuracy, meaning that they have a fixed number of bytes they can use to represent data, what happens is not all numbers have a correct representation in that way we're saving the data type into memory. So for this sum of 0.1 and 0.2, what we get is not 0.3, but 0.3 and a lot of zeros followed by the digit 4. Why? Well, because floating point math isn't completely accurate. There are subtle errors here and there, which typically average out if you're doing large calculations, but that means that you can never compare two floating point values directly, two floating point values that have been that have been a product that are a product of a calculation. I would have said that that have been entered from the console, but you actually can't compare floating point values if they have been just entered from somewhere. You just can't rely on a calculation of floating point numbers to give you an exact result. So what's usually done in this case, if you want to check against some floating point value, what you usually do is use math.apps and you subtract from sum this 0.3 value. So you subtract from what you have, or actually you will subtract from the absolute value of what you have, the value with which you're comparing, and then see if that's larger than 0, and not 0, but larger than, for example, 0.1 or 0.01 or 0.0001. This way, what you're doing is you're calculating, and yeah, actually the initial way I wrote it was correct. Let's say what you want is to check if the distance from sum to 0.3 is less than 0.001, for example. What I'm doing here is I'm not comparing directly sum with 0.3, but I'm reducing sum by 0.3, and if sum is very close to 0.3, then the absolute value of this difference should be very small. You know, it's like comparing the two, but I'm not comparing them exactly, I'm comparing them within a range of this value. So if you have a programming task which expects you to do something with floating point numbers, it will usually have a so-called epsilon defined, which is the smallest number from which on you consider two numbers equal. So if they have a difference of that epsilon, which is provided in the task description, then if the difference of the two numbers is less than that epsilon, then they are considered equal. So in programming, when you're doing such calculations and searching for equality, usually that equality is checked within some epsilon, some range of possible equalities. Okay, so that's one of the weirdness of floating point numbers. You just have to keep that in mind. Now, most tasks in our lessons will not involve precise calculations with floating point numbers, so you don't need to worry about this too much. But if you're in some larger project, if you're comparing floating point values, you will probably be comparing them like this. You compare the value you've calculated with the value you want to check against by subtracting one from the other, doesn't really matter in what order, taking the absolute value of that, and then checking if that absolute value is less than, or actually this should have been less than, not larger than, is less than some epsilon, which basically means that the distance from between these two numbers on the numerical axis is less than this distance over here, and that means that you consider them equal. So in floating point math, nothing is ever exactly equal, it's approximately equal. And here's another example of that with other numbers. There are a lot of numbers which aren't exactly representable in floating point. Okay, so in case you actually need very accurate calculations, but you don't need them to be fast, you can use the big decimal class. Big decimal is a special data type which provides arithmetic operations which are absolutely precise. So this is absolute precision floating point calculations. How high is that precision? Well, it depends on the amount of memory you have on your computer. So this big decimal type isn't a fixed size type like int or float or double. It's a variable size type which can take up more memory as it needs to grow. So when you're doing financial calculations, either you're using cents, meaning the smallest denomination of a currency, or you're using big decimal to represent that currency, and you're doing the operation slower. So big decimal works pretty much like a normal variable, but you don't initialize it directly by giving it a value. You just need to say big decimal, like you would int, the name of your variable, and then the keyword new, followed by big decimal, and then the value of that big decimal. Or you could do big decimal dot value of, and provide an integer from which this needs to be parsed. Or if you've got a string, you just say new big decimal, and you provide the string over here, for example 42, because this could be a very large string which isn't representable in integer or long or anything, or 42.3, that would also work. So big decimal and provided the string 42.3, and that will parse it into a big decimal. Or if you provided a large string which can't fit into any data type, it will still fit it, as long as you have enough memory to fit that. Okay, and the operations you do on it are directly on the variable itself. So you don't say number plus, you'd say number dot add, and you provide the parameter which is the other big decimal you want to add in. Okay, actually we have a task which involves using big decimal. We have n real numbers and we need to sum them in, and they could be a lot of these numbers. So n is a normal integer, but the numbers themselves, so here 2 says we have two numbers, and this is the first number and this is the second number, and we need to add them together. How do we do that? Well, let's see what we can do. So we need to use the scanner to read the next integer from the console, and this would be our number of values. And I'm using n here instead of number of values because that is the business logic of our task. So in the task, it's described as n, which is just n, which equals the numbers which need to be read. Okay, so then I'll use n for my variable name. I can use the variable names described in the task, because whenever someone then reads the task, they will know exactly what this variable means. And I can also call it number of numbers or something, but n seems sufficient for now. Okay, so now I need to read this many numbers from the console. So I need to do a for loop which starts from 0 and continues until it reaches n, and does what? Well, I need to sum into a big decimal. So I'd be needing a big decimal number over here, which is our sum, and this I will initialize with a new big decimal. Now it wants a parameter with the initial value, and I'll say that the initial value is just 0. Okay, so I'll initialize my sum with big decimal 0, and then I can say read the next big decimal. Well, how will I read that next big decimal? Well, I'll have it on a separate line, and since I have each of them on a separate line, let's read the string from the console. So let's say line equals scanner dot give me the next line, or actually I'd say the next number, give me the next number from the next thing from the input, since reading the next integer will read up to here. And if I say next line, that will just give me an empty line because it's at the end of this symbol, and I would need to somehow move my cursor to the next line. So if I want to read with next line after I've done next int, I should probably do a next line over here, so I can eat up this empty line at the end. So whenever you read with next int, it only reads up until the end of the thing you have to be parsed. So if it's an integer, it will read to the end of the integer, but it will not read the new line symbol over here. So it will stay over at this position. And then if you say next line, well, next line ends over here, so that would be an empty string. So instead of playing around with the lines, what I do is I just say scanner.next. That will give me the next string. So if I read the next int, that will read up to here. But next string will search for the next start of a string that isn't a white space. So this is a white space over here, so it will ignore it, and it will start from here. So this will be the next string that it reads. Okay, so this reads me the next string, and I need to convert it into something I can sum into my sum. So what can I sum into my sum? Well, I can say sum.add, and I need to provide the big decimal here. Okay, how do I provide the big decimal here? Well, I need to create the big decimal from this line. How do I create the big decimal from this line? I simply say big decimal, and here I think I can provide the string. Let's see. Can I provide a string value? What I did was I came with the cursor over here and I pressed Ctrl P, and I saw each of these lines as a different option of initialization for big decimal. And if I look around hard enough, I can see that I can provide a string value. So I can provide my line over here. So this will parse my big decimal into my line into a big decimal, and it will calculate the sum of this big decimal and this line. Now, notice that doing the sum like this is the same as saying sum plus new big decimal line if plus were available. Now, plus isn't available for big decimal like it is for int, but it's the same concept. Now, how do I get the actual value from here on out? Well, I need to assign it back into sum, because if I were using the plus sign, I would be saying sum equals sum plus line, if line was a number. I wouldn't be just saying sum plus line, I would be saying sum equals sum plus line. Same situation here. Sum gets replaced by sum, compute the sum of this with this value. Okay, so this calculates the sum. And now I can use that value to print it to the console. So I can say system.out.print line and print this sum. And if I start this, I will see that it prints the sum of these big integers which are entered here. Let's use big decimals, I meant, which are entered here. Let's check that. Two numbers. The numbers are this large thing and the number 5, and the output seems correct. So our code works for very large values. Let's check with these also. Pasting these in, this seems that it matches the value which we have here as an example. And again, we should test this program out with different inputs, but we won't be wasting time in the lesson here. We will let you guys figure that out on your own at home. Test it out, play around with this class. There's also a big integer class. It's meant for representing big integer numbers which are larger than long. So if you need to store very large integer numbers, you can use big integer for that. Whereas big decimal you use if you need to store very large floating point numbers. Okay, so this would calculate the exact sum of a few real numbers over here. Okay, and we have a solution for that which more or less reflects what I wrote. Okay, so another thing which we need to cover is how we can convert between types. So what do I mean by that? You noticed that if I create an integer and I say that this integer should become equal to a long number, for example 5L, I get an error. Why do I get an error? Because long can represent larger values than int. And if I try to save a long inside an int, well, I'd lose accuracy. So I'd lose the actual value if that value is larger than the largest integer value int can represent. Okay, so I can't do this. However, I can do the reverse. I can create a long number and assign it with an integer. Why? Well, because the integer numbers all of the integer numbers can be fit into long, because long is a larger type. Same goes for double and float, by the way. So if I create a double number double and assign that to 0.4f, and you remember that f means floating point, this works. It's okay because floating point is a smaller type than double and it can fit into double. Okay, but if you want to do the reverse, if you want to say integer x equals n, like in this case we have a long number n, and we want to save that n into x, and we know that we can. Like you see that here we have 5. We know that this is a small number. For some reason we've saved it into a long. For example, let's say we've had some large calculations, and these calculations could have overflown in, but then we've got a lot of subtractions, and then those have caused the number to reduce. And we know they can fit into integer, but Java doesn't allow us to do that. It gives us a compile error. Why does it give us a compile error? Because Java doesn't know what this value could be. We could have changed that somewhere in our code to something which it can't determine compile time, and hence it can't allow us to assign the value directly. So what do we do then? Well, we do the following thing. We cast this value into the type we want. So we say, convert this thing into an integer. Now, by doing this, we sort of give our signature that we're responsible for losing accuracy. If we don't, Java says, look, you're going to lose accuracy here. Are you sure you want to do this? I won't allow you to do this unless you tell me you're sure. And the way we tell Java we are sure is by just saying that this needs to be casted into an integer. And if there's any loss of accuracy, that's our responsibility because we've explicitly requested the conversion into an integer. Now, this over here, the assignment of an integer to a long, is called an implicit conversion because it happens implicitly. We don't have to explicitly mention that we want this conversion to happen because the long data type can contain the int data type. However, since the int data type can't contain the long data type, or at least can't contain any long value, it can contain some of them but not all of them, we need to explicitly say that, look, we know that we could lose accuracy here, but it's fine, that's what we want to do. So this is called typecasting, converting one type into another by losing data, or sometimes not losing data. So implicit conversions are lossless. For example, if you assign a float to a double, that's lossless, or an int to a long, that's lossless. However, if you have a double and you want to assign that into an integer, or a long and want to assign that into an integer, well, that's explicit conversion. You need to explicitly say, yes, I want to lose the accuracy of this data type and convert it into another data type. Okay, now in what situations would you be doing that? Well, here we have a problem where we're converting centuries to minutes, but I'll give you another example. Let's say we have minutes and we need to convert them into hours. Let's say we have the task of someone needs to do a lecture, and we know, yeah. Let's formulate it like this. Someone needs to conduct a lecture, to conduct a lesson. That lesson is going to be some amount of minutes long, and once that person starts doing the lecture, they're going to spend some amount of minutes conducting the lecture. And then, let's say we want to, after they've conducted the lecture and after the students have seen the lecture, we want to provide them with a video which contains the lecture. So that video will have some length in minutes. But students don't really care about lengths in minutes since the lecture is long. They want to know whether that lecture is 1 hour, 2 hours, or 3 hours, or something like that. So let's say our lecture can be anywhere between 1 and 4 hours, and we need to get the minutes that lecture, that lesson took, the minutes that lesson took, and present those minutes as hours. Okay? So what we need to do is convert the minutes into hours and then lose part of the accuracy. So what we need to do is have an integer number of minutes. Okay, so we're having minutes. Let's say we read them from the console. Okay, and now we need to calculate how many hours these are and convert them into an integer number. So we want an integer number of hours which will be displayed to our students. So they can say, okay, so this lecture is 3 hours, or about 3 hours. Not exactly 3 hours, but about 3 hours. So that's the amount of time I'm going to need to watch it. Okay, so what will I need to do here? Well, the hours we will first initialize as a double. Okay, so how do these hours look as minutes? Well, they look as the minutes divided by 60.0. Why .0? Because .0 will convert this into a double number, and hence this division will be a double division, floating point division, which will keep its accuracy. And then I will convert it into the approximate hours, the approximate number of hours. How will I do that? Well, I'll first round the number, the hours number. So if I get 3.2 hours, that would give me 3 hours. Whereas if I get 3.9 hours, that should give me 4 hours. Okay, but math.round, we know that this gives us a round number because that's the function of math.round. It rounds a number. Okay, but we still can't assign it to approx hours. Why can't we assign it? Well, because math.rounds returns a double number. Why does it return a double number? Because it accepts a double number, and it's easier to return a double from this. Since it's already a double, we're just returning another double as a result because we don't know how this is going to be used. So that's what math.round does. It returns a double number. But we're sure that this is an integer number, so we can cast it to an integer. We can assign our responsibility here. We can say, look, I know that I may lose accuracy, but I've done my math, and I know that this value will be okay when converted into an int for my purposes. And then I can print those hours back on the console. And now if I start this program, I will see that if I enter, for example, 125 minutes, those should be 2 hours. So if I press enter, I got 2 hours. So you use explicit typecasting when you know that something can be stored as the smaller type, smaller, like in this case, int is smaller, int is less precise than double, and in that sense it is smaller than double. So when you know that you can store it without negative side effects for your program, and that would depend on what your program is and what it aims to do. Okay, so here's another example of converting centuries into minutes, and there are calculations involved here as well, and you can test these out for yourself too. Now, the last thing we need to do before we go into the break is discuss quickly the Boolean data type which we have. Now, we already use the Boolean data type, but we use it indirectly. What do I mean by indirectly? Well, whenever we say, for example, let's have two numbers, the number a, which is equal to 5, and the number b, which is equal to 10. Whenever we say if a is less than b, what actually happens is a less than b is calculated and it provides a result. What is the type of this result? Well, if you extract a variable from this result, you will get a Boolean variable, and that Boolean variable contains the result of whether a is less than b. So this is a less than b, and the type of that Boolean variable is Boolean. So this is a result that can either be true or false, and the data type for a result that can either be true or false is Boolean. So this can contain any sort of comparison. Anything you do with the comparison operators, this will be able to contain its result. Now, the Boolean data type also can be printed directly onto the console, and it prints out true or false depending on its value. Okay, so that's pretty much it for the Boolean data type. That's how it looks like. One important thing about it is that if you have a Boolean variable, even though it can be stored in exactly one bit, either a 1 or a 0, it is actually stored in an entire byte. So 1, 2, 3, 4, 5, 6, 7 zeros and 1 after them. So these are 8 bits, and this would mean true, whereas false would look like this: 4 zeros and another 4 zeros. A single byte with only zeros is false. Now, why is that? Well, the reason for that, the reason for using an entire byte instead of a single bit, is that the smallest addressable part of the computer's RAM memory is a byte, and variables can only represent at least a single byte. Variables actually represent addresses in memory, and the smallest addressable thing in memory is a byte. Hence, the smallest thing you can use is a byte. So a Boolean variable is actually an entire byte, even though it needs a single bit. And there are ways to, for example, have 8 Boolean variables in a single byte, but that's done through some hacks with bitwise operations, which aren't really the subject of this lesson, but we will see them in other places. So keep that in mind. Each Boolean isn't a single bit, it is a single byte. So if you have 10 Booleans, that's 80 bits, not 8. If you have 10 Booleans, that's 100. Whoa. How does it look like? Yeah, 80 bits instead of 10 bits. So 10 Booleans, they could be represented in 10 bits, but they aren't because computer memory doesn't work that way. Okay, so we have a task over here. We have special numbers, and a number is special when the sum of its digits is 5, 7, or 11. And now our task is what? Well, we need to iterate all the numbers from 1 to n and print whether a number is special or it isn't. So what do we need to do? Well, we need to separate a number into its digits and calculate whether that sum is either 5 or 7 or 11, and then print that out for the number. And notice how we have true or false printed over here. Now, how would we do that? Well, we do a for loop. So what is our input? Our input is to which number we need to go. So let's say we're reading a number n, int n equals scanner.give me the next integer, and then we're starting a for loop from 0 to that n. And how do we find the sum of the numbers of the sum of the digits of this number? Well, we've actually done that in a previous lesson. We've separated the number into its digits. How were we supposed to do that? Oh, and by the way, we're not starting from 0, we're starting from 1. And we're going up to n inclusive, not to n exclusive. And how are we doing that? Well, we need to get the number, and the number is I. And actually, I'll rename this to number because it will be easier to read that way. And I'll do what? Well, I'll start a while loop, and I'll say, okay, so while that number is larger than 0, I will say int digit equals that number. Give me the remainder of that number divided by 10, which gives me the last digit of the number, and then I'll say the number just becomes itself divided by 10. Number becomes itself divided by 10. And now, in order for me not to play around with the control variable of this loop, because that would move around this index which I have, I will change it back to I, to this integer which I'm floating around, and then I'll just say int number is equal to I. So I'm creating a number that I initialize with the current number I'm looking at, and then I play around with this number to get each of its digits. Okay, and my task is to determine whether the sum of the digits of this number is 5, 7, or 11. Okay, so these digits I'm getting here, I need to add into a sum. Okay, so this sum begins from 0, and each time I get a digit, I add that digit into the sum. So for each number, I will run this for loop, and then I'll have the sum of its digits over here. And now what can I do? Well, I can detect whether this sum is 5 or 7 or 11. How do I detect that? Well, I just say I can write if statements and then create Boolean variables for them, but I can also create Boolean variables directly. So is 5 will be equal to if the sum is equal to 5, and is 7 will be equal to is the sum equal to 7, and is 11 will be equal to is the sum equal to 11. So this should be sum is 5 and sum is 7 and sum is 11. And what I print is if is 5 or it is 7 or it is 11. In each of these cases I do what? Well, I just say system.out.print true. But if I'm going to be printing true or false, why not just use the value of this boolean, which I get over here, because this is a boolean value. This is the boolean value which says is special. Is it a special number? Well, it's a special number if its sum is either 5 or 7 or 11. This is what I'm saying over here, and I can directly print it on the console. System.out.println is special. So that's how I use Boolean variables. I just combine them with or and expressions, and I can use them, and I can initialize them by doing comparison operators, placing comparison operators between values in my program. Okay, so that's one way to solve this task. And you can test around if this thing works correctly. We may have made a mistake, but I'll leave solving this task up to you. And here is a solution which solves our problem the way pretty much similar to what I showed you just now. If you need help, you can look at this solution, but test it around and play around with it and see what you can get as a result. Now, the character data type is something that represents, as you might guess, characters in computing. So, how does it do that? All of the data we've seen up until this point has been of integers. So we've seen integers, not exactly integers, but numbers. So we've seen numbers in integer form. We've seen numbers in floating point form. We've seen calculations with them, we've seen comparisons with them, but we haven't really seen symbols on the console. So the character data type in Java and in other languages too is declared by the char keyword or char keyword, or however you would like to read that. Let's read that as char because it seems more intuitive. So this char keyword creates a character data type. This is the character data type. And that character data type is actually also a number. So the way text works in computers, just like I told you earlier, when you have values in computers, there are always ones and zeros. There's no such thing as characters in computers, but there's also no such thing as integers or floating point numbers. So what actually happens is we treat the ones and zeros in a certain part of memory in a certain way. So the way we treat character data types is the following way. A character is just a numeric representation which is then pulled from a table of character descriptions, so of character images. So whenever you render a character on the console, for example, you print someone's name, the characters in that name are actually just numbers which are drawn by using the images from some table which says for symbol 65, you should print the capital letter A in English, and for symbol 98, you should print the lowercase letter b in English. So characters are just numbers. Each character represents a symbol through an integer code. So there's a table of symbols, and that table of symbols has symbols matched by integers, by integer codes. And whenever you have a character, that's actually that integer code. And whenever you display that character, it just renders as that integer code. So the default value for a character is /0. /0, you might notice that these are two symbols, at least as a literal. But actually this is one symbol because the slash is a special symbol that encodes the next symbol after it. We'll talk about this in a moment. Okay, and it also takes 16 bits of memory, meaning that it is equal to the short data type in size. And the values it represents are from this thing to this thing, which is just a special way of describing the Unicode code table. So the character data type represents Unicode characters, and these Unicode characters basically allow you to represent any alphabet from any nation around the world. So anything, any symbol you can think of can be represented through Unicode. Okay, so what does this mean over here? Well, this is just a hexadecimal representation of the integer code of a Unicode symbol. So this is Unicode symbol 0, which equals this 0 default value, and this is Unicode symbol 65,535, because that's the largest number you can fit into a 16-bit integer. Okay, so how do characters look on in Java? Well, let's create some characters and see how they behave. So if I create a character data type, I can assign it, let's say this is the letter variable, I can assign it with this special literal. The character literal is a single quoted, single symbol value. So I can write, for example, a symbol here like star, or I can enter the capital letter A. And if I print this thing on the console, system.out.println, if I print this letter on the console will contain the letter A. Let's see that. Okay, so our console now contains the letter A. Okay, what can we do else with this symbol? Well, I can force it into an integer. So instead of printing it as a letter, I can say, okay, I don't want this letter as a letter, I want this letter as an integer. You remember this, we talked about this a few minutes ago, and it's called typecasting. So we're typecasting this letter into an integer, meaning that this letter will now be treated as an integer number. And if I start this, you will see that the console will contain A on the first line and 65 on the second line. Why does it contain 65? Why is A represented as 65 and not as something else? Well, if you Google the ASCII character table, or the Unicode character table for that matter, because ASCII is just a subset of the Unicode character table, you will see that symbol 65 is capital A, and symbol 66 is capital B, and so on. So characters are just integers, which when rendered, actually shorts, but you get the idea, they're integer numbers, integer code points, which when rendered on the console are displayed with a special symbol depending on what symbol represents them in the Unicode table. However, they act the same as any normal integer. What does that mean? Well, that means that if you want to print all the letters, all the capital English letters, guess what you can do? Well, since this is just a number, you can start a for loop, starting not from integer I equals 0, but from character I equals, and not 0, but the first letter in the English alphabet, capital A. And then continue on until the last character in the English alphabet, capital Z, but we need to continue inclusively, because A and Z are just numbers. We write them as symbols, but whenever I write A like this, the computer actually understands 65. And whenever I write Z like this, it understands 65 plus the difference between A and Z, the number of English letters. Okay, so let's see what this does. System.out.print, let's print them on the same line, .print I. Because I is a character now, it will be printed as a character. And now if I start this code, I will see the alphabet printed on my console. And here's the alphabet. That's because characters are just numbers, which are treated as characters when they're printed on the console, but are treated as numbers otherwise. Okay, what else can I do with characters? Well, there are special functions which I can call on characters, which make them behave in different ways. For example, I can say character dot to lowercase and supply this character I over here. So this converts this character I into the lowercase I. So if I start this code like right now, what I'd see is the lowercase letters. Of course, I could have done that by just using A and Z lowercase letters over here, but I wanted to demonstrate the to lowercase function. Now, if you call to lowercase over something that isn't a character, for example, the symbol 5, nothing will happen. You'll just receive the same character. Okay, and there are other things you can do. For example, you can say if character dot is digit I, then do something. This will check if this character is one of the digits either 0 with like a character, the character 0, or if it's the character 1, or if it's the character 2, or the character 3, or the character 4, and so on and so forth. Okay, so this is a way to check if a character, and there's also is alphabetic, which checks if a character is an alphabetic symbol, which checks for any alphabet, meaning that this will check for example, Cyrillic, whether a character is alphabetic. Okay, so this works for everything, and this is basically the character type. It's a pretty simple numerical type, but that numerical type can be treated both as a character and as a number. You can do arithmetic on it, you can increase it, you can calculate sums for it, and so on. Okay, so let's solve a task. Now there is a simple task over here where we have 3 lines of characters and we need to print them in reverse. This is a pretty simple task. We just need to read a separate line. Okay, well, it's not completely simple. Okay, let's do it. So we need the character A and the character B and the character C, the 3 characters we're going to be reading. Okay, and we need to print them in reverse order on the same line with a space between them. So what I need to do is system.out.print, and I need to print what? I need to print the first character, then the second character, then the third character. Okay, well, how do I do that? Well, one easy way to do it, I could use a formatted string, but one easier way to do it is just say print the character C and then print a space like this, and then print the character B and then print a space after that, and then print the character A and then print a space after that. That's the simplest way to do it. Now I have compilation errors here, but I have them because I haven't initialized character A or character B or character C. Okay, so let's read character A from the scanner. What can I get here? I can't do next char, and I can do simply next, which would read a string, or I can do next line because they've told me that these are each on separate lines. Okay, so I do next line, but that returns a string, not a character. Well, as we'll see in a few moments, a string is just a sequence of characters, and I can tell a string, please give me the character at position 0, or at position 1, or at position 2. So the character at position 0 is the first character in the string. So I read an entire line. That entire line is a string which contains only one symbol, and I just say, give me the 0th position of that string. String start at position 0. Okay, and I can do the same thing for character B and character C. I read a single line, and then I take the first character from that line. And I can do the printing over here, and if we start this code, we will see that these characters are printed in reverse order. But that's not really that much of an interesting task. So let's do another task, and that task will have applications in other places too. So what is the other task I want us to solve? The task is the following. I'll have a character entered from the console as a single line. That character will either be a letter or it won't be a letter. My task is to output which letter in the alphabet that character is. It could be a lowercase or uppercase letter, I don't know which. It could be a lowercase or uppercase letter, or it could be something different than a letter. And if it's different than a letter, I should just print not a letter. Okay, so let's handle that case. I read the character already, and let's check if it's a letter. How do I check that? Well, I use the character.isAlphabetic method, and then I supply that character to that isAlphabetic method. So if that character is alphabetic, I'd be doing something. I'd be doing the calculation of which symbol in the alphabet it is. Okay? Otherwise, I'd be doing what? Well, I'd be printing system.out.print line, not letter. Okay, so I have part of the task solved already. That's great. But how do I get the number of this letter in the alphabet? Let's say that if I want the character, if they provide me with the character, let's name this letter. Let's name this just letter. Oops. Yeah, let's name this letter. And this renamed the string. It sometimes renames the strings when you try to rename a letter. It depends on what you pick when it asks you whether you want to replace only code occurrences or not. Anyway, so we read a letter from the console, and I'm asking, is this alphabetic? And if it is alphabetic, I want to print which is its number in the alphabet. And let's say that for simplicity, the character A will be the value 0, and the character B will be the value of 1, and so on. Programmers count from 0. We will learn why when we get to the lesson about arrays. But let's say for now that programmers just counted 0, and that's why the letter A from the English alphabet we will treat as the 0 number letter. So the letter at position 0. Okay, so whether they enter B capital or B lowercase, or C capital or C lowercase, or A capital or A lowercase, I would still want to find out which letter this is in the alphabet, starting from 0, where A is 0. How do I do that? Well, I already know that the letter is alphabetic. Okay, so how do I find which is its position in the alphabet according to these rules? Well, since it could both be a capital case or a lowercase, one thing I can do is just convert it into one of the cases, so I don't need to worry for the two different situations. So I'd say letter is now changed to character dot to lowercase, converted to a lowercase representation, this letter. If it already was lowercase, fine, nothing will happen. And if it wasn't lowercase, it will be changed to lowercase. So I'm only dealing with this case from here on out. Okay, so what do I do here? Well, what I know is that each character has a number, right? And if I check the number for A, it will be 97. In the Unicode table, A is the symbol 97, and B is the symbol 98, and C is the symbol 99. You see a pattern here? So A is the symbol 97, and B is the symbol 98, so they're sequential, and they're just numbers. Well, if I need to print 0 for A, then I just need to subtract A from A, because 97 minus 97 equals 0, and that gives me that 0 I need for A, because 97 is the code for A. And if I subtract 98 minus 97, that would give me 1. So if I subtract B minus A, so if I do B minus A, which is 98 minus 97, that would give me 1. And 1 is the value for B, like I want in this task. And same thing goes for C. If I subtract the code for C, if I subtract from it the code for A, I'd get 2, right? So that gives us the number 2 for position 2 in the alphabet. So that's all I need to do. I need to say int position equals subtract from the current letter what? Well, the first letter in the alphabet. Subtract, not assign. So the position is the letter's position currently minus the first letter in the alphabet. And I'm using lowercase a because I've converted this letter to lowercase. Okay, so let's print this out on the console now. System.out.println position. Let's print this position and see what we get. Let's see if my code is correct, if I correctly print positions in the alphabet. Okay, so printing for A. A is position 0. Great, that's what I wanted. Okay, let's do that for lowercase c. Lowercase c is second position in my alphabet. Is this what I wanted? Yes, that's exactly what I wanted. Okay, so this is a way of doing arithmetic with characters. Now, homework assignment. It's not really a homework assignment, but something I suggest you try to implement. 2 characters will be entered on the console. These characters will be entered one after another, directly one after another. So you will get, you know what, it's not 2 characters. You will get a number, n, so you will get an integer number n, let's say 3, and then you will get 3 characters entered on the console, like, for example, like so. And your task is to calculate the sum of all the digits in those letters. So this would be 8. How would we do that? Well, we'd read the number 3, then we'd read a string with next line. So we do just next line. Then we start a for loop starting from I equals 0, because the string started 0, until I reaches less than 3. And then we'll take charet I. And that's our letter. Okay, and now for the letter, what do you need to do? Well, you need to check for the symbol. It's actually better to call it a symbol. And then for the symbol, you check, is it a digit? And if it is a digit, you need to convert it into a number, because the digit 3 isn't the number 3, it's some value in the ASCII table. But you can convert it into a number the same way we converted the position in the alphabet to a number, because the digits in the ASCII code table are ordered in the same way. So you won't be subtracting A, you would be subtracting the code of 0. Okay? So you get the numeric value of this digit by subtracting 0 from the character, and then you add it to the sum. That's basically that task. Do that, implement that. It's good practice for processing text and processing digits from text. Okay, so let's continue on. We solved this task, and there's a solution we can check. Now, another thing we need to know about characters is that since there are special characters in code, we need to have ways of escaping them. For example, we can't create a letter directly in our code. We can't have a literal for the new line in our code. So we can't say letter equals these apostrophes, and between them we can't press enter like this, because this is a new line, but the code doesn't support that. It can be a space, that's fine, but it can't support an actual new line. It also can't support the tab symbol. It can only support the space and normal symbols. Okay, so how do we create literals for example, new line? Or for stuff like, how do we create the letter apostrophe, the symbol apostrophe? So let's call this a symbol. We can't just place 3 apostrophes here, because apostrophe simply means a character begins here. So how do you render an apostrophe inside a character? How do you write the literal for an apostrophe? Well, for such special cases, we have the so-called escaping of characters, or this is a way of saying that the following symbol will not be a part of the code, like char is a part of the code and symbol is a part of the code, and this apostrophe is a part of the code. Inside these apostrophes, slash followed by a symbol means render that symbol. So this is not a part of the code, because if I just enter a single apostrophe, well, it treats it as a part of the code and it gets confused. Okay, as part of the Java code, I mean. And it gets confused because it doesn't know what I'm telling it. But now I'm telling it, okay, listen here, I want you to add this symbol as a symbol. I'm not typing in code over here, I'm typing in the actual symbol. And there are such escaping symbols for a lot of things. For example, new line is escaped like this. If you want to have a character that represents the new line symbol, you write \n. And if you want a character which represents the tab symbol, you write \t. That means the tab symbol. And if you want a character, which is the default value of a character, which is the so-called no terminator, which is this thing is equal to just the value of 0 casted to a char. So this and this are completely equal. They're the same thing. So the character code 0 and this way of representing the character code 0 are the same. So there's escaping for this. And guess how you add a \, into a symbol? Because now you know that \, means something special. Well, how do you escape a \? With a \. So double \, means single \, if you're saving it, if you're writing a character literal in your code. This only applies to your code. If you're reading from the console, characters are just characters. But since in code, apostrophes mean something, and quotes mean something, and slashes mean something, there's escaping for them in your code, only in your code. So that's what escaping is. So if you want to enter an apostrophe, you do it like this. If you want to enter a quote, if it's for a character, you can do it like this. But if it's for a string, you need to do it with a backslash. Or you can do it always with a backslash if you're unsure. Backslash and quotes just means quotes. And quotes work inside character quotes, inside apostrophes like this. But if you have a string, well, the rules change, and then since strings, if you have a string message which equals hello, well, a string is surrounded by quotes. Hence, you can't add a quote over here because it confuses the code and it doesn't understand. It thinks that the strings end here, the string ends here, and then you have some other quote after that. And in order for it not to treat this as the closing quote for a string, you just write a backslash in front of it, and that would print the text HEL and then quotes and then LO. Okay, so let's print these. System.out.print line, print the message, and print this symbol, and let's make the symbol be a backslash. And to make it be a backslash, we need to write double backslash and start this code. We will see what I described earlier. We will see the HEL apostrophe HEL quote LO and then the backslash. If you don't do the escaping, you get compile time error, compilation errors, because here it sees, okay, this is a closing quote, and it thinks that the message is hell, and after that there's some low variable which we've added. And for the symbol, it thinks that this apostrophe isn't the closing apostrophe. Why? Well, because it sees a backslash over here, and the backslash means the next symbol isn't a part of the code. Hence, it's missing something here. So if we want just a backslash, we have to write two backslashes. Okay, and here if we want a quote, we need to write a backslash quote. Same goes here for backslashes. If you want to render a backslash inside this hello string, you need a double backslash. So launching this, we will see H backslash EL quote LO. H backslash EL quote LO. Now, if this is confusing where you need to add a backslash and where you don't, just play around with it. It takes some time getting used to, but it's not very complicated. And there's a list of other escaping symbols. You can also do this backslash U, meaning Unicode, and then the hexadecimal representation of a Unicode code point. And that would allow you to render any character over there. Okay, so here are some literals and what they look like when printed on the console. You can play around with these if you want. Here are the tab symbols. Here are some traditional Chinese symbols. Here are a Unicode. Here's a Unicode letter, which is just the letter O represented in Unicode, and you can play around with these values a bit so you can get used to them. Okay, so the last part we need to talk about are strings. So strings are just sequences of characters. Just like we had this character data type, well, there's a string data type which represents a sequence of characters like this. So the string data type message over here, each of its symbols is actually a character, one character variable for each symbol. Depending on what language you're using, it might not be one character for each symbol, but it will mostly be one character for each symbol. So the string keyword is what it creates, and if you don't initialize it, it has a value of no, but this default value we will meet when we get to the lesson about arrays. So up until this point, you can ignore this no thing, which we've entered here. And you always write string literals in quotes. That's why you have to escape the quote character. We've seen those already, and one thing we can do with them, except represent symbols and read from the console and parse them into numbers, is concatenate them using the plus operator. So you can do, if you have a message, if you have the message hello, and then you say print on the console the message plus space plus world, this will print on the console hello world, because it will attach this space to the end of hello, and then it will attach world to the end of this space, and this will print hello world on the console. Okay, so if we're printing a file name with a string, we need to keep in mind that we need to add the double quote. So if we're initializing it inside code, so by the way, here's the hello world. If we're initializing a file path inside code like this, then we need to escape. This is called escaping. Whoops, we got a double. We need to escape each slash, for example, in a Windows file path, with another slash. So if you see a backslash, you add another backslash in it. If you want a character literal directly, so if you're writing this inside your code, you want to be doing escaping. If you're reading it from the console, you don't need to be doing anything. You can read directly from the console, because the console isn't Java code, whereas this is Java code, and to order that Java code to render a backslash, you just need to type 2 backslashes for it. Now, we've already seen what else there is here for using strings. We've already seen the string.format function. If we want to, in addition to concatenating strings, we can use the string.format function to get a string built from a few different pieces. So instead of concatenating these with a space like I did previously, like I did over here when I said message plus space plus world, instead of printing like that, I can create a string which is string formatted, which equals string.format. What do you want me to format? Well, I want you to format 2 strings one after another with a space between them. Okay, so one string, a second string, a space between them, and here I can supply my message and this world string I want printed. And now if I say print this formatted thing on the console, I will get hello and space and world printed out. We've seen this already. Oops, what did I get? I didn't get hello, I got the message from this escaped Windows path, but that's still a good example of what happens when you're escaping paths. These double slashes became single slashes because they're inside my Java code. Okay, so this is how you format these strings, how you can build them as a single entity, or instead of using format, if it's something more simple, like it's in this case, it's just the space separated strings, you can just add that space separation through concatenation. Okay, so that's one thing you can do with strings, and here's an example of how you can print the first name and the last name of a person and that into a string. So this formats a string, generates the full name from the first name and the last name, and then prints that into another format in which the string is at the last place. This is just playing around with formatting strings. It's not something very advanced in comparison to what we've already done. And if you want, you can also use the string concatenation not just on strings, you can use them on strings and numbers. So if I have, for example, an int age which is 42, and if I have a string name which is the answer, because the answer to the universe and everything is 42. Okay, so if I print now name plus space plus age, this will convert 42 into a string and will print it on the console. So strings are pretty convenient to work with in Java. We don't need to do anything special, we just concatenate them with pluses and they just work. Okay, so we have a task in which we have 2 names entered on the console as single lines, and we need to combine them with a separator. Okay, we can do this in a few ways. let's do it in the easiest way, which would be string first name, get that from the scanner next line, since we've been told that these are on separate lines. Get that from the next line from the scanner, and then get the last name from the next line of the scanner. And then what do we need to do? We need to get the separator. Well, string, actually they call it a delimiter here, not separator. Okay, so let's call it a delimiter. And get that from the console. Okay, and now how do we print these joined with that delimiter? Well, we just say system.out.print, and we concatenate these three strings. So we concatenate first name with the delimiter followed by last name, and that would print our string on the console. Let's see it, if it works. So this thing is waiting for me to enter two names. So let's say I'm Georgiev, and it's waiting for the delimiter. Let's say that the delimiter is money, because we all like money. Okay, so we got George Georgiev with the delimiter of $3 signs. And that works because strings can be concatenated easily one after the other. Okay, and we can test around with the other delimiter, but we won't play around with that now. The point of this demonstration of strings was to show how strings function in Java, and they're pretty easy to use. We can concatenate them using plus. We can also concatenate them using string.concat, which just accepts the parameter for the string to concatenate with. So this could have been first name.concat with delimiter.concat with last name. And each of these operations produces a new string. So string.concat with this delimiter will produce a new string on which we call concat and add the next name, and this we can replace the plus code with this concat code, and it would do the same thing. Now, another thing which strings have in them, which is useful, and which we haven't really covered in this lecture, is if we say want to iterate each symbol of a string, what we can do is start a for loop starting from 0 and continuing until, let's create a string s over here, which is hello. We can create a for loop which starts from 0 and continues up until s.length, gives us the length of this string, and on each iteration of this for loop we can do system.out.println of s.give me the character at that index. Now this accesses each of the characters of the string, which is a note back to that task I made up for you to do at home if you're into it, of filtering out which symbols in a string are digits and summing them up. Well, you'd be doing that with something like this. You'd be iterating the string until you reach its length and reading each of its characters by doing s.give me the character at that position. So this is a character, this is the current character, and printing that current character on the console in our case would just print H, E, L, L, O, each on a separate line. But if you want to do something more special, you could, for example, like the task I mentioned, do a check like if character dot is digit, if the current character is digit, then, and guess what, you, in that task which I offered you a few moments ago, you would be checking if this is a digit, and then if it is a digit, you would be converting it into a number by subtracting the character code of 0 from it, and then adding it into a sum. Okay, so this is how you walk the characters of a string, and this is how you can do some operations with them. Now, there's of course a lot more to talk about regarding strings. We will have a separate lecture about a separate lesson about text processing further on, so don't worry about that. This is just an overview of the data type of string and how you can use it. We will see a lot of other ways to use it and modify strings and so on. But for now, we finished up our current lesson. We talked about variables. We talked that they are a way to store information which can later be processed by the computer. We talked that there are different data types of variables, and there are numeral types which represent integer, floating point numbers, and so on. Some of them are very specific, like the integers, whereas floating point numbers aren't very accurate, and calculations with them are fast but not completely 100% on the mark. And if we want something to be 100% on the mark when calculating, we can use stuff like big decimal. We also talked about string and text types. We talked a lot about escaping and how you can convert symbols into numbers and back. And we played around with joining up and concatenating strings. And now we know that strings are just sequences of characters, which are Unicode characters, which represent pretty much any language you can think of. So we now know data types, and we can use these data types in our programs, understanding how they function. So I hope this was useful for you. And of course, if you have any questions, please ask them in the channels we have provided for you. And well, until next time, bye-bye.
In this lesson, your instructor George will explain and demonstrate how to work with arrays, reading arrays from the console, processing arrays using the for each loop, printing arrays, and simple array algorithms. You will learn how to declare and allocate an array of certain length, 2 ways to read an array from the console, how to traverse and print array elements from our existing array, and how to access an element by index, and how to modify an element at certain index. Along with the live coding examples, the instructor George will give you some hands-on exercises to gain practical experience with arrays and other mentioned coding concepts. Let's start learning arrays.
Hello everyone, this is George, I'm your technical trainer, and today we're going to be talking about arrays in this lesson. And this lesson will actually complete our knowledge base for writing complete computer programs. I was going to say Turing complete, but we'll need to explain that in a bit. So up until this point, we were writing programs with one very important component missing, and today we will see how we can use that component to our advantage, and we will learn all the power that comes with using arrays. So what are we going to talk about today? Well, arrays is our main subject. We'll talk about what they are, how we can create them, how we can use them, how we can read them from the console, and of course write them to the console, meaning how we can do input and output of arrays from the console. Then we'll talk about stuff like string.split. We'll talk about using a for loop to read the arrays. We'll talk about printing them with loops, and we'll talk about printing them with standard functions like string.join, and we'll figure all that out. And then we'll talk about the for each loop, which we haven't yet encountered up until now. We'll see how that works, we'll see what we can do with it, and we'll have some fun with this new concept, which will complete our knowledge base for writing fully featured programs. Now, I'm repeating this concept of writing fully featured programs and accessing the full potential of programming. But what do I actually mean by that? Well, up until this point, we were creating programs which had branching. So our programs had branching of logic. So we could split our code execution into two parts. And we also had a random number of repetitions of some piece of our code. So we could branch our code, and we could repeat our code a number of times that was determined, for example, from the input from the console. However, we're missing a pretty important part of all of this, so we could, in order to write complete computer programs. Now, each computer program, each complete set of instructions and computer supports needs to have branching, needs to have repetition of code a number of times, which isn't determined compile time, meaning that, for example, you read an integer from the console, and that determines how many times you repeat some piece of code, or other conditions determine it. So those are two important things, but there's a third thing, and the third thing is allocating memory, and more precisely, allocating memory dynamically. Our current access to memory has always been through variables of primitive data types, and these primitive data types, although they do initialize memory, the amount of memory that the program needs is known compile time. We know what number of what methods we have, and these methods have variables in them, and these variables allocate memory. However, we have no option of allocating a random amount of memory during our execution of the program. So while the program executes, we're basically working with what we've coded into it from the start as memory. So however many variables we have created, well, we have that many bytes of memory, depending on, of course, the sizes of our variables. So there's a strict correlation between them. But very often, a program will need to increase the memory it uses based on user input or other conditions it encounters. So often you will have you will have code that needs to allocate additional memory. And we're missing this part. We can't yet do this. So let's learn how to do it, and Arrays will allow us to do exactly that. Now, to illustrate the problem, let's do a demo. So let's say we have a task in which we have to read integers from the console. Let's say we have numbers like so. So we have 4, 5, 1, 3, 7, and our task is to reverse these numbers and print them in reverse order. And even, let's not keep them on the same line, let's have them on separate lines. We want these numbers on separate lines, we want them entered, and let's have an initial number which tells us how many of these numbers there are. So in this case we have 5 numbers, so this will be the number 5. And let's make this one 42, so it's a bit easier to see where the numbers start and which part of the input is the number of numbers and which are the actual numbers. So let's change them to 42, 15, 31, and 7, for example. So these are our numbers, and we need to reverse them. So we have an initial count of these numbers, and we have the numbers as a sequence, and we need to reverse that sequence of numbers. Now, how would we do that? Well, let's say there are a fixed amount of numbers. So we have, like in a previous lesson, there was a task where there were 3 characters entered on the console, each on separate lines, and then we had to reverse these characters, and that was pretty much easy because we already knew the amount of characters on the consoles, because we already knew there were always going to be 3, so 3 lines of input. In our case, we don't know that. We are told the number of inputs on the first line of the console. So, but let's say we want to solve the task for the example of 5 elements. How would we do that? Well, if we don't know how to dynamically allocate memory, what we are forced to do is just create the variables which represent the input which we got. So we'd have something like int number 0, because programmers count from 0. You will see why I count them from 0. And then we'll have int number 1, and then we'll have int number 2, and then we'll have int number 3, and then we'll have int number 4. That's all of the numbers, right? Those are 5 numbers, just like in this case. 5 numbers counting from 0, that gives us a minimum index, let's call that an index, of 0, and a maximum index of 4 for 5 elements. Okay, so what do we do now? Well, we're going to need a scanner. So let's create a new scanner that reads from system.in, and we'll initialize that and put it into a variable, and that variable we will call scanner. And how do we read from that scanner now? Well, I just say number 0 equals scanner.nextInt, and continue on reading like that until I reach the end of my variables. And I'm limited by exactly that. I'm limited by the amount of my variables. Now, we could play along a bit here and write some conditional statements like if there are only 2 elements, we can only input these 2, and then if there are 3 elements, we can input these 3, and if there are 4 elements, we can input these 4, and so on. And that would be pretty ugly code, but it could work if we initialize all of these numbers. So let's reverse them. After we've read them from the console, let's reverse them. So how would we reverse them? Well, we'd say system.out.print. Let's print them on the same line with spaces. So system.out.print number 0 with a space after it, and then system.out.print number 1 with a space after it, then system.out.print number 2 with a space after it, and so on for number 3, and so on for number 4. Okay, and again, we could do this with ifs. So we actually need to read our size first. Int size, let's just call it size, the number of numbers, or sequence size or something. Okay, so this is scanner.nextInt also, because we need to read this size variable at the start, and then read our numbers, and then print them out. Now, of course, this code has a problem. The problem being that we can't actually work with this size we have. We are still allocating all of the variables we need for reversing the data. So we have a problem. We have a dynamic amount of memory we need to allocate, because it is determined at runtime. So it's not a compile time determination of memory which we use during which we determine during writing the code. It's a runtime determination of memory, which comes just like any other condition that can occur during our program. In this case, it comes in the form of user input from the console. So we can't know what input the user will add here. So we can't know how many variables to initialize. Now, in most programming tasks, you would know what the maximum value is. And I guess you could do something like initialize all possible numbers. Let's say you know that the maximum value will be 100. What do? Well, you keep initializing numbers like this until you reach 100. So you'd have a lot of numbers and then number 100. And then you'd read, you'd have an if before each nextInt reading, and whether and based on how many numbers there were entered in the initial input, well, then you'd do conditional checks which compare exactly with that amount of numbers. So you would do, okay, so how many, if your size is 1, you would be reading just this number. If your size is 2, you would be reading this number, and then you would be reading this number. If your size is 3, you would be reading the first 2, and then be reading the third number, but won't be reading the fourth number, and so on. So you get the idea. We would have numbers read one after the other, and we'd have ifs before reading each number. Now, obviously, this is very non-optimal. Even if we could do it, and we can't really do it because we don't know how many numbers there are going to be as a max value. Yeah, I just said if the max value was 100, okay, we could probably write them all. But if there were 4 billion or even larger, well, we can't do that. We can't do it, at least in a reasonable amount of time, and coding would be a nightmare if you had to do it like that. Okay, so what do we do in that case? Well, most programming languages give you one or another method of allocating dynamic memory. So allocating memory which is not known compile time but is known runtime. So what do I mean by that? Instead of initializing a fixed number of variables, what we do is initialize an array. Arrays allow us to initialize dynamic amounts of memory. So instead of having number 0, number 1, number 2, number 3, and so on, what we would have is, after reading our size, after we know how many elements we need, we would create a so-called array. How are arrays created? Well, arrays contain elements, just like this sequence of variables contains elements. It contains the number 0 and number 1 and number 2 and number 3 and so on. Okay, so arrays contain elements, and those elements have some type. So if we want to read numbers, well, we want to create an integer array. And how do we create an integer array? We begin with saying integer. It's pretty much the same as creating any variable. However, because we don't want a single integer, we want a certain amount of integers determined by the input, we place brackets over here. So what this tells Java is this isn't a single variable, meaning that it's not a single piece of data, it's multiple pieces of data. So this int array can contain multiple pieces of data, and we'll call it numbers. So up until this point, it's pretty much the same as initializing a variable, only you need to add these square brackets. Okay, so we have the numbers, and then we say these numbers are equal to a new, just like we used new for initializing big decimal and big integer or string and so on. The same way we use new to initialize an array. And now here we say new int because we're having an int array, an integer array. We say new int, and what Java wants to know is how many ints. So it says this is an array, and it needs to know how many ints we want to initialize. Okay, so how many ints do we want to initialize? Well, we want to initialize a size number of ints. So whatever the input was stored in size, we need to initialize that number of integers. Okay, so this creates a so-called array, and that array contains this amount of elements, meaning that this line of code initializes as many ints as there is size entered here. So if we got 6 for size, then this will create 6 integers in memory. If we got 2 in size, it will create 2 integers in memory, and so on. Okay, and numbers points to that memory. So numbers is the variable which contains the array. So this is the array, and we are saving it into this variable. Okay, so how do we use that numbers array? Well, we could do the same like we did here, although it wouldn't be initializing an int variable on each line. It would just be, let's remove these, it would just be numbers, and then to access an element of numbers, we just open brackets and then write in the index we want to access. So just like we had number 0, number 1, number 2, number 3, and so on, we can do number 0, number 1, number 2, number 3, number 4, and so on. So this accesses the element at that position. So for 5 elements, this would be the first, the second, the third, the fourth, and the last element. Okay, and if we want to print them, what we can do is, again, access them by their index. So we don't say number 0, number 1 directly. We place these brackets around the index we want to access. So these brackets are your multi-tool for arrays. You declare arrays with them, you define their size with them, and you access their elements with these brackets. So this code, up until this point, is pretty much the equivalent of what we had for the variables. The only difference is that we're using a non-fixed number of elements for initialization. Okay, so now the next cool part is that we don't need to do it like this, because this over here is just a variable, right? This is a value. This is the integer literal 1, integer literal 0. And this is the integer literal 1, and this is 2, and this is 3, and this is 4. Wherever we can place a literal, we can place a what? We can place a variable, correct? Okay, so how can we walk through all of these numbers over here, and instead of typing in manually, based on the size, instead of typing in manually, how can we do this automatically? Well, we're repeating the same piece of code, right? We're repeating the access to the element, the reading from the console, so we're repeating code. This code executes, and it should execute this amount of times, a size amount of times, correct? Okay, and the only thing that changes is the index over here. Well, guess what can start from an index and reach another index and repeat a piece of code by supplying it its index? Well, that's the for loop, or one of the other loops. So what we do is just say, create a for loop starting from 0 and continuing up to, now we could use size, but since we've initialized an array already, and arrays in Java know their size, we can directly access the size of the array. So we can say numbers, and from here on out, to access something of an object like numbers, the same way to access nextInt from a scanner we use a dot, well, in the same way we use numbers dot to access its length, because length and size are both members of, in this case, scanner, and in our case, the numbers array. Okay, so length is just the amount of items there are in this numbers array. So now we start a for loop, and that for loop will start from 0 and continue until there are numbers. Okay, until its index reaches the maximum index of numbers, which in this input example over here is 4, because there are 5 elements, and counting from 0, that gives us the maximum index of 4. And now, instead of writing each of these lines on our own, we can just say numbers at position I, assign that to the next integer from the console. And this will execute these operations for us. So we will run a for loop, and this will execute these assignment operations for us. Okay, so that works. We just assign values to a numbers array, and we can now use the values from this numbers array. And guess what? We can also print the same way. So we read like this, and to write, what do we need to do? Well, we need to start another for loop, but instead of starting it from 0, because we want it to print in reverse, remember, we want them printed in reverse. Okay, so starting instead of from 0, we want to print the items of the numbers array in reverse, meaning we need to start from the last item. Okay, so which is the last item? Well, we already said that for 5 items, the last item is at index 4. So this would be index 4, but how would we calculate index 4 in another way? So for 5 items, it's index 4. So for length items, like we have here, for the number of items, we have length minus 1, because 5 minus 1 is 4, so length minus 1 is the last index in an array. Okay, and what is our check? Well, we need to start from the last number and continue up until the first number. So we're going to be going in reverse, meaning we're not going to be increasing I, we're going to be decreasing it. And we're not going to be checking whether it's smaller than something, we're going to be checking whether it's greater than or equal to something. And that something, that last item we're visiting, is 0, correct? The index 0 is the first index in an array. Okay? Just like index 0 is the first index in a string, by the way. That's why when you say char at 0, it returns the first character in a string. So that's where that comes from. Okay, so we got that. And now what do we need to do? Well, here's what we were doing previously. And now it's the same code, only that we don't print the element at index 0. We print the element at index I, whatever I is. Okay, so what did we get just now? We have a very small program in comparison, which can work with any size we enter, regardless of what that size is, as long as we have enough RAM memory to store an array that big. Okay, we have that, and then we just have two for loops, which iterate based on the length of that array. So not only did we solve our problem, we also are able to use the variables, the variable size of that dynamic memory, and start for loops based on it. We don't need to repeat code for each index. We just submit that into a for loop and only change the index we're accessing. So in addition to allowing us dynamic memory allocation, arrays allow us dynamic access to elements. So in this way, we don't have a fixed number of variables we can access. We have a dynamic number of variables determined by the input. Okay, so we have this. Let's see if it works. So we're printing the numbers. Okay, let's get this input. How can we get it? I'll hold down Alt and I'll mark vertically like this. Okay, copying this and starting the program. Let's see what we got here. Okay, so the program is now running. Let's add our input to it. So 5 items, 42, 15, 1, 31, 7, and we expect them ordered in reverse. And that's what we got. 7, 31, 1, 15, 42, the 5 items. We don't have a new line at the end, but that's not a big deal. We can always add it over here. We can always add it at this part of the code. Okay, so this thing worked. Great. Let's see from what we can do with arrays from here on out. So this is what an array is. An array is just a normal variable which stores multiple data points, multiple parts of information. You can think of it like storing multiple variables inside a single variable and having the option to access them programmatically, meaning that you don't need to know their names. Their names are just formed by the name of the array plus the index at which that element is located. And other than that, the reading and writing of these elements is the same as using any normal variables. If the variable was called numbers I or numbers 1 or whatever, it would be accessed and written to the console, read from the console in the same way that any other variable can be. So each of the variables here inside the numbers array are just normal variables which you can work with like any other variable. Okay, so these variables here are called elements. So an array contains elements, and these elements have indices. An index is just the position of that element in the array in relation to the other elements. So you have the element at position 0, you have the element at position 1, you have the element at position 2, and so on. Arrays are continuous pieces of memory, meaning that you have your RAM memory over here, and you have an array, in our case our array numbers, and that simply points to a place in memory where the array starts. And you have the item, the element 0 over here, and then you have the element 1 over here, and then you have the element 2 over here, and then you have the element 3 over here, and the element 4 over here. For a 5-item array of numbers, that's what you have in memory. So each of these, since numbers was an integer array, each of these is 4 bytes. So this is 4 bytes, this is 4 bytes, this is 4 bytes, this is 4 bytes, and this is 4 bytes. So for a 5-item array, this is a sequence of 5 times 4 consecutive bytes in memory, meaning 20 bytes in memory for this whole entire array. And these bytes are consecutive. That's very important for arrays. That's why arrays can work the way they do by accessing elements, because they know that their items are always sequential. That's, by the way, the reason they start from 0, because numbers points to the first position, and to get to any position you need to offset from where numbers points. And how much do you offset? Well, if you want to offset to the first position, you need to move 4 bytes to the right. And if you want to go to the 0 position, well, you move no bytes to the right, because numbers points to the first position. Okay, so that's what an array is. An array is just a sequence of integers in memory which we access programmatically using an index. Okay, and let's go back to the lecture and start examining them in more formal details. So an array is a sequence of elements. It is typically illustrated like somewhat of a sequence of squares which are numbered with indices from 0 to the length of the array, to the number of elements, minus 1. Okay, so this is an array of 5 elements, and arrays have a fixed size. You can't change the size of an array. Once an array is created, it will always be that size. You can change what the variable points to, because the variable is just a container for the array, meaning that this is the array, and this is a variable that happens to point to this array at this point in time. Later on, we can just say that numbers is something different. So we can say numbers is now a new integer array of 3 elements. And this would forget the old elements. So numbers will start pointing to a new array. The old array will be detached from this numbers variable, and it will drift along and be removed from memory at some point when the Java runtime decides that we're not using it anymore. And numbers will be pointing to a new array. So we're not resizing the original array, we're just forgetting about it and using another one. We're making numbers point to a new array. Okay, elements in an array are always of the same type. For example, you can have an array of strings, an array of characters. A string, by the way, is an array of characters. You can have an array of doubles, you can have an array of integers, but they all need to be of the same type. This thing over here is what you call the element index, and the indexes start from 0 and end at length minus 1, length of the array minus 1. Okay, so how do you create an array? We already saw some parts of this, but let's play around with arrays a little bit more on the more formal side. So how do you create an array? You name the data type of the array, the data type of the elements which will be contained in this array, and then let's say that data type is integer, and then you write brackets, a closed pair of brackets, square brackets, and then you type in the name of the variable in which you want to store the array. So let's call this again numbers. Okay, and then you need to initialize it, you need to create an array, you need to dynamically allocate memory for an array. So you say new integer, and then you say how large this array needs to be. So there are a few ways you can do this. First off, you can just say create me an array of 3 elements. Okay, so now you have an array of 3 elements, and you can start accessing the elements by just mentioning their index. So saying numbers, then opening these brackets, which I said are your multitool. Any operation you're doing on an array is probably going to involve them. Okay, so numbers and accessing the element at index 0 is done like so. You open the square brackets, you mention the index you want, in this case 0, and then you can assign a value to this. So you can say numbers at position 0 equals 42. And numbers at position 1 equals 13. And numbers at position 2 equals 255. Now, the same way you assign them, the same way you print them. So the same way you get access to an element for assignment, you use the absolute same syntax to get access to an element for printing. So what I do here, I'd say system.out.print line, and I'd access numbers at position 0. So this would print the first element, and if I start this piece of code, numbers will get initialized with 42, 13, and 55 as its 3 elements, and then we'll print 42 on the console. Okay, now what else can I do? Well, what happens if I don't initialize number 0? So I created an array, it has 3 elements, I initialized numbers 1 and numbers 2, but number 0 has never been initialized. What would happen, what would come out on the console for things that I haven't initialized? Well, the answer for integer is 0. Why did I get 0? Maybe because the index is 0? Well, no, it's not that. Let's misinitializing another number, so let's say that number 0 is after all 42, and let's skip numbers 1, and let's print that one out and see what gets printed on the console. Well, again, we will have 0 printed on the console. Okay, so it's not the index. How does Java decide that this should be 0? Well, if you remember the lesson about data types, you will recall that there we had a thing called a default value for data types. So for integer, that default value was 0, and for floating point numbers, that default value was 0.0, and for characters, that was the 0 character /0, otherwise named /0, or the no terminator. And if you remember strings, the value for string was what? The value for strings, the default value for a string was no, meaning that if you have an array, the values of the strings in that array will be no's until you initialize them. That's the no value. No just means a lack of value. Okay, we'll get to that in a bit, but this is how you can initialize values in an array. So let's get back to initializing all of our items and see how we can use a shorthand for that. So we're saying numbers 1 is now initialized by the value 13 like it was before, and instead of writing this down, when you know what your elements will be, like in this case we know what our elements will be, compile time or runtime. We know it compile time because we have initialized them specifically with the literal tree. The literal we know compile time. I'm writing it right now. And the values, I also know compile time in this case. So when you know your values compile time, you can just do like so. You remove this size over here, and then you place the items inside these curly brackets after the square brackets of the integer array. So you place 42, 13, 255, and you can press Ctrl-Alt-L to format the code so that the spacing is more pleasant for the eye. And now we have the equivalent of initializing the numbers array like so. And if I print the first item, the item at index 0, at index 1, I would get 13 printed on the console. And here we go, we have 13 printed on the console. Okay, and again I can iterate this array with a simple for loop. I can say for index starting from 0, continuing until we reach numbers.length, and that would give us at each iteration we'd have each index in the numbers array. Not that I is specifically tied to the numbers array, but since it's increasing from 0 up until numbers.length, at the first iteration I will be 0, the second iteration I will be 1, and at the third iteration I will be 2, meaning that we would access each of these elements, 0, 1, and 2, and we can do whatever we wish with them. Let's say we can print them on the console. System.out.print, and let's print that number at that position. And we can add a space after it, and we can even add, after that printing, we can even add system.out.print line, print an empty line so that the array is represented on a single line on the console instead of having something else after it. Okay, so starting this, we're going to see 42, 13, and 255 printed on the console with spaces. Okay, so that's one thing we can do with arrays. What else can we do? Well, let's get back to the lecture. So this is a way of initializing a numbers array, and as I said, all elements in that array are going to be going to contain the value 0 initially. If that's an array of integers. Now we can also initialize them by using these curly brackets as I demonstrated, and we can assign values through a for loop. Now I already showed how we can assign values through reading from the console. This example here just assigns each index, each position to the value 1. So all of the elements in this numbers array are going to be the number 1. So there are going to be 10 ones in our array of numbers. Okay, so length holds how many elements you've got in this array, and this brackets operator accesses the element at that position. You can play around with the elements any way you want. You just need to mention the name of that element, and the name of the element is just the combination of the name of the array and the index of the element placed in square brackets. Again, we did this a few times already, so I hope you already got the drift of what we're doing. It's just 10 integers, 10 integer variables, and the name of each variable is determined by the numbers array, and an index, a number, which determines its place in that numbers array. Okay, now what happens if we access an element outside the numbers array? Meaning, what happens if we access index 10? Well, what's the maximum index for an array of 10 elements? It's 9, right? 10 minus 1. The maximum index is always, max index is always length minus 1. Okay, so what happens if we access the position at length? So what happens if we say, give me index length, give me the element at index length? Well, what happens is a so-called array index out of bounds exception, meaning your program crashes with an error message containing this inside it. We will explain exceptions in another lesson, but for now all you need to know is that the program will crash. So you cannot access elements outside of your array. Same thing would happen if you have a negative index, if you try to access index minus 1. Okay, so that's an array, and that's how you access its elements. Now let's have an example of what we can do with a string array. We can initialize a string array and place, for example, the days of the week there, and then we can have some code which enters the day of the week, and we print the name of that day of the week. So let's do that. Let's have an array of strings, a string array, days, or even day names, and we'll initialize that with a new string array which contains the elements Monday, Tuesday, Wednesday. I won't be typing in all of them because it will take more time than it's necessary. These can be on a single line, they can be on multiple lines, they can have empty lines in between them, although I wouldn't suggest that. You can do any configuration of initializing them like this. The only thing you keep in mind is that when you're specifying the values at initialization like so, like literals, you have to omit the size of the array. Why? Well, because the size of the array is determined by how many items you add in. Okay, so what do we do from here on out? Well, we can let's say we have a task in which we need to read a number from the console. That number will be a number between 1 and 7. That's important, between 1 and 7. Okay, let's add all of the days so we can implement the task fully. So Thursday and Friday. I won't be singing because you will not want to watch anymore. Okay, so Saturday. There was a song about Saturday too. And Sunday. There are a lot of songs about Sunday and on Sunday. Okay, anyway, so we have our weekdays, and we're going to have an input between 1 and 7, and we need to print the name of that day. So 1 will be Monday, 2 will be Tuesday, and so on. So let's read that. Let's call the scanner and ask it for the next integer and say that this is the day number, but not the day index, because I'm saying the day number will be between 1 and 7, not between 0 and 6, right? So what do I need to print now? I need to say system.out.println, and what would I be printing? I'd be printing day names, and I'd access day number. Well, yeah, but if someone inputs 1, I'd get Tuesday, because this is index 0, and this is index 1, and this is index 2, and this is index 3, and so on. And the last index is index what? Index 6. Okay, so if we're going to get input which is in normal human numbering, starting from 1, we need to access the element 1 less than that. So if they enter day 1, we need to access day names 0. So starting this code, this would give us the name of that day which we've inputted. So if I input 4, I should get Thursday, because Thursday is the 4th day of the week. So enter, and I got Thursday on the output, exactly as I expected. Okay, so this is one way you can use an array to index values, index some names, and access them through a number. Okay, so we just handled that, and here we have a problem which is exactly that concept. One thing in addition, we have to print invalid day if we don't get a number between 1 and 7. So that would be just an if condition that prints something else if the index is different than the range 1 through 7. Okay, so here's a solution which does that, and again, I suggest you write that code yourself. Okay, so let's do a reading of an array, and then we'll do a break. A simple reading of an array. Now, we already saw how we can read an array by knowing its length as input from the console, because that's the first thing we did. The first thing we did was enter a number from the console and then initialize an array with that size. So how does that happen? Well, you read the number of items you're going to need, then you initialize an array with that number of items, and then you start a for loop starting from 0 and continuing to that number of items, although here I'd prefer r.length, because I already know that this array is at most this number of elements, and I don't need the n anymore. That way I'm reducing the span of n, because I'm not using it as... Well, I'm reducing the usages of n, and I'm using only the array and its own sizes to determine the loop. But n is fine too. Okay, and then I just start an iteration which starts in at index 0, it accesses element 0 and it reads it from the console. And then at index 1, it accesses element 1 and reads that from the console. And then at index 2, it accesses element 2 and reads that from the console, and so on and so forth. Okay, so that's how you read an array from the console, if you know the size, if the size has been entered on the console. But if you don't know the size, there are other ways to read an array from the console. So one of these ways is by reading an array from a single line on the console, and this is actually a pretty common case when reading input from the console. Now, how do we know when to stop? Well, if we have a fixed size, we execute our loop that number of times. But if we don't have a fixed size, we need to have something else which indicates when we should stop. In this case, because this is a single line on the console, we know that that single line will end in the new line character. And do we have a function that reads until it reaches the new line character? Well, yes, we do. And that function is called scanner.nextLine. So what we do now is we'd say scanner.nextLine. That will read us these symbols. So this will get us a string containing these symbols, only the symbols. Those symbols are not yet numbers. We don't have an array yet. We actually have an array of characters, because a string is just an array of characters. So this string line is just an array of characters, but they're still characters. They're not numbers separated into multi-character sequences which represent integer values. Okay, so how do we get them as such numbers? Well, lucky us, the string object, our line here, has a split function. What does the split function do? Well, you supply a separator by which you want to split. Actually, you supply a regular expression, which we will talk about in a further lesson, by which you want to separate your values. Now, if you just want to split by spaces or any other character, you just type in this character over here. And after you split on this character, split, well, guess what it returns? It doesn't know how many elements it's going to get, so it needs to count the elements, allocate a dynamic amount of memory, and place those elements in that dynamic memory. Well, guess what it allocates? It allocates an array. So here are our elements. Okay, so how did we get them? We got them as strings. Why didn't it return it as numbers? Well, because it doesn't know if those are numbers. I could have entered something like hello world and read that from a single line of the console, and that would actually be an array of strings. So splitting a string just gives us the elements as strings, and from there on out we have to decide what to do with these elements as strings. Okay, so in our case we have a string array of elements, and we want to have an integer array of elements. Okay, so let's create an integer array of, let's call them numbers. How large is this array going to be? Well, it's going to be as large as elements, so I'd initialize it as a new integer array, which is as big as elements.length. Okay? And from here on out, we just need to copy the values from the indexes at elements into the indexes at numbers. So we have, for example, if we entered 12, 42, 13, after splitting this single string into multiple strings, what we get is 12 as a string, then 42 as a string, and then 13 as a string. Okay? So this is an array of strings. This is the first string, this is the second string, this is the third string. So this is the string at index 0, this is the string at index 1, and this is the string at index 2. And now we want to have an array with 1, 2, 3 elements, which also have index 0, index 1, and index 2. And what do we need to do? Well, we just need to get the string from index 0 of the strings, and then convert it into an integer. How do we convert it into an integer? We use the integer.parseInt method, right? So we do that for index 0. So what would we say? Our numbers array at position 0 will become assigned to the value of our elements array. I just deleted our beautiful artwork, doesn't matter. So if we were just doing it for the first element, we'd be doing numbers at position 0, assign that with elements at position 0, but we can't assign it directly. What did we need to do to convert the string into an integer? We need to integer.parseInt it into an integer. So this is a string, and we're getting an integer from that through integer.parseInt. Okay, and that gives us the numbers array element at position 0. But we don't need to do that just for element 0. We need to do it for element 1, 2, and for element 2, and for element 3, and so on. So how do we do that? Well, we run a for loop. So we say start a for loop from 0, continuing up until, now both elements and numbers are the same size, but since I'm writing into numbers, I prefer to use their size. So numbers.length. Okay, and now we just say for a single index it was numbers at position 0 equals element at position 0, and that parsed to an integer. In this case, since I will always be the next index in the array, we just do numbers at position I, assign that with integer.parseInt of elements at position I. And that's it. We now have our numbers entered over here. and we can do whatever we wish with them. Just so you see that the reading is correct, let's start the code and see in the debugger how the numbers array looks like. And now we'll combine reading an array from a single line on the console with viewing an array in the debugger. Okay, so let's input 13, 42, 255, minus 1, 5. Okay, and press enter. Let's see, it seems that our code reached this part, and now let's see if our array looks correct. So here's our array. We can expand it over here and see its elements. So, oh, I actually expanded the elements array, but that's fine too. Let's see them both. So the elements array are the strings 1, 3, 4, 2, 255, minus 1, or dash 1, and 5. Those are the strings. What did we get in the numbers array? We got the numbers 13, 42, 255, minus 1, and 5. Okay, so we read them correctly. And if we want, we can print them on the console or calculate a sum for them or whatever we want to do. But this is how you read a line of integers from the console. These 1, 2, 3, 4, 5, 6 lines do that. Pretty neat, huh? It's a pretty short program for reading something which we haven't yet gotten any practice with. So here's some code which does the same thing. And you can do it with functional programming too. There is the Stream API in Java, which allows you to do such sequence operations one after another over an array. So how can you do that with a single line of code? Well, you tell Java to convert your items into a stream. Streams are things which can be managed by doing operation on each of their items. And then you say, for each of the items, where item is this, where I'll use this as the name of the item, parse that item into an integer and use this result, and convert that to array. Now, if this seems a bit like dark magic to you currently, it's because it is. So, it's actually not that complicated, but it's too soon for us to explain fully what this does. However, since you're probably going to see this functionality somewhere on the web and wonder why haven't we shown this to you, well, that's why we're showing this to you. And if someone is interested, they can study this even further on. But for now, it's completely okay to read with for loops. Actually, I prefer reading with for loops, even though I can use this and I understand how it works. I mostly prefer to read with for loops because it's a bit more explicit on the operations you're doing. You can do it even shorter. You can say create a stream out of the splitting. Instead of creating a separate variable which you create a stream from, you can say arrays.create a stream from that split which I just got and map each element to an integer. How do you map it to an integer? By doing to each element an integer.parseInt and convert that back into an array. Again, if that's a bit too weird for you currently, don't worry. That's normal because we haven't studied the concepts of objects and we haven't even studied methods yet, so it's normal for you for this to seem weird to you. It will get clearer as we go along, and you're not obliged to do it, but if you're interested, see and work out how this works. Study it online. Okay, let's continue on with the next part of the lecture, which will concern ourselves with printing arrays and the different ways we can do that on the console, and we'll also solve a few programming problems related to arrays. Okay, so how do we print an array on the console? Well, we already saw some of that. Let's say we have an array initialized with a few strings, let's say, and we want to print its items. Well, how do we do that? And let's print not just the items, but let's also print the indices of these items. So let's say array and that index is equal to that value. How do we do that? Let's write some code over here. So we could use our array which we just read from the console, but let's not overdo it. Let's just initialize a string array and work on that. So we have a string array, and that string array will have items. Let's call them words. And these words are initialized through a string initialization here, and we'll place the words hello, and then we'll place the word world in the array. Okay, so we want to print these words on the console, and we have several options to do that. First off, we can do the for loop, like we did for the normal integer array. It would be the same, the exact same for the string array of words. Okay, so we start from index 0, we continue until index matches words.length -1. That's the last position we want to. We continue until we reach words.length -1, meaning that the index should be less than words.length. So the last position we want to match is words.length -1. At the point where we have an I which is equal to words.length, we need to stop the loop. Okay, so now what do we do? Well, we just print out the word at that index. And I also said let's print out the index along with it. So let's print a formatted string, system.out.printf, print a formatted string. And in that formatted string, I want to say that words at position something, at position digits. So actually, let's write it simply, and then we'll replace whatever we want. So words at position I, we want to say that that is equal to So we want to say words at position, some position over here, is equal to the value at this position. So we want to say that words at position, for example, words of 0 equals, let's say, hello. That's what we want to print. So let's say that we want to have words 0 equals hello. That's what we want printed for the first element. Okay, so let's generalize this for all elements. So this would print words 0 equals hello for all iterations of the loop, but that's not what we want. We want to do this concept, but we want to do it with the specific values of the element at index 0 and element at index 1 and element at index 2 and so on. Okay, so this won't be words 0, but it will be words, the digits of an integer number. What is that integer number going to be? Well, it's going to be the index in that words array. And now we need to just print the word at that position, and since it's a word, it's going to be a string, and that string we print with %s, and to place that into the format, we need to access words at that index. So starting this code, and we might want to have a new line at the end. And starting that code, we'll see hello and world on two separate lines. Here we go. Words at position 0 is hello. Words at position 1 is world. Okay. So we just printed out an array of strings on the console. We also saw we can print it out just the words themselves. We can separate them with spaces. Now let's do something more interesting. I want us to print each word, and I want the words to be separated by spaces. But I don't want actually, okay, let's do it like this. I want the words separated by commas. So I have a word, and I have a comma, and then I have another word, and I have another comma, and so on. Okay, so how would I do that? Printing the words is simple. Let's just print them like this. So starting it like this, we'll just print the words with no separators between them. So I will have hello world attached, concatenated on the output. Okay, so how do we add a comma, you say? Well, one way is to just attach the comma to the printing operation, but this will not exactly work, right? Because it will print commas between our words, but it will also print a comma at the end. And we don't want that comma at the end. We want the end to finish without a comma. We only want commas in between our strings. And by the way, we need a new line at the end so that we can separate our output from the debugger messages, like this one. Okay, so we're printing a line to separate ourselves from this debugger message, but we still have the problem of the comma after the last element. So again, this is somewhat of a debugging challenge. How do we cause our code to only print separators until it reaches the last element? We don't want a comma after the last element. Well, obviously, we won't be printing it each time. So we will be printing it under some condition. Under what condition do we print the comma? Well, we want to print only when we are not at the last word. How do we check whether we are at the last word? Well, we say if the index equals words.length -1, then we are at the last index, right? So this here is the last index. because words.length minus 1, the last index of an array is always the length of the array minus 1. So in this case we have item 0 and item 1, element 0 and element 1, and the total size of these elements is 2. So minus 1 would give us exactly the last index. Okay? And in this case I would only need to print words at this position. Otherwise I would print words followed by a comma. And this should work. If I start this code, I will see hello and world separated by a single comma and with no comma after world. So that's fine, but I want to make this code look a bit better. So now I have a lot of repetition. In both cases I'm printing words at position I. So in both cases I'm doing this. The only difference is that when I isn't length minus 1, I print a comma. So I should kind of reverse this, right? If I'm doing something in both conditional statements, if I'm doing the same thing in both conditional statements, well, that means I'm doing something wrong. That if in both in the if and the else I'm doing the same thing, then I probably need to be doing that thing outside of them, because whether it's true or not, the statement I got into the if, in both cases I'm printing. So let's take this out of the condition, and what would remain is I'd switch these around. So I'd say if I is less than words.length minus 1, meaning that if I'm at any other position, any position other than the last position, I want to print a comma. In all other cases, if I get to the last position, I won't print a comma, because if I becomes 1, which is the last position here, what will happen? Well, is 1 less than words.length minus 1, words.length minus 1, words.length is 2, minus 1 equals 1. Is 1 less than 1? Well, no, it isn't. And since it isn't, this comma will not be printed. Okay, so starting the code like this, we will get the same result, but the code looks a bit more understandable. Okay, so that's what our code should do. That's how we print an array of items, separating them with a separator and ensuring that the separator doesn't get to the end of our array. It is only between the elements and not after the last element. Okay, so we did that. And that's one of the ways in which we can print a list of integers on the console. Now, here's a task we already solved. We have an array, which is defined on the console as a single integer followed by that number of elements, and we need to print them in reverse. We already did that at the start of this lecture, so we won't repeat this task. The solution which we have over here is pretty much the same one we implemented ourselves. Okay, however, let's see something else. In addition to printing ourselves, if you have a string array, and this only works for string arrays, not for other array types, if you have a string array, instead of coding this all by your own, this printing with separators, you can simply use the built-in string functionality. You can use string.join. Now, string.join accepts one parameter, which is a delimiter, in this case a comma, in our case where we wanted to separate them with commas. A delimiter which is a comma, and the array of things which it needs to join, in this case are words. So string.join, getting this delimiter and these words, will generate a new string, which we will call comma separated words. So this variable will now contain a string, a sequence of symbols, which are separated, which are our words, converted into symbols and separated by commas. And now we can simply print these comma separated words and see what happens on the console. We will see hello comma world printed on the console, just like we did previously. So instead of writing that yourself, if you have an array of strings, well, you can use string.join. Now, if you don't have an array of strings, you can use the code which we implemented a few moments back. Or another option would be, well, what happens if you have a list of an array of numbers? Well, you convert it into an array of strings. How do we do that? Let's convert an array of numbers into an array of strings. So let's say we have an int array which is numbers, and we want to place that into this words array. Okay, so let's say that numbers, for simplicity, we won't be reading it from the console. We'll just initialize it with a new integer array, and we'll place 1, 2, and 3 over here. Okay, and now we want to convert this integer array into a string array. And how would we do that? Well, the way we do that is go through all of the items in the numbers array and place them in the matching positions in the strings array. So first we need to initialize the strings array with that appropriate amount of elements. So we'd say numbers.length, initialize the string array with numbers.length. And from here, we just need to loop through the words array. So I'd say start from index 0, continue until you reach words.length. And at each position in words, place the number from numbers. Okay, so we can't do this directly because numbers is an integer array and words is a string array. So we're trying to put an integer in the place of a string. But that's something for which we have an easy conversion. Just like we have integer.parseInt, which converts an integer into a string into an integer. Well, the same way we have string.valueOf, and we supply it with an integer number or something else, and that converts it into a string and saves it into words. So now let's print these numbers on the console separated by a comma using this functionality. And we got 1, 2, and 3 printed on the console with commas. Great. So we have that implemented now, and we have another way of printing to the console. Just convert your numbers array into a strings array by copying the items using string.valueOf, and then just use string.join to join them. Now, there are advantages and disadvantages to this approach. Of course, to do all of this, we need to have an entire string array, which we need to print. Whereas if we just iterate the numbers and use the code we wrote a few moments ago, which manually separates them by a delimiter, well, in that case, we wouldn't need to allocate a new string array, and that would use up a bit less memory. But if you're not concerned about memory in the program you're writing, this is a completely fine solution. Okay, so I just showed you string.join. By the way, you can also join by nothing. If you leave this as an empty string, well, that would just concatenate these strings which you entered. So instead of 1, 2, 3 with commas, you would just receive 1, 2, 3 as a sequence of characters. Okay, so that's another way in which you can print arrays to the console. Now, we have another interesting task over here. We need to reverse an array of elements, but instead of just printing them reversed, now up to this point we were printing reversed when we were reversing. In this situation, we want to reverse the array itself, so we need to exchange the items inside the array, like so, like it's demonstrated over here. We need to exchange the last item with the first item, the second item with the second last item, and so on. Okay, how do we do that? Well, there are a few ways we can achieve that. Well, the easier way is to just create another array and start from the last index of the first array and copy into the first index of the second array. And so you're copying in reverse. That's one way of doing it, but let's not cop out like that and actually swap the items in place. This is called an in-place algorithm. What does in place mean? It means that it works in the place it has begun, meaning that starting it on an array of strings will reverse that array, not create a new array, meaning it won't need more memory than is needed for the input. Okay, so let's say we have these words again. It doesn't really matter how we get them. Let's say we get them from these Okay, let's actually initialize these words as input from the console, since it's good to practice our reading of arrays. So let's say we have a list of strings from the console on a single line, and we need to read them into array of strings. How did we do that? Well, we used scanner.nextLine to get the entire line of strings, and then we split that by spaces, because that's our separator here, spaces. Split that by spaces and receive our array of strings. So this is a string array, and let's call it, we can call it strings. It's not necessarily words, it could be symbols. So we have our strings array over here. And now all we need to do is walk that strings array and swap out indexes. Okay, so let's leave the printing logic over here. So we're printing strings, comma separated words isn't really accurate anymore, so let's just inline that variable, meaning let's remove the variable and just place the expression we just used wherever we need the printing to happen, and we need to print them with a space. Okay, now the current code will just read strings from a line on the console, split them into spaces, and then print them joined by spaces again. We need to swap around these items in such a way that the last items become the first items. Okay, so how would we do that? Obviously we need a for loop, so we need to be accessing elements inside the array, and each of these elements we need to do something with. What are we going to do with each of these elements? And for how many elements are we going to do it? Let's take a look at the slides again. So what do we need to do? We need to exchange the first item with the last item, and then the second item with the second last item. And how many times do we need to exchange? Well, since each time we're touching two elements, that means that we only need to do as many operations as there are elements divided by 2, since each time we're playing with 2 elements. So if we have 5 elements, 1, 2, 3, 4, and 5, how do we exchange these? Well, we exchange 1 and 5, and then we exchange 2 and 4, and that's it. We don't need to exchange anymore, because if we continue exchanging, we reverse it again. So we only need to continue until we reach index, the index that is the number of elements divided by 2. So if we have 4 items, how does that look like? 1, 2, 3, and 4. Well, it's again, we exchange 2 and 3, and we exchange 1 and 4. If we have 4 items, 1, 2, 3, 4, 5, if we have 5 items, I meant, we exchange 1 with 5, 2 with 4, and that's it. So in both cases, we reach index 2, meaning actually we reach index 1, because index 2 is the index we shouldn't be reaching. This is index 2 here, this is index 2 here. So in both cases, our loop runs from 0 up until it reaches the index before index 2. So 0, 1, and we stop at 2. And 0, 1 here, and we stop at 2 again. Okay, so whether it's an even number of items or an uneven number, an odd number of items, we, in both cases, go until we reach the dot length divided by 2, and we need to reach before this, so less than this. Okay, so we need a for loop that goes from 0 to strings.length divided by 2, and now we just do what? We need to exchange 2 indices. Which are these indices? Okay, so the first index we need to exchange is just index I, whatever index we're at currently. So index 0, index 1, index 2, index 3, index 4. So I becomes index 0, and this is the first index we need to exchange. And we need to exchange it with which index? Well, index 0 we need to exchange with index 4. What is index 4 expressed through the variables we have? Well, index 4 is strings.length minus 1, right? That's index 4 in our case. Okay, what happens when I becomes 1? So I becomes 1, pointing at the character B. Which index do we need to exchange that with? Well, we need to exchange it with index 3. What is index 3 described as variables which we have? Well, strings.length minus 1, and then minus 1 again, right? So string.length minus 1 is the last item, and strings.length minus 1 and again minus 1 is the next element. But what is 1? Well, 1 is I, right? So I is index 1, and this is what we're using over here. And if you think about the first index, well, here we also have minus I, but it's minus 0 because I is 0 the first time around. So what's the formula for the opposite index on the other side of the array? It's just int, let's just say that this is the left index and this is the right index. So the right index is what? It's strings dot length -1, that gives us the last element, and then we need to offset it as much as I is offset from the start. So if I is offset from the start by 0, we will offset it by 0, and then if it's offset from the start by 1, we will offset it by 1. Run this formula around in your head, do a few calculations with it, and you'll see what happens. You'll see that this provides the exact indexes we need. Okay, so we have the left index and we have the right index, and we need to swap them around. How do we swap around two variables? Well, you probably know by now that to swap around two variables, you need a third variable in which to store one of the two, because you would be overwriting one of those two, and you would need to use the swapping variable to overwrite that one to the other value. So, simply said, if you have a bottle, I know that's a weird bottle, bear with me. So, let's say you have a bottle of water, and you have a bottle of tea. Let's even give it a bit of color. Now I know this doesn't look like tea, but bear with me, please. Okay, so you have a bottle of water and you have a bottle of tea. Let's indicate that this is water. Okay, so a bottle of water and a bottle of tea. In order to exchange them, well, you can't just pour the water into the tea or vice versa, because you'd mix them. Okay, what you need to do is grab another bottle. So grab, let's say, this bottle over here, which is empty, it doesn't contain anything, and move the contents of the water bottle into the green bottle, then move the blue bottle's contents into the red bottle, so the previous water bottle's contents are now filled with the yellow of the tea, and now this green bottle, which got the red bottle's water, needs to be moved inside the blue bottle. So you need a third variable. How do we do that? Well, let's create a third variable, string, and let's say this is old left, the previous value of left, and we'll assign that to strings from the position, we'll assign that to the string at position left index in the strings array. Okay, so old left is strings, give me the position at left index. Okay, so that's old left, and now what do we do with the left index? Well, we just say strings at the left index should be assigned with the value of strings at the right index, so right index of strings. Okay, and now we just need to, we now have whatever was at the right index, we have it at the left index, and now we just need to set the right index to contain what was previously at the left index. So strings right index, assign that with the value, with the old value of the left index. And that's it. We just swapped around our lists. Let's see what we're going to get if we have any errors here. Okay, so we're running this, and let's say we want to input. Let's input the input we had in the presentation, A, B, C, D, E, and let's see if it switches them around. Yes, it does. And now we should try out with an even number of values, because that's where we could have a mistake. Okay, let's go with 1, 2, 3, 4 and see. Okay, that converted it into 4, 3, 2, 1. Okay, so we solved that issue, and the code over here is pretty much the the code which we had in our case, and you can check it and try to implement it yourselves. Okay, let's continue with the last part of the lecture, in which we will see another for loop. Now, we already talked about loops in a previous lesson. However, this is a new type of loop which is strictly related to arrays or other types of sequences of elements, and we will study about other types of sequences further on. So this loop is the so-called for each loop. The for each loop, or sometimes called the range-based for loop, or the for in loop, is a loop which is specifically created to iterate through collections. What does that mean? That means that instead of writing loops which traverse an array by indexes, what you can do is create a for each loop which goes through all of the elements inside that array without needing to reference the index. It only references the item itself. So how does that work? Well, it works by providing you an element at each iteration, but not providing you an index. So you only have access to the element itself, but not the current index. Okay? It's a read-only loop, meaning that you can't actually edit the items inside the array. We'll show that in a bit. And it looks like this. You type in for, just like you would for a normal for loop. But after that, you specify the collection you want to iterate, like, for example, an array. You prefix that with a column, and you say that you want to iterate each item inside that collection, and you can use var instead of writing the type name of whatever you have in the collection, or you can just write, if you have a collection of integers, you just write int item. So this says at each iteration you will be supplied with an item variable, which will be the next item in that array or collection. So let's do that in our code. So here we had a printing of strings on the console with a space. Actually, let's get rid of that one, and let's just initialize a normal array of strings and test on with that. So here's our array of strings. We'll initialize it with a new string array containing the words hello and arrays, because we're talking about arrays today. Okay, so we have our strings array. Now, normally we do a for loop starting from index 0, reaching up to strings.length, and actually not reaching that index, not executing for that index, so I being less than strings.length. And then, what do? Well, we start printing, for example, our strings. Let's say we do system.out.println the string at that position, so strings at position I. And just so we make this a bit more clearer, strings at position I we can assign to a variable which we can call item. So we get the current item from strings by accessing that index in strings, and then we print that item. The exact same result we will get if we do a for each loop. How do we do a for each loop? We type in for, we open the brackets, and we say what type of data do we have in our strings array. Well, we have strings. So we have the string item inside our strings array, and for this item we can do system.out.println item. That's it. That's the range-based for loop. That's the for each loop. The for each loop is just a shorthand for an iteration of items inside a collection, whether it be a list of strings collection, or an array of strings collection, or a linked list, or a lot of other collections we will be studying can be iterated through this for each loop. Okay, so what effectively happens? Well, effectively this loop just goes through the indexes in this array when it's executed for an array, and it gives us an item variable which we can access to print it. We can name it however we want. We can name it S if we want to, but I named it item, so I match this string item variable over here. So this loop and this loop are pretty much equivalent currently. Let's get back to the item name. This for each loop and this for loop are pretty much equivalent. They have the same effect as in sequence of handling of elements, and they have the same result printed out to the console. So both of these will print hello and arrays on the console. Let's see them in action. We'll wait a bit. And here we go. We have hello and we have arrays on the next line. And then we have hello again and we have arrays again on the next line. Okay, so that's what the range-based for loop looks like. Now, what you don't have access to here, as you notice, is the index. We can't access which index we are located at currently. So you don't know whether item is the first item or the second item or the third item or whatever. So you only use this range-based for loop if you just want to go through all of the elements in a sequence and do that. If you want to do something specific, like swapping around elements or assigning new values to elements and so on, that's something you need to have a normal for loop to do. Okay, so saying that, can we actually use the index even though we don't have access to the index? Let's try to use the index regardless. So how can we print at which index we're located currently? I want to print the following thing. I want to print 0.hello and 1.arrays, formatted like this. This is what I want output on the console. So how would I do that with a range-based for loop, with the for each loop? Well, let's remove the old for loop. Well, I might not have the index directly, but what's to stop me from creating an integer variable, calling it index, starting it from 0, and incrementing it where? Where does the for loop increment its index? At the end of the body, correct? So let's do the same. Let's increment the index at the end of the body. And now all we need to do is just go over here and print the index, then followed by a dot, and followed by the item. Now if I start this code, I will get 0.hello and 1.arrays. Here we go. So I can still use an index, but I need to code that index myself. Okay, so let's add a space here so we see what, let's see the formatting a bit better rendered. Yeah, this is what we wanted initially when we said we want to have a prefix of the index. So yeah, 0 dot space and the item. That's what we printed. How did we do it? We just used an index variable which was external to our for loop. And yeah, this index variable is visible outside of the for loop and can be used outside of the for loop, but we don't really care about this in our current program. What we care about is the fact that we managed to get the index of the current element. Now, not all collections will have such a thing as an index, but you can still count up to which item you've reached. You can count how many items you have in your array of strings, for example. Okay, so that's one thing you can do with for each loop. Now, what you can't do with the for each loop is say item, assign that to, for example, a sequence of dots. So doing this, yeah, the code will compile, it will run. Let's see what happens. So I'm assigning the item to a sequence of dots. And on the output, yeah, I actually do see that I'm outputting sequences of dots. Does that mean that I just lied to you and that I can actually change the item? Well, not exactly. Meaning, if I now iterate these strings again, so I'll add the same for each loop, but I won't be changing anything. I'll just say strings, so I don't need to write the for each loop. I will just ask IntelliJ to do it for me. So I write strings, I press Alt and Enter, and I say iterate, and it generates the for each loop for me. So for each item in strings, print that item. I won't need the index. Let's ignore the index, and actually let's ignore that index from the previous code as well, so it doesn't mess with our thinking about what's happening. Okay, so we're just printing the items, but in the first loop we're assigning values to these items, whereas on the second loop we're just printing them. So what would we expect to see? Well, if this actually changes the items in the strings array, then the second printing should still print the dots, right? Not the words. Let's see what happens, however. What you're going to see is that the items remain what they were. So we're not actually changing them. All we're changing is the current, let's say, copy of the item. So each time you create a for each loop like this, you're actually receiving another name for the item. You're receiving another variable which indicates the same item in strings. But if you change the entire variable, you're not changing the string itself in the strings, you're changing the new variable. So you get a new variable that points to this string the first time. And if you tell that variable to point to something else, because assignment of strings and of other objects doesn't override the existing object, it just overrides the variable which points to it, and that variable now stops pointing to hello and starts pointing to this string, to these string dots. And if we iterate it again and not mess with the variable, it will still point to whatever it was supposed to point. So here we're not changing the item itself, we're just changing. Imagine in this for each loop, on each iteration, we just receive, let's say that this is a apartment, and we're walking through apartments, and we're visiting the first apartment, and then we're visiting the second apartment, and so on. So in order to visit the apartment, we need to know the address of the apartment. So by doing a for each loop like this, what we're actually doing is receiving an address. You know, like First Broadway Street or something. So we're receiving First Broadway Street and we're visiting that First Broadway Street. And this First Broadway Street, we're receiving it written on a piece of paper. So this is our piece of paper. It's not the apartment itself. It's just a piece of paper which has information about where that apartment is located. So this variable is just something that contains information by which Java finds where the actual object is located in memory. And if we take that sheet of paper and just scribble something on it, we won't change the apartment itself, we won't change the apartment, we're just changing the sheet of paper's address, and it will point to something else. And if we try to visit that something else, well, we will see something else. But we didn't actually move the apartment, we just received a copy of the address, like we received a card, a business card, which indicates the address. If we scribble something on that card, that's our problem. The person which gave us the business card still has another business card and still has their address. So we didn't change the address itself, we just changed what was written on the business card. So by changing the business card and printing it, yeah, we printed something else because we scribbled on the business card, but the original business's owner still has their apartment and still has other business cards which they can hand out. And if someone else visits the actual business card addresses, they will see the actual apartments. Whereas I am seeing something different than the actual apartments. I'm seeing whatever I scribbled on the business cards. So editing the item inside the for each loop doesn't actually edit the item inside the array. Here you're just receiving, you can think of it like receiving a copy of the item. So the for each loop receives copy of the items. A copy isn't exactly the correct description in the long term, but for now it's a good way of understanding it. Imagine that you're receiving a copy of the string. Okay, and iterating it like this will just print that copy of the string. Okay, in reality it's a variable which points to the same string, but you're not changing the same string by assigning a variable, because assigning a variable just changes to what the variable points. So instead of that variable pointing to hello, it will begin to point to this new string object I just created. Okay, so that's pretty much all you need to know about this for each loop. You can't edit items inside it. Just forget about doing that. Okay, and we now have an example of printing a list of numbers with the for each loop. I showed you how to do printing strings, so it's pretty much the same thing. It doesn't matter if it's strings or numbers or floats or doubles or booleans or whatever. Okay, so we have a task over here. We have a problem which we need to solve. We have an array of integers which is going to be entered on a single line on the console, and we need to sum all even and all odd numbers. So we need to we're only caring about the elements right now, right? We don't care about the indices of those elements. We only care what type of element we have, whether we have an odd number or an even number. Okay? And then we need to find the difference between the even sum and the odd sum. Okay, so how do we do that? Well, we have an input of a line of numbers. Let's read that input of a line of numbers. So we can directly use our strings array, but instead of initializing it ourselves, we will read it from the scanner through the next line method, and we will split it by spaces. Okay, so now we will get the numbers, but represented as strings in an array of strings. And now we need to convert that array of strings into an array of integers. So here are our numbers, and we will initialize these numbers with a new int initialized by the strings.length. Okay, and now what do we do? Well, we need to copy these strings from here into our numbers. So we need to start a for loop from index 0 to index numbers.length, -1 effectively. And we need to set the numbers array's position I to the value of strings at position I, but we need to parse it into an integer. Integer.parseInt of that strings at I element. Okay, so this is how we get the element. And now what do we do? Well, we have the numbers, and we have to calculate the sum of the even numbers and the sum of the odd numbers. Well, since we're calculating both of these values, we need an integer even sum, which starts from 0, and we need an integer odd sum, which starts from 0. Okay, and now what do we need? We need to iterate each item in this array check if that item is even or odd, and add it into the appropriate sum. So how do we do that? Well, we just start a for each loop, since we don't care about the index, and every time we don't care about the index, we don't really want a normal for loop. It's easy to make a mistake with the indexes in the for loop, but it's not easy to make a mistake with the for each loop because there's not much you can make a mistake with. So let's do a for each loop. So numbers, I type in the name of the collection I want to iterate, and then I press Alt and Enter, and then I pick iterate, and it generates a for each loop which walks through each number in the numbers. And what I need to do is, if that number is divisible by 2 with a remainder of 0, so I have no remainder when dividing this number by 2, then I need to add it where? Into the even sum. I need to add that number into the even sum. Otherwise, there are no other cases except that remainder being 1. So if the remainder is 1, I'd add it to the odd sum. Okay, and I just now need to print the difference between these. Okay, so for 1, 2, 3, 4, 5, 6, I should get the result 3. Why do I get the result 3? Well, because I have the number 1 is odd, 3 is odd, 5 is odd, so I get 8 from that. And I have the even numbers are 2, 4, and 6, and I get 2 and 4, 6, and 6 is 12, and I subtract, okay, I'm not, my calculations are wrong, this isn't 8, 3 and 5 is 8, so 3 and 5 equals 8, and 1 more equals 9, so this is 9, and the sum of the even numbers is 12, and the difference is between even and odd, so I need to subtract odd from even, and I'd get 3. Okay, let's see if that works. I need to print on the console system.out.println even minus odd. Okay, and now start this and I'll see what happens. I will copy the input from these examples and test it out in this in the console. So for this input we received 3, that seems correct. Okay, we should receive minus 35 for this. Let's check with a negative value, so with a negative result. Pasting this, minus 35. Okay, so now I should test around with the other inputs so that I can be sure that my program is working correctly, but I will not be playing around with that currently. I will just continue on with the lecture. My advice is, again, solve this task by yourself and try to test with different inputs and see how you can implement it in another way. Maybe implement this task with a normal for loop, see how that changes things, and so on. Okay, so here in the solution which were provided, we have reading of the input through a stream. You can play around with this one too, instead of using my approach of reading from the console with the for loop. Or you can continue with using, or you could do this approach, you could do my approach of just parsing items one by one. Both of the approaches will be fine enough at this point of the course. And from here on out, it's pretty much whatever we wrote a few moments ago. Okay, so before we reach the summary, let's do one more thing. So before we reach the end of this lecture, let's do some nested iteration of our numbers. So let's solve the following task. We need to find the smallest difference possible between two numbers in the array. Okay, so what does that mean? Well, for our array of 3, 5, 7, 9, and 11, the smallest difference, and that's kind of a boring example because all of the differences are 2. Between 3 and 5 it's 2. Between 5 and 7 it's 2, and 7 and 9 is 2, and 9 and 11 is 2. And all other differences are larger. We need to find the smallest difference. Okay, let's pick some of this data. All of this data is kind of boring. Okay, let's figure out our own data. So let's use this as an example. We have the array which contains the items 7, 1, 13, 5, 2, 33. So we need to find the smallest difference between two numbers in this array, but not consecutive numbers, any two numbers in this array. So any two numbers which aren't the same number. So we need to check, how do we check this? We obviously need to check every number with every other number. So what we do is check this number with this number, and then we check again this number with the number 13, and then check this number with the number 2, and then check this number with the number 33, and so on. And then we do the same for number 1, then we do the same for number 13, the same for number 2, and then no need to do it for number 33 since it doesn't have another number with it. So actually, how do we do it? We do the checks with 7 and 1, then we do the check of 7 and 13, then we do the check of 7 and 2, then we do the check of 7 and 33. Okay? And for the number 1, do we need to check back as 1 and 7? Well, no, we're looking for the smallest absolute difference, so we don't need to recombine them the other way around. So instead of checking 1 with 7, we'll just check 1 with 13 directly. So 1 with 13, then 1 with 2, then 1 with 33, and that's it. And then for 13, we'll check 13 with 2 and 13 with 33. And then for 2, we'll check just 2 and 33. So these are the checks we need to do. So for each number in this array, we're comparing it with each number after it, and we're looking for the minimum difference. Okay, since we're looking for a minimum difference, what do we need to create? Now, first off, this is a standard part of this is a standard task in programming. Find the minimum. So we're searching for the minimum, but it's not the minimum element, it's the minimum difference. So since we're searching for a minimum, let's create that minimum. So we're searching for a minimum. We'll call it min difference. How will we initialize that min difference? Well, I do the following. I'd assume that the difference between the first and the second element is the minimum difference. If it isn't, I'll prove that by iterating the elements, so I'll replace that. But initially, I'll start with the difference between the first two elements. And I'll have a requirement that my array of strings has at least two elements, otherwise it's not really... there's nothing to search a minimum difference for. If we have an array of just one element, or 0 elements, that's also possible, by the way. If we search for the minimum difference in an array of one element, well, we can't make a pair of elements for which we need to find the difference, so yeah, that doesn't work. Okay, so the minimum difference is mat.absolute value, and mat.absolute value of the difference between numbers at position 1 and numbers at position 0. I can swap them around if it would be easier to read. So numbers 0 minus numbers 1, it doesn't really matter since we're calculating the absolute value. Okay, and I need to print this. And you're saying, okay, but you haven't calculated everything. Yeah, I haven't. But I like to frame my program like this. I like to initialize whatever I'm going to be calculating, and then print it, and then somewhere in between I need to implement my code which does the work. Okay, so how do I do this work? Well, I need to start for each element in this for each element in this array except the last element. So I need to do it for the first element, the second element, the third element, and the fourth element, but not for the fifth element. So for each element except the last, for each element except the last index, which means that could I use a for each loop? The for each loop always iterates all elements, but I don't want the last element, so I'll be using a normal for loop. Okay, so for each element in these elements, I need to check it with all of the other elements in the list. So let's do the first part, for each element. What I'm going to be doing for each element, I'll figure out afterwards. Okay, so I'll start a new for loop, starting from 0 and continuing until numbers.length -1, right? We don't want the last index. That's why we're doing a -1 over here, so we don't reach this index, which is -1. Okay, so for each element, I need to look at all the other elements. So in order for me to check all the other elements with 7, well, I need to write another for loop, because this is exactly what I did when I was writing this out. So I picked 7, and I started 7 with 1, and then 7 with 13, and then 7 with 2, and then 7 with 33. So each element after our current elements index I need to visit. Okay, so what I need to do is start another for loop, and now I can't really use for I, because I is already used for the first loop. So I call this index, now IntelliJ suggests J, because that's just the next word, the next letter. I'd avoid using I and J in nested loops. Why? Well, because they look too much alike, and it's easy to confuse them with one another. So I'll instead call this the compare index, because that's what I'm doing. I will be comparing with that element. So the compare index continues up until where? It continues up until numbers.length, not .length minus 1, because I want to compare 7 with 33. I just don't want to compare 33 by itself with anything. Okay? And what do I check now? Well, I'll check the difference between my current number and this index. So I'd say that the current difference is equal to math.abs, calculate the absolute value of the difference between numbers, my index on which I have started, meaning that first time that's going to be 7, the index from which I've started, and numbers, the index with which I'm comparing. So this is my current difference. Okay, so now I've walked this array, I've walked each of its elements, and for each of its elements I've walked all of the other elements. And actually, have I walked all of the other elements? From which index do I need to start? Well, I need to start from the index after my index, after my current index. Look, I'm comparing 7 with 1, not with itself, not with index 0. And then I'm comparing 7 with 13, and further on, I'm comparing, I'm comparing 2 with 33, and only with that. I'm not comparing any of the previous indexes. Okay, so this isn't correct over here. I should start not from 0, but from what is my base element with which I'm comparing. It's at index I. So I need to start from index I plus 1. Okay, so this is my current difference, and from here on out it's just searching for a minimum element. So this is the current element, and this is the current minimum. So when do I need to change the current minimum? Well, if the current difference is less than the current minimum, then the current minimum will become the current difference. And that's it. And I print the current difference here. Let's check if this works. So for these, the minimum difference seems to be between 1 and 2, and that should be 1. Let's see if that's true. We paste that code and we get 1. Again, we should test around this code with other values, other orderings of these values, maybe with an array of only 2 elements, with an array of a lot of elements, with an array of elements which are all of equal value, and so on. So we can test whether it really works, but I'll leave that to you, and I'll leave debugging any issues that remain from here up to you. Again, this is bonus homework if you want to really ramp up your programming skills. A lot of the work done on arrays is actually of this type. You're not only iterating them, you're iterating for each element, you're iterating the array again, or another array again. Okay, so what did we learn today? We learned that arrays hold sequences of elements, and they allow us to allocate programmable amounts of memory, meaning we can say how much memory we want allocated. They allow us to programmatically access elements of that array, meaning we can use a for loop or another method of computing an index and then accessing the element at that index, which is an extremely powerful tool, because we don't need to know the names of the indexes. We just need to be able to calculate those indexes, what they are. Okay, we saw how we can allocate an array, and we saw how we can access elements of that array, and we saw how we can read elements from the console for an array, and how we can print elements on the console through the string.join method if they're strings, or through a for loop which just prints the elements. And we also saw the for each loop, and we solved a lot of programming puzzles, and the last one of which was a pure bonus, which we weren't considering initially for this lesson, but bonus knowledge is always bonus knowledge, so I hope you found this useful. Again, if you have any questions, please ask them in all the channels we've provided for asking questions, and I'll see you again next time. Bye bye.
Today, together with my colleague George Grigiev, we continue teaching this free Java Foundations course and the basic concepts from Java programming, such as arrays, lists, methods, strings, classes, objects, and exceptions, to prepare you for the Java Foundations official exam from Oracle. In this lesson, your instructor George will explain and demonstrate how to use methods in Java. Methods allow developers to declare subprograms in their classes and in their programs. Declaring a method means to give a name for a certain block of commands and involve these commands later by their name. Methods can accept parameters, input data, and return a result, output data. This is the reason why they are sometimes called functions, like in math. Your instructor George will explain how methods works through live coding examples and will give you some hands-on exercises to gain practical experience. Are you ready? Let's start learning.
Hello everyone, this is George, and today we will be talking about methods, meaning that we will find a few ways in which we can make our code more organized and a few ways in which we can extend its functionality. But keep in mind that everything we learn from here on out, after we know how to create loops, branching of our code, and allocating dynamic memory, everything else we do is just a tool which helps us write more efficient code, or a tool which helps us write shorter code or better formatted code, and so on, because everything up to this point has covered all of the main functionality a program needs, so you can write any type of software with it. Now, that doesn't mean that it's practical to write software with only the knowledge of arrays, for loops and ifs, and conditional statements, but it is possible to write any program with that knowledge up to now. So learning about methods now, this is just something which allows us to build upon the knowledge we already have and gives us a lot of powerful tools to organize our code and to reuse it and so on, but it's not essential in creating any other program. So anything you can do with a method, you can do without a method. But it really helps, and no one really writes business level software without implementing methods, and a whole lot of other stuff we're going to continue learning in the following lessons. So, to the topic at hand, methods. What are they? Why are they used? So, what are we going to cover today? We'll cover what a method is and why we need to use them, how we can name them, and what are the best practices in naming them, and we will cover this last in the lecture, even though it's further ahead, even though it's soon in the slides, and it's in the first slides. It's in the first slides because when you're reviewing your lecture later on, you will need to pay more attention to this topic than the other topics we have covered during the lesson. So, we'll talk about how we can declare and invoke methods, meaning that how we can create named pieces of code which can be later reused from other pieces of code, how we can return values from those, how we can pass in parameters to them. We'll talk about the concept of values and value and reference types, and we'll just dive into a bit of that and how it functions in programming, and how we can handle it, and what we should be watchful for when working with this difference in data types. And then we'll talk about how we can overload methods, meaning have the same method which accepts different parameters. And then we'll talk about how a program is structured in Java, and how execution happens, and what is the so-called program stack, and why the debugger has a frames window which shows that program stack, how it's useful, how it affects our the execution of our program, and so on. So, before we talk about what methods are, let's see a piece of code and think about how we can optimize it. So, first, let's write a very simple program. Our program will just print some stuff on the console, but it will print it in sort of a prettified way. So what I'll do is I'll do a system.out.println, and I'll print a bunch of symbols. Which symbol do you want? Well, let's say we'll use dashes. Okay, so we're printing. Okay, let's pick something different than dashes. Dashes are too standard. Let's use. What should we use? Okay, let's use dollars because everyone loves those. Well, maybe not everyone, but a lot of people do. So, printing dollars. So we'll print dollars, and then between those dollars, we'll print out a line that says hello, or this is your receipt, or welcome to methods. Okay, so if I start this program, what's going to occur is that I'll get 3 lines outputted on the console, and they will contain the dollars I printed out, as well as my message and the dollars to finish that up. Okay, so what can we do? What don't we like about this code? Well, we obviously like the dollar part, but we don't exactly like it 100% from a programmer point of view. Well, what's not okay in this code? Well, a few things. First off, what happens if my requirements change and it turns out that I shouldn't be printing dollars, but I should be printing stars? Well, I need to replace the stars over here, and then the dollars over here I need to replace with stars, and then I need to go and replace the dollars at the other place with stars again. So I need to replace at 2 spots. So I have some piece of code, and then I need to replace that piece of code at 2 places, and both of those could cause an error, because if I miss replacing something correctly, or if I do replace it but I miss one of the stars I need to add, well, that will generate an error. Now, you already know how you handle stuff like that. If a value repeats itself, you should probably extract a variable for it. So you should extract a variable called, let's say, header or symbols or whatever, and initialize that to this sequence of symbols. And in that case, you'd only need to replace in one position. So you'd only need to replace the value which gets assigned to header, and after doing that, that will be printed equally in both places. But still, we still have an issue here. What the issue is that we're repeating code. What do I mean by repeating code? Well, we're repeating the fact that we're printing on the console, and we're printing a certain value on the console. Again, this is a really simplified example, so it's not really a big repetition of code, but the point still stands. We're repeating execution, which could be generalized. And another thing about repeating execution, it's not just about the fact that there's repeated code, but that once you have repeated execution of something, that means that there's a business concept, or just a concept in your program of that thing being executed. So this is a named thing. This is a header being printed. This is a line of symbols being printed. If you're repeating something, that thing probably needs a name. That thing is some type of cornerstone into your code, which you need to consider as a first-class citizen of your code. Like variables have names, and they're first-class citizens of your code. So here you have pieces of code which repeat themselves. So you probably have some underlying concept in your program which needs to be generalized and have a name by which you refer to it, instead of writing that piece of code everywhere. So what we can use in programming to replace repetitive code. So if we're repeating a value, we use a variable to repeat that value and to store it into a single variable, and from there on out we repeat the variable. Now, if we see that we're repeating code, especially if it's more code than just 2 lines like here, so if it's more code, if it's a sequence of operations, for example, in the lesson for arrays, we had to read an array of numbers from a line on the console. Well, that's a very good example of a piece of code which you'll probably need to repeat a lot of times. So we'll need to refactor that in some way. We need to edit that code in some way so it can represent the concept in our program which it deserves to represent. So how do we do that? Well, we use methods. What are methods? Methods are just named pieces of code. That's it. Nothing more complicated than that. Like the way your code stands in a main body, so this is the main method. This is a method. Main is a method in Java, and it is the entry point of your program, and your program just contains a bunch of code, and that bunch of code is located inside this main identifier. So methods are just named pieces of code. That's it. Though they're nothing fantastic or special or nothing hard to understand. They're just ways for you to get a few lines of code, give them a name, and be able to invoke those lines of code with that name instead of having to copy that code over and over again. So let's make a method and let's call it with an appropriate name for what it's going to be doing. Now, what are we doing over here? Well, we're pretty much printing a sequence of characters. We're printing a line of characters. We have a line of some type of character, and that we're printing that on the console. Okay, so instead of writing this out every time, let's just say that we have a method which does that. Now, methods you can declare this in the same place where the main method is declared. So the main method is declared over here inside the class main, inside this opening and this closing bracket, and you can define a method anywhere you wish within this range. So anywhere between these lines you can create a method. It doesn't matter whether it's before main or after main. Java doesn't care about that. Okay, so how do we do that? Well, let's be copycats and do what main does. Well, it's a method, so why not copy that? Let's see what we can do. Okay, so let's copy everything. And we can't name it main because it's another piece of code. It's a piece of code which is going to print a line of symbols. So let's call it that. Print line of symbols. Okay, what is this line we're printing? Well, this is the code we want to execute. We want to execute this print line operation in this print line of symbols method. Now, what we have here are the so-called method arguments or method parameters, and we don't really care about those. We don't want to supply parameters at this point. We'll see how we can do that further on. So let's remove those. So what we're left with is a public keyword, which, by the way, we can do without. It's not necessary while we're doing single file Java applications. We won't need to care about what public, private, and protected mean. We will see those things in other lessons further on. So what we will need to leave in is this static and this void. Now, what do they mean? Well, we'll figure that out in some time, but short info about the static part. Well, static methods can only call other static methods of the same class. Now, we're inside the same main class, meaning that the main static method can only call other static methods. If our method isn't marked static, main will not be able to call it if it's in the same class, like it is in our case. So, how do we deal with that? We just place that static keyword. Now, void means that our method will not produce a result. It can have side effects like printing on the console, but it will not produce a result. Okay, so that's it. Now, instead of writing this piece of code down, instead of writing system.out.println and supplying the symbols which need to be printed, I just say print line of symbols, and that's it. And then I say the same over here at the bottom line, the bottom result. Okay, so this is a method. A method is a named piece of code. You can have as many lines of code as you want over here, and main will still be able to call this method print line of symbols, and printing this line of symbols will still yield the same result on the console, which is outputting a line of dollars with a certain length. Okay, so how do we make this more interesting? Well, we do have a print line of symbols, but that's not really an ideal method for us. So we can only use it in only one single exact way. And that one single exact way we can use this print line of symbols method is by printing these dollar signs. Okay, so let's start modifying this. Let's say that it's possible that my conditions, that my requirements for the project I'm implementing change. a lot of stuff can change, but something that seems very likely to change is the length of these symbols. So I'm saying print a line of symbols, but how long is that line of symbols? Well, nobody knows. So there could be 3 symbols or 10 symbols or 100 symbols, and that seems like something that hasn't been well defined in the specifications of my project, since it's just printing a line of symbols, and it could change. And since it could change, let's implement this print line of symbols method in such a way that I'm not in danger of having to rewrite it again once some specification changes. So, what do I have in mind? Well, instead of printing a fixed string of symbols, let's just print symbol by symbol a fixed number of times. So we'll still keep it fixed, we'll still keep it printing a fixed number of items, but at least we'll have it as a variable. So if someone changes my specification and says, I don't want, how many symbols do we have? 19 symbols in this line of symbols. I want 10. I want it to be easy for us to print that. Okay, so what are we going to do? Well, we obviously need a for loop, which starts from I equals 0 and continues until we reach 19. Okay, and on each execution, it just prints on the console this $sign that we want printed. Now, how did I figure out that these are 19 symbols? Well, I marked them, and here down at the status bar of IntelliJ, we can see the number of symbols which we have selected. For example, now I have 2 characters selected. Okay, so I have this implemented, and now I don't need the print line over here anymore. But I do need the print line, but I don't need to print the symbols inside it. So I need a new line to be printed. Why? Well, because I called my method a print line of symbols method, so it should print a line. So it should finish its output by printing a line. And what else can I fix? Well, I don't really like having a value directly here in code. At least I don't like having that value as a magic value. Let's just name that value something. So I press Ctrl Alt and V after marking this value, and I'd say this is the length of the symbols I'm printing. Now, it's not a super descriptive name, but considering that it's contained inside the print line of symbols method, it's pretty reasonable for me to assume that length means the length of the symbols I'm printing a line of. So names of variables and of methods in that relation should be appropriate for the context in which they exist. So length in a method of print line of symbol, in a method named print line of symbols, is kind of obvious to the reader that it should probably mean that this is the length of that line of symbols, whereas length in main doesn't really tell you length of what. Okay, but if you have a named block of code which you reference with this variable, then it is easier to understand. Okay, so we have our length. We have our length of 19 symbols, and we're running a for loop which prints those 19 symbols. Now, if I start this code, it will do the exact same thing again. So I haven't really changed anything. I've just reworked the way I do it. Now, how can I improve this even further? Well, this print line of symbols, I didn't really change that much. From the perspective of the developer, yeah, that print line of symbols method changed in such a way that it can now print multiple symbols, and it can be easily changed. This method can be easily changed to print as many symbols as we want. We wouldn't have to, type in just different numbers of symbols and count them by hand. We can just give a numerical value of how many symbols we want printed. Okay, so that's good, but from the point of view of the user of this method, which in this case is the main method, this is still a method that can be only used in one way. It can only print a fixed length of line of symbols, and we can't really tell it what that length needs to be. Okay, so let's make this thing into a parameter which allows our method to be called to execute for a different lengths of lines of symbols. So this is currently just a variable inside our println of symbols method. It lives inside the println of symbols method the same way that if we had a variable inside main, it would live inside, its lifetime would match the code block of main. So here, println of symbols variables like this one live during the lifetime of that method. Okay, and this int I variable, on the other hand, lives within this for loop's lifetime. So during the whole execution of the for loop. So this is just a normal variable. Now let's change this variable so that external users of the println of symbols method can change the length of the printed symbol line. How do we do that? Well, we take this length variable and we move it up here. Now this initializes it in exactly the same way. It will still live inside this body of the println of symbols method, the same way it lived there when it was just a normal variable inside the println of symbols method. So whether you declare it over here or you declare it over here doesn't change its lifetime inside the println of methods method, println of symbols method. Okay, now we have this set to 19. But we can't anymore set it to 19 because this is now a parameter. This is something that gets supplied from the outside. And if we scroll downwards and reach the println of symbols call, we will notice that here we have compilation errors now. What do these compilation errors say? Well, you can't call println of symbols because it requires a single parameter of type integer and you're trying to call it without any parameters. So here we're saying call println of symbols, executed, these brackets mean executed, but we don't supply any parameters to this println of symbols method. Okay, so if we want 19 symbols to be printed now, instead of initializing length over here, which would mean that println of symbols would always execute the same way, instead of doing that, we supply a parameter, and that parameter we provide from the caller, from the call side. This is a call site of the println of symbols method. So main calls println of symbols, and this is the site where it is being called, where it is being executed. And we're going to call it and tell it, well, when we're calling it, we're going to tell it print 19 symbols. And then we'll do the same down here for this println of symbols. And of course, this could be extracted into a variable, and we could call this variable length, or replace it. And now I'd name it header length, because length in main isn't that obvious as it is in println of symbols. So header length now in main makes more sense because this is what we're printing. We're printing a header. We're actually printing also a footer, if we consider this to be a footer, but you get the idea. It's good to have more meaningful names than just length or height or whatever, if it's not obvious what they mean. Okay, so println of symbols now can be parameterized. So I can call println of symbols from any place in my code, from anywhere, from main. I can even call it from itself, but I won't do that now. I can call println of symbols from anywhere in my code, and I can parameterize it so I can print any number of symbols I want. Okay, so and again, this is just a copy of the value I submitted. So this is just a variable which gets initialized as if I just said that this for loop was over here, replacing this method, and as if I had a variable int length equal to header length. So this is the exact equivalent of what's happening when I write, instead of this for loop, instead of this body of the method, if I write just the call to the method. So if I say println of symbols of header length, this is exactly equal to this code. Exactly one-to-one correspondence from the point of view of the results of the program. The execution is a bit different, and we'll talk about that at the end of the lecture. Okay, but effectively what you'd see is the same process, the same output. Okay, so now we've replaced a bunch of lines of code with a single line of code which does their job. We haven't exactly replaced them, we've written them somewhere else, and we can call them again and again. And now we're saving from repeating this code. So I'm using one line of code to execute 4 lines of code, or even more if this method was longer. Okay, so that's one parameterization. What else can we parameterize on print line of symbols? It's still printing a line of symbols with a length which we specify as a parameter. Okay, what else can we parameterize here? Well, obviously we can parameterize what the symbols are, because we're currently only printing dollars. Imagine that we need to print whatever our program does. Imagine that that program, let's say we need to sell this program in a country which doesn't really like dollars. It has its own currency or symbols. So let's say that we want to print stars now. For people that don't like dollars, maybe they'll like stars. So how do we do that? Well, currently the only way to do that is to change the print line of symbols functioning and change this to a star. And that's all fine and good, but we'd have to be changing or writing a new method for each print, for each type of printing we want, for each sequence of symbols, for each type of symbol we want printed. So that's not exactly ideal. What can we do? Well, we can supply another parameter. We already supplied the length parameter, and what I'd say is I'd add a new first parameter, which is the symbol I want to be printed. Now, each parameter inside the parameters list of this method needs to have a data type and a name associated with it, and parameters are separated with commas. So I'll supply a first parameter over here, and I'll call it char symbol. The character which I need printed on the console this amount of times. So how will I call this print line of symbols now? Well, I'll say print line of symbols with this, print this symbol this many times, this amount of times. Okay, so now I'm not printing dollar, I'm printing symbol. Okay, so now print line of symbols makes a lot more sense in the name department, because why? Well, because it prints a line of symbols, and the symbol it prints is specified as a parameter. It's not a part of the name. So it prints a line of this thing with this length. Okay, so now if I want this code to continue to print dollars, I just need to supply the first parameter as a dollar. And I need to supply it again over here. And again, I'm just parameterizing my method and allowing it to be called in different ways in different places. Now, if I decide that my header will be dollars, whereas my footer will be stars, I can easily do that now. Now, I executed the code with the dollar parameters, and that's all fine and good. But if I want this method to function differently in different call sites, now I can do that. So now I can say, okay, so the top line, I want it to be stars, and the bottom line, I want it to be dollars. Okay, so we're changing from stars to dollars. Starting this, let's see what happens. Well, I have a line of stars at the top, then welcome to methods, and welcoming us to methods, we get the dollars. Well, that seems great. That's what we wanted to do. We wanted to have a method which is customizable, which can do different things based on different parameters we supply to it. Well, this is what a method is. This is a very basic example of a method, but it's a good example nonetheless, because it allows you to write code which can execute with different parameters and do different things based on these different parameters. Now, we don't really have branching over here in this method, but we could. We could have conditional statements, we could have more loops, we could have other method calls even, we could have initializations of arrays. Anything we can do in main, we can do over here in print line of symbols as a code concept. Now, what we need to do, of course, is different depending on the different situation, but we have no limitations in other methods. So basically, whether the method is called main or something else, it can do anything we have learned up to this point. Okay, so this is what a method is. So now let's see more formally what we need to know about methods. So a method is just a named block of code, a piece of code that has a name and can be called from other places. So you define it somewhere in the main class of the Java program. You can define it in other places too, but for now that's where we're going to define our methods. You can define it before or after the main method. The main method doesn't really care where its print line of symbols is located, as long as it's somewhere inside the main class and it's static. Okay, and here's another sample of a method. here we have a static void print hello. Again, this public is not really necessary at this point, so my suggestion is avoid it since it's not necessary. It doesn't really help you in the future if you're writing public everywhere, so just avoid that public call. And we have this method which is called print hello, and that prints on the console some information. Okay, now the method bodies which we're going to be writing will always need to be surrounded by these curly brackets. Unlike the if statements and the loops, these brackets are always absolutely obligatory. Your code will not compile if you don't have these brackets. Okay, so how do you call it? Well, you just enter the name of the method and then you follow that up by brackets. And if that method accepts parameters, well, you supply the parameters in those brackets. Now, why would we use methods? Well, we already sort of illustrated that briefly, and we will keep seeing it while viewing this lesson. But simply put, you can split problems into smaller pieces. You've already seen what my approach to solving problems is. I like to break them up into parts and solve parts by parts by parts. Well, a method is a great way to separate out a part of your code. And it also allows easier testing of your code. Not only can you organize it better and can you read it better, meaning that, look at this code now, it says, okay, so I'll print a line of symbols, so that's much more clearer than just system.out.print. It signals the intention of your code. You want to print a line of symbols. What symbols? Well, these symbols with this length. Then you're printing a message, and then you're printing another line of symbols. This makes code much easier to read because you describe your intentions instead of just invoking built-in functionality. Okay, so you have the bonus of better organization and readability because you know what they do, and it allows you to avoid repeating code because, like we have here, we just recall this method and the code gets executed automatically without us having to copy-paste it everywhere where the method is. And that allows of course it allows very much easier writing of code because if you have to change something, you just change it in one single place, not in 7. And another thing they really improve is testing, because once you have your program broken down into manageable pieces, each of these pieces can be tested independently of the others. Whereas if you have a single huge main method, well, that can't easily be tested. Whereas if you separate it into smaller methods, you can test each part of your program by testing the appropriate method. Okay, so what we saw now was the void method. A void method simply executes some code between brackets. So it's really just a named piece of code, and it can accept parameters, but it doesn't create a result. Now you might say, well, sure it does. Sure it creates a result. I just saw the result printed on the console. Yes, but that's not the result. That's not the result of the execution of the method, meaning that I can't take this method and assign it to a variable. I can't say x equals print line of symbols. I can't do that. I can't create a local variable of some type. There's no variable type void. Void just means no data. So there's no variable type void, there's no data type void, so I can't create a variable which gets the value of this operation. Whereas if you compare that to math.apps of -5, I can assign this to a variable. I can say x equals apps from the value -5, and I can get an integer from that, or I can get a double from that, and so on. So calculating an absolute value returns a result. So when we're saying that void methods do not have a result, this is what we mean. We mean that their execution, the result of their execution cannot be assigned to a variable. That's what having a return value means. Apps has a return value, in this case it's an integer, and that value can be assigned to a variable. Okay, so void methods don't return anything, they just do something. Typically they print something on the console, or sometimes they modify parameters which are passed into them, and we will talk about that when we get to value and reference types, how that happens. Okay, so this prints hello on the console, and calling and doing this, whether we do this in main or we do this in a print hello method, both are methods. So anything you can do in main, you can do in a print hello method or whatever you decide to name it. Now, we have a part here about naming and best practices, but I'm going to skip over that in favor of seeing through all of the concepts of methods and creating methods and supplying parameters and returning values and how these parameters are affected by the difference in value and reference types. And once we know everything about methods, then we'll come back to how we should be naming them and how we should be organizing code inside them. However, when you review your lecture at home, and this is why these slides are in this position, when you review your lecture back home, you should go through this naming and best practices section, because you already know what how methods are created and how they are declared and how they are described, what parameters they take and how they return values. And then this will make a lot more sense while you're progressing through the lecture, so you know why we've chosen the namings we've chosen. Okay, so I'm going to skip over this part and I'm going to jump right into the declaring and invoking methods parts. Now, we already saw that as an example in my code before we started the actual lesson. Now, let's see it a bit more formally. So, what you write when you create a method, first off, you start by public and static for now. This is not really syntax that's always obligatory when you're writing methods. It's an artifact of how we're writing our programs currently. Hence, we're going to have to write it initially and then we'll start getting rid of it. Okay, so public static, for now you need it. Later on we'll find ways where we will not be needing this. Okay, and then the significant part comes from here on out. First thing you type in is the return type of the method. Now for void methods, this is going to be void, meaning they don't return a result. They don't have a result that is assignable to a variable. Then you have the method name. The method name is simply the identifier which you use to invoke the method later on. For example, if you're in the main method and you want to call this print text method, you would say print text, referencing it by its name the same way you would reference a variable by its name. Okay, and here we have the parameters. Here we have the parameters which you supply to print text when calling them. In this case, in order to call the method print text, you have to supply some text which needs to be printed. For example, this is the text hello. Okay, so this is these are the parameters, and there can be many of them. They get separated by commas, I already told you that, and each of these parameters has to have a data type. A data type and a name. So data type, name, comma, next parameter. Data type, name, comma, next parameter, and so on until you fill in all the parameters you need. And this over here is the method body. Just like for loops have a body and just like conditional statements have a body, methods also have a body, which should always be surrounded by brackets. Now, all methods are declared inside classes. Actually, in programming, what this would typically be called is a subroutine or a function. A function is just what you see over here, a code which has a name. And if a function is located inside a class, like it's obligatory to do in Java, it's called a method. That's why in Java you're going to see them called methods, whereas in JavaScript or C++, you're usually going to see them called functions unless they're parts of classes. But in Java, they always need to be inside classes, and that's why they're called methods. I'm telling you this not because terminology is that important, but because it is important when you're searching for stuff in Google, so you don't get confused why there's in one language they're called one way, and another they're called another way. Okay, so main is also a method because it is a function located inside the main class. Okay, and variables inside the method are local variables. They are called local because they are only visible for that method. The same way that variables inside main are only visible inside main. So anything inside some kind of brackets is visible inside those brackets. Except when we get to classes and objects, where it's pretty much the same, but there are a few, the semantics are a bit different there. So while we're talking about methods or code blocks in general, anything declared inside a code block is only visible inside that code block. Okay, so continuing on from here, how do we call a method? Well, we just implement that method, and then after we have that method implemented, we invoke it by using its method name followed by these curved brackets. So in main, to call print header, we just say print header and follow that up with the brackets. Now these are obligatory. You can't just say print header and not supply these. if you just say print header and don't supply these, you're just referencing the code of the method. You're not executing it. So in order to execute something, you need to place these brackets, even if they're empty, even if you don't supply anything to them, just like system dot print line. You can call this without supplying any parameters inside it, but if you omit these brackets, the code will not compile. So you need the brackets. Okay, so this is a method invocation. It executes the code inside the method. What actually happens is Java sees, okay, I need to go into this method, and it goes, visits this method, executes this line of code, and then returns after the end of that method, and continues the execution of the code which we had in main. Okay, so you can invoke methods from main, of course, because main is just a method. You can invoke methods from themselves, which is called recursion, and this isn't really something you want to do like this. There are applications of the concept of recursion, but we won't be covering them in this lesson because it's going to become too wide of a lesson and you're going to lose your focus. We are going to discuss them further on, however, and it's a very important concept in programming. But for now, we won't be calling methods from their own bodies. And there are other ways to call methods, and namely that is calling them from other methods. So, for example, if you're printing a header, you may have a method which is print header top and print header bottom. Like, for example, if you consider this thing which we're printing here, the entire thing a header, well, this might be considered the header top, and this might be considered the header bottom, and this might be considered the header message. So, let's say that we can make this into a method, and we can say that this is actually a parameter to this method, which is header title. So this is the title we're printing, and now we have a header title and a header length. And okay, let's put this header length back inside this part of the code. So what am I doing now? I'm taking out the header title and I'm grouping this code together. Guess what I'm going to do from this point on? I'm going to make this into a method, so I can print different headers with different messages, with different titles, multiple times without having to write the code again. So I can now mark this code, press Alt and R, or just pick the refactor menu from up here, and then go to extract, or just press X, and then go to method, or just press M. And when I do that, Java, or IntelliJ more specifically, will offer to create a method for me instead of me having to write the method myself. It will create it as a void method. It will accept a string parameter named header title, this header title over here which I created. And the method will look something like this. Again, ignore this private or public or whatever part. This will be what the method looks like. And I need to name it somehow. So let's say this is print header. Okay, and now I have print header which accepts a header title. And by the way, since the method is called print header, you don't need to call this a header title, because if you just call it title, it's obvious that it's the header's title, not something else's title. So now we just have a single call in main, and now we can inline even this variable, and I can say just print header, and that calls the method print header, which prints a line of symbols, and then prints a message, the title, and then prints another line of symbols. And how does it do that? Well, by calling other methods. So methods can call other methods, it's completely fine. Just how main can call the print header method, well, the same way the print header method can call the print line of symbols method. And now look how neat and tight our main method looks like. And now we can have some other logic here which doesn't concern itself with how headers are printed. There's someone else that is responsible for printing headers. Okay, so these are the ways of invoking methods. Now, we already saw how we can supply parameters to those methods, but again, let's see it more formally, how it looks like. So, what can method parameters be? You can supply any type of parameters to a method. For example, here's a method which accepts two parameters, a start and an end, and it prints the numbers from that start number to that end number. So two integer parameters. How would we call it? If we want to call this method to print the numbers from 13 to 42, how would we call it from main? Well, we type in print numbers, and then if we want to start from 13, we type in 13 as the first parameter and 42 as the second parameter. Of course, we can have these saved into variables or read from the console or whatever. Anything works. Any way of supplying a value over here would work. Okay, so print numbers is called like this from main. Or if we want to read these from the console, we can simply say scanner.nextInt if we have a scanner, and that would read the first number, and then scanner.nextInt for reading the second number over here. Okay, so when you're invoking a method, you're supplying the parameters. Now, you can have 0 parameters on a method like we have. Actually, we don't have such an example in our methods. But if we create a method which is called print default header, now we have a method which accepts no parameters, and that method calls the print header method with the parameter welcome to methods, and that one calls print line of symbols with 2 parameters. So you can have any number of delegations of responsibility here. So we now have a method that prints the default header, whatever that header seems to be. And the print default header method knows what a default header means, and it passes it on to the print header method, which doesn't know what a default header means, but it knows what a header means as long as it's provided a title. And from there on out, the print line of symbols method doesn't even know what a header is, but it can print a line of symbols as long as you provide it with the symbols and the length, and so on. So each parameter inside a method has a name and it has a data type. So always you name the data type, and then you name the name of the parameter, the identifier of the parameter, then you place a comma, and then you supply the next parameter, and so on. Okay, so we have a problem here of how do we print the sign of an integer number. We have to create a method which, when it sees 2, prints number 2 is positive. When it sees -5, prints number -5 is negative. And otherwise, if we have the number 0, it prints the number is 0. Okay, let's do that quickly. So we'll come over here and we'll create a method, a public static. Actually, we can avoid the public part. We can create a method named, which is a static void method, and we'll name it print number sign, because that's what we're doing. We're printing the sign of a number, or we're printing number sign info maybe, because we're not just printing the sign, we're also saying a bunch of other stuff. So let's say this is our number which we're getting as a parameter. And what are we going to do? Well, if that number is larger than 0, then we will be printing system.out.println the number %s, %d is, and %s is something. So the number is positive. Okay, so we don't want a print line actually, we want a printf, and let's add a new line symbol at the end. Now I'd be doing the same for the same call, the same formatting call, but with different parameters, right? For negative. So else if the number is less than 0, then I need to print this thing again, but with the value of negative. And I think about how I can extract this so I don't repeat code, but this is something I'm going to leave to you. And in the final else, if it's not larger than 0 and if it's not less than 0, then it's probably 0. And then I'll say the number is %d over here and just print out the number. Or I can just say the number is 0, that would also be valid. Oh, no, it's actually the number 0 is 0. That's what I need to print. Okay, so do you notice a pattern here? Everything is the same except this string at the end. So what am I going to do? Well, instead of printing each time, I will just have a single print, and I'll say string the sign info is a string which gets initialized in this case to sign info to positive, and in the other case it gets initialized, sign info gets initialized to negative, and in this case sign info gets initialized to 0. And now I have only a single print statement which prints not positive but prints what? Prints sign info. Okay, so what did I do? Well, I removed the repeating code, which I execute in all of the branching scenarios. I moved it out of the branching, and the thing I put into the branching was the determination of the info I print at the end. So if I start this program, nothing special will happen because I'm not calling this method, right? And you can notice that by the fact that it's grayed out. IntelliJ detects that I'm not calling this at all. Okay, so let's call that method. Let's leave our header alone, and let's create a new scanner. Tell it to read from system.in. Save that into a scanner variable, this scanner object. I save it into this scanner variable, and now I will say print number sign info from scanner.give me the next integer. And if I start this thing, it will expect me to enter an integer number, and for that integer number, it will print this sign information which I described over above in the print sign info method. So if I write minus 5, I get the number minus 5 is negative. And I can test around with the other values if it works correctly. We're not going to do that now because we're in a lecture, and this is something you should try at home with by writing this code by yourself. Okay, so here is also a way of implementing this. Now here we have the repetition of this code. Now this is also a valid solution. However, I don't like it that much due to the repetition of this same operation multiple times. By the way, you could also extract a method for this. Think about how you can do that. Instead of extracting a variable, think about how you can extract a method. Okay, there's another problem over here. We need to implement a method that receives a grade between 2.0 and 6.0 and prints the corresponding grade in words. So if we get between 2 and 2.99 inclusively, so if we get something between, if grade is larger than or equal to 2.0 and this grade is less than 3, then we need to print fail. And otherwise, if not that, we need to print, if in the other case in which the grade is larger than or equal to 3, but less than 3.5, we need to print poor, and in the other case we need to print if it's larger than or equal to 3.5 and less than 4.49, meaning less than 4.5, we need to print good, and so on. So this is just a bunch of if statements. How would our method look like? Well, our method would look like, what does it do? First off, it's a void method. It's a static void method. What does our method do? Well, it simply prints information about the sign, so about the grade. So print grade name, maybe, or print grade description. And what is it going to get as a parameter? Well, it's going to get a grade. What's the grade in this case? A double grade. And then it will just open the brackets and do the if statements. And in each if statement, print the necessary thing. That's our method. And then we just need to call it from the main and see what it prints. That's this solution. We won't be coding it now. We'll leave it as something for you to try out at home. It shouldn't be very much complicated than what we did previously. So here's an example of how you can do it. But my suggestion is try to solve this problem by yourselves and try to solve all of the problems which we see here, even if I've solved them for yourself, because that is how you build experience with coding. Now, another problem over here we will solve. What the problem is, we need to print a triangle. Now, how do we print this triangle? Well, notice that there is a pattern here. So, if we say that this triangle is of 3 elements, we should print a line of a single element, then of 2 elements, then of 3 elements, and then reduce to 2 elements and reduce to 1 element. Now, we could do that in a single method. We can implement a method that is just named print triangle, but there's a pretty obvious subtask to this print triangle task. What is that subtask? Well, that subtask is printing a single line of numbers. right? You print a line of numbers starting from one number, and starting from 1 always actually, and ending in a number you supply as a what. It changes, right? So in one case it's 1 number, then it's 2 numbers, then it's 3 numbers. Well, you supply the end number. The start number is always 1, but the end number you supply it additionally. So let's implement that. So what I'll implement is I'll first implement a print line method, and then I'll implement the print triangle method using the print line method. So I'd write that this method, I'd type in that this method is a void method since it's going to be printing, and I'd call it print. And what is this exactly? It's an increasing sequence, right? It starts from 1 and it increases to 2 and then it increases to 3. So print increasing sequence. And I'd supply the end number, the last number, and the last number that needs to be printed. Okay? And what will I do in this printing of an increasing sequence? Well, I'd start a for loop from what? From 1, right? Because I'm starting from the value of 1 always, so I'll start my loop from the value of 1. And I'll continue to last, but I will continue inclusively because I want to say print increasing sequence of 3, and if I do that, I want this printed on the console. Okay, so now what do we need to do? We just need to print out to the console this number with a space after it. So now I have this number followed by a space, and that is my description of the print increasing sequence method. And now I can print a line after that, system.out.print line, so that I can finish this print increasing sequence with a new line, so that when I print the next increasing sequence, it starts on the new line. Okay, so here I have a single part of the solution, the part which prints one single line. Okay, what is the bigger part of the solution? Well, I need to go here and print a line that reaches 1, then I need to go here and print a line that reaches 2, then go here and print a line that reaches 3, and then start reducing. Print a line that reaches 2 and print a line that reaches 1. So up to this part, I'm running a for loop that increases from 1 to 3, and then I'm running another for loop which decreases from 3 minus 1 to 1. Okay, so that seems pretty simple. Let's now implement our static void print triangle method, triangle, and I supply the parameter which describes the triangle's, what is this? It's a width, right? So it's not the height, it's the width. It's not exactly a great name for a parameter, but it's better than, it's descriptive enough if you know the context of the task. So print triangle with this width. And how will I be printing this triangle? Well, I'll start a for loop, starting from I equals 1, because that's where this is starting, a single item in a line, okay? And I'll continue until I get to the width, inclusively to the width, okay? And for each iteration of the loop, what will I be doing? Well, I'll be printing an increasing sequence. So I'd say print increasing sequence. And how long is that sequence going to be? Well, it's going to match the number in the control variable of the loop, I. Okay? So I'll print that increasing sequence, and then I'll start from width minus 1, because for here I'm starting from 2. So I have a width of 3, this is 3, and then after I print this part, which I'm doing over here, then I need to print the next part, which just begins from the length over here minus 1. The width, actually, minus 1. So starting from width minus 1, continuing until I reach width 1, I'm printing again an increasing sequence. And now I just need to read the number from the console, which is the triangle width, and I'll create a new scanner for that. Tell that scanner to read from system.in, and read the next integer from there. And now I'll just say, okay, so I have the width now, and print a triangle with that width. Pretty simple, huh? Looks, actually, I know it wasn't simple while I was writing it, and I was doing it sort of quickly, because I want to let you go into a break so you can refresh your minds. But even if it seemed complicated while I was writing it, if you study it item by item, it really isn't. That's the power of methods. It breaks up your code into parts, and if you're finding it hard to understand this solution, well, just understand this part first, see how that works. Then understand this part, see how that works. And then understand, well, this part is pretty simple, but understand that and see how that works. So you can understand, once you understand how one part works, you can treat it as a black box and just imagine that it works that way and not care about the code itself, because you're not seeing it all the time. Okay, let's enter 3. Whoa, we messed up something. Okay, let's see what we messed up. We're going to stop this code and we're going to, I already see what I messed up. Do you see what I messed up? It's kind of boring when you see your problem quickly, but since this seems like an infinite loop, right? So there's a problem with the loop continuation. Is this an infinite loop? Well, doesn't seem like it would be. It starts from 1 and continues until it's less than last, and it increases all the time, and nothing else touches I. Okay, so it's probably not this. Is this one an increasing loop? It starts from 1 and continues up to width and increases I. It doesn't seem like it's going to be an infinite loop. However, look at this part. I'm starting from width equals from I equals width minus 1 and continuing until I reach 1 inclusively, but I'm not reducing, I'm increasing. So I'll never reach 1. Well, not never. I'll reach it after integer overflows and travels all through the negative values of integer and then reaches 1 and then it will stop, which is really isn't ideal. So what I need here is minus minus, not plus plus, because I'm going down on the values. Okay, so 3, and we have our triangle 1, 2, 3. Okay, so I'll leave you with this for a few minutes to get a rest for your head, and of course there's another solution over here which you can check out. It's sort of similar to what I implemented, and if you have questions again about this, you can ask in the channels which we have provided for you to ask questions in, and you will receive some answers. And ask your colleagues too and communicate with them and play around with them. What have we seen up to this point? Well, we've seen how to create a method, a void method, and how to pass parameters to that method. What we haven't seen yet is the return keyword. The return keyword just ends the execution of any method immediately. It doesn't matter whether it's in a loop, in a conditional statement, and whatever. The moment you meet a return statement, the method ends its execution. That's it. No more execution for that method until it's called the next time. Okay, so let's actually see that quickly. Let's create a method which prints an array of integers until it reaches a negative value. So it prints all the values of an array of integers unless it reaches a negative value, in which case it immediately stops. So let's ignore this triangle and scanner part. Let's create an array of integers, let's call it numbers. And let's initialize that with a new integer array containing the numbers 1, 2, minus, let's add one more number, 3, minus 1, 5, 6. So let's have this array of numbers. Okay, and I'll create a method which is called print numbers until print numbers stop on negative. So it's a sort of a weird method name, but it's not a method that you would typically be writing. It's just an illustrative method on what return does. So now I'll supply this numbers parameter. Now you say, wait, we haven't created such a method. Well, we will tell IntelliJ to create it. So I press Alt and Enter, and I select Create a Method. It creates this method for me. It creates its parameter, which is the integer array of numbers, which I need added into it. And now, how do I print an array of numbers? Well, I just run a for loop. And I actually can do a for each loop, right? So I can iterate these numbers with the for each loop and say, if number less than 0, then return. This is the new keyword we're encountering. Otherwise, just system.out.print this number with a space after it. Okay, so what will this do? Well, starting the program, we will say that only 1, 2, and 3 are printed, and nothing after that is printed. So only 1, 2, and 3. Why? Well, because the code encountered a number which is less than 0, meaning that it entered into this conditional statement and accessed the return keyword, which immediately ended the execution of this method. Doesn't matter that it's in a conditional statement, which is inside the loop, it immediately breaks out of the method. It's sort of like the break statement inside loops, but in this case, it's a full breaking of the entire method, not just of the loop. So it directly exits the loop. So this is what the return keyword can do for void methods. Void methods don't need a return keyword, but if you add it somewhere, it will immediately stop the execution of the method. Okay, so if you're using it for a non-void method, the concept of the return keyword is for that to be used to return an actual value. So you have a method, and that method returns a value which you can assign to some variable. Okay, so let's do that. Let's implement a method which, what can our method do? We already have an array of integers. Let's do something with that array of integers. For example, let's implement a method that counts the number of positive numbers inside an array of integers. Should be kind of simple. So let's say count positive in numbers. That's what I'll call my method. I'll say Alt and Enter create this method. Okay, so I'll leave it void for now, and then we'll figure out how to make it a non-void method. So this is our array of numbers. Let's iterate that array of numbers. And what do we need to do? We need to count the positive numbers in that array. So in order to count positive numbers, I need to have a counter. So int num positive. This is my counter. What should it start from? Well, it should start from 0. And if I encounter a number for which it is true that the number is larger than 0, then num positive will be increased by 1. I will bump it up by 1. Okay, so num positive is now increased by 1 whenever it encounters a number in numbers which is positive. Okay, and now after this method has ended, after all of the numbers have been iterated, I can do return this num positive value. Now I'm getting a compilation error here. Why? Well, because my method is void and I'm trying to return a value from it. The thing which you write after the return statement is the value which this method should return. And in order for the method to be able to return such a value, it has to have a return type that matches the value that you're returning. So the return value has to match the return type. In this case, it doesn't. It is an integer, whereas the return type of my method is void, meaning it has no return. So in order for this method to be able to return a value, I need to change this void type into an int type. And now this code will compile. And now if I print this on the console, now if I just count the positive numbers, nothing will happen, right? Actually, it will happen, but I won't see any result because I'm not printing the result on the console. Now, this method actually has a result which is assignable to a variable, meaning that I can say x equals count positive and create a variable x, which I assign with that value of the number of positive numbers in this array. So now I can system.out.print a line with that x number, and I will see the output, which is contained in that x variable, which contains the number of positive numbers in that list of numbers, which is in this case 5. So 3 over here and 2 over here, 5 numbers. My program is correct. So this is what a returning method does. It calculates some value and it returns that value to the caller of the method. So the caller of the method can use that value as, for example, a variable which can be saved, or the caller of the method can place that result of the method inside the print line statement so they can directly print the result of that operation, or do something else with it, or supply it to another method, or use it in an expression, and so on. So any method that returns a value can be assigned to a variable. The result of its execution can be assigned to a variable. Okay, so here we have another example, a read full name method which returns a string. It accepts a scanner parameter, the scanner used to read from the console, and it uses it to read two names from the console and concatenate them into a single string. Okay, so any method that returns a value can be assigned to variables, can be assigned to expressions, can be passed to other methods. Like when we do scanner.nextLine, we pass that into pass the return value of this as a parameter to the parseInt method. The parseInt method is just a method, just like the nextLine method is just a method also. We'll see how to write methods like the nextLine method further on. But this is a method, it returns a value, and that value is then passed on as a parameter to the parseInt method in the integer class. Okay, so here's an example problem. Now, instead of solving this problem, which is pretty simple, we just need to code a method which calculates, which multiplies a width by a height and gives us the result. Instead of implementing this method, let's implement something which will be useful further on. So, in previous lessons, we learned how to read an array of integers from the console. So let's remember how we were supposed to do that. So we have an array of integers on the console as a single line. So how do we read that from the console? Well, we don't know how many there are, but what we can do is create a scanner, tell it to read from system.in, name it scanner, create a variable for it, and then tell it to read an entire line from the console. Now up to this point we're just reading a line from the console. From here on out we need to parse this line into an actual array of numbers. So this is our line on the console, and from here on out, after we've done the reading part of the line, we need to convert this line, this string, into a sequence of numbers. So what do I need to do? Well, we've already done this. We tell the line to get split by spaces. So split it into an array of strings, which is the, let's call it items. So we're getting the items by splitting the line by spaces. So each of these items will be a number, but a number represented as a string. And now these numbers I need to initialize with the same length that the items have. So initialize them by items.length, and then run a for loop starting from 0 and continuing up until we reach numbers.length. And what will we do with that? Well, we'll set the numbers at position I to the value of items at position I, but we will convert that into an integer through integer.parseInt. We've done this in previous lessons already, so I won't give it more time for explanations. You can rewatch the previous lessons if you're still having trouble with this one, but it shouldn't be too hard at this point any longer. So after we've created this array of numbers, we have the numbers and we can use them. For example, we can pass them to count positive functions as a numbers array and print that on the console. System.out.println, print the line of the number of positive numbers in the numbers array. Okay, but instead of writing this code over and over again, these 5 lines or whatever they are, instead of writing these lines over and over again, can't I make a method which returns this array of numbers? And the answer is yes, I can. Let's copy this code and let's create a method. How would I call this method? Well, since converting a single integer from a string is called parseInteger, converting multiple integers from a string would be called parseIntegerArray, for example. So I'd create a static method, which maybe will be void, but it actually won't be void. But let's call it a void method for now, and then we'll figure out what we need to return from it. So creating a void method, call it parseIntegers or parseIntegersArray. Okay, what will I get as a parameter? I'll figure it out afterwards. So I'll copy the code that I'm going to be using to do the parsing, and I'll see what's missing. Okay, well, IntelliJ automatically told me what's missing, so I copied the code, and what am I missing? Well, I'm missing the line. So I'm missing the string input. So the string, even the string s, so because this might not be a line, someone might be calling parse integers on something they know contains integers, but it's not a line of strings, it may be a part of a line of strings. Okay, so parse integers, and now, instead of this being a void method, what does it need to return? What's the result of this method? Well, what I'm creating is the numbers array. So what I need to return is the numbers array. Now if I don't know how to change this void return type into a numbers array type, I can just go over here, press Alt and Enter, and select the suggested fix, which is make the parseIntegers method return an integer array. Okay, so I got that. And now I can just call this method and say numbers, the numbers array. Instead of parsing it manually, I can just call the parseIntegers method and supply this line string, and now I have my numbers generated from that line. So now I have a method which I can reuse in other code as well, which just reads a line of numbers. And this is very useful for exams, because if you have such a method, well, you don't need to code it again. You can just copy paste it into your solution and call it from wherever you need it. Okay, so now we can parse a line of numbers, and we can even shorten this code even more. We can just say parseIntegers of the next line of the console. It became a lot more neat than it was before, right? Instead of having a huge for loop here, which I need to read to understand what it does, now I just see that, okay, I'm parsing an integers array from a string from the console. Instead of having to read through the code and understand what each part of that code does, I'm just following the names of the methods. Okay, so this code is going to work. Let's just test it just in case I've made some mistake while coding it. So let's say the line of numbers is 3 minus 4, 42, 0, 71. So the number of positive numbers is 3, 42, and 71. 0 isn't a positive number, it's just a non-negative number. Okay, so pressing enter here, exactly 3 positive numbers. That's what I expected as an output. Okay, so it seems that this works. Now I tested a lot more before starting to use it again in every program I implement, but this is the gist of what you need for reading lines of integers. Okay, so instead of solving this problem, we solved another problem, and we actually helped ourselves write code further on. And you can study how this problem was solved in this solution. It's a pretty simple method. It's just a method that returns a multiplication of two values. Okay, another method, this one I'll leave to you again, a method which gets a string and repeats it as many times as necessary. Now, one advice, if you're using this solution, don't use a string over here, use a string builder. We will be talking about text processing and why it is not good to append multiple times into a string, even though this solution will work. But until we get to that point, use a string builder over here, and that will optimize the functionality of this repeat string method. Okay, so this method otherwise accepts a few parameters and just does an operation a few times. How does it repeat a string? Well, it just appends over and over again into the same string. It's a pretty simple method to implement. And again, my suggestion is use a string builder and Google how you should be using that string builder to append into a string and to get the string result at the end. Okay, so another method, we have a method that should calculate and return the value of a number raised to a given power. So we would get 2 and then 8 as values, and we need to raise 2 to the 8th power. How would we do that? Well, let's implement that power function. So I'd call, what does this function do? It calculates a power. It's a static function. It returns a what? Well, here the numbers are double, so we will return a double number. Since we're raising a double number to a power, that result is going to be a double number. So let's call this method power because it raises a number to a power. And the number we're raising, it's actually not an integer, it's a double number we're raising to a power, and the integer power to which we're raising it. Because in this task, we're expecting integer powers because non-integer powers are too complicated to implement with the knowledge we have at this point. Okay, so what does this power method do? Well, it's going to multiply the number by itself a power number of times, meaning that we need to run a for loop again, starting from 0 until we reach power, and multiply number into itself that many times. and then return this number. Now, there is something I'm missing over here. What if the power is 0? If the power is 0, I should return 1, right? Any number to the 0th power is simply 0. And actually, if the power is 1, I shouldn't be multiplying the number by itself at all, right? So I should be multiplying the number, not power number of times, but power minus 1 number of times, because if I get 1, I shouldn't be multiplying the number by itself at all. So instead of doing that, I could do the following. Int raised to power equals 1, because a number always, a power number always starts from 1, and then I'd multiply raised to power by number. In this case, if power is 0, this check will immediately fail, so I, which is 0, less than 0 will return false. So I will not go into this for loop, so I will return raised to power, which is the value 1. If I get 1, I will multiply raised to power with number exactly once, and so on. Okay, so this is the power method. I won't be testing it because that would waste some of our time and we need to discuss some more important concepts, but you can test this method out. How would you call it? You'd just say, go over here and say system.out.println. Println what? Well, println the power of scanner.read the next integers, read the next double, and scanner.read the next integer. So we're reading the double number which we will be raising, so we're reading this, and then we're reading the integer for the power, and we're passing these on to the number and power parameters in the power method. And that calculates the power, returns the double result, and that double result we print on the console. I sort of pushed it tighter than it needs to be, but I think you can understand what the sequence of operations does. And it's also good for you to learn to read such tightly packed operations and learn to examine them piece by piece. So you start from the innermost operations, and then you continue on to the outer ones, and then to the final outer one. So test this program at home. Try implementing your own solution. Try implementing a solution with 2 returns. So another way to solve this problem of raised to power being 1 is by what? Returning 1 if the power is 0. So if you see that power is 0 on the first line, you can do if power equals 0, then return 1. Otherwise, start multiplying number by itself until you reach power minus 1 number of multiplications. That's what my initial idea was, and then I decided to go back to have another variable and multiply in that. So play around with that solution. It will be useful for you to see how 2 returns inside a single method cooperate. Okay, now that we've talked about return types, we need to talk about a bit about value and reference types, and that's actually got to do more with parameters of methods than it has to do with the return values, but it's important either way. So, what do I mean by value and reference types? Now, there's an example here, but in order for you to understand that, I need to show you something. Okay, so ignore the code which we've been writing up until now, and let's say we have a simple method which doesn't return anything, and we'll call it increment. It will just increase a value, and we'll pass in the value x. And this value x we will increment by 1. This simply increases the value of x by 1. Okay? Now, let's ignore the scanner, and actually we'll not ignore the printing, but we'll print something else. We'll create a variable a. We'll assign it the value 5. Or let's assign it the value of 42, because 42 is the typical example value in programming. Okay, so what do we do from here on out? Well, let's say increment, by the way, this needs to be a static method, increment a. And then let's print a on the console, system.out.println a. Okay, what will happen over here? What's the result going to be? Well, think about it. You can even gamble on it if you want. think about it, and what's the result going to be? Well, it's going to be 42. Even though, in this method, we're increasing x by 1. Now, why does that happen? Well, let's imagine this wasn't a method. Let's imagine that we get this code over here and insert it in this place. So, what will this code look like if I insert it in this place? Well, it would look like int x equals a, and then x plus plus. Now, at this point, you shouldn't be surprised why a doesn't change, why a doesn't get incremented. It doesn't get incremented because we're not incrementing a. We're incrementing another variable, and that variable's value changes. And first off, it gets assigned by a, and if we place a breakpoint over here and start the program, we will see that the breakpoint stops the program over here, and we will see that x is indeed 43 because it took the value of a and then it increased it by 1. Okay, so that's valid, and a stays 42. Okay, so what happens when you supply an integer parameter to a method? Well, the method receives a copy of that integer parameter. Kind of like what the for each loop does when you're iterating an array. If you change an element if you try to change the element which you're using for iteration, it's not actually changing the array, it's changing just the element which you are using, your local copy of that element. Okay, well, all fine and good then. Then in that case, what is going to happen if we have an int array x over here and we change its first element by increasing it by 1? And let's say that we don't have the int variable here, we have an int array arr, and this array is initialized by an integer array with a single item. Let's say the single item is again 42. Okay, and now we're going to print the single item in that array. Okay, so what will happen now? We're receiving an array. Of course, we need to call the increment method to see if anything happens at all. We're initializing an array. We're passing it into the increment method and increasing the first element inside that array. What's the output? 42 or 43? Well, if you followed the integer logic, it would have been 42. However, for an array, it isn't. It's 43. Okay, what happens here? Well, arrays and other objects, like for example the scanner, are so-called reference types. Now, there are many ways to understand this, but one way to deal with the concept is that reference types, when passed into a method, are passed by reference, meaning that when you access the type, you're accessing the underlying object. So this ARR object over here, that's actually the variable name. The object itself is this thing, the initialization of an array with a value of 42. So this is the object. This is just a variable that points to that object so we can access it. But this one over here, this thing, is the object. Okay, so this is the object. When we're passing ARR here, what the method receives is just another pointer to that object. It still points to the same object. It's not a copy of the value like it was for the integer. For the integer number, there's no object, there's just an integer, it's just a number. And that number gets copied around. Whereas here, you don't get the number copied around, you only get the reference to that object copied around. So both ARR and X over here point to the same object. They refer to the same object. That's why they're reference types. They refer to objects, they're not the objects themselves. So ARR over here isn't an object, the way integer is a number. If you have an integer x, that integer, this variable x, is the number itself. Whereas if you have an array, this thing isn't the array. This is just a name for this array which you initialize. The array is the thing you initialize with the keyword new. That's the object. This is the actual object. And when we assign it to a variable, that variable isn't the array, the object exactly, it just points to that object. So this variable ARR points to this object initialized here in this code. So when you pass that ARR around, when you pass that into the increment method, it receives another thing, another copy, which points to this same array. And since it points to the same array, editing that object will edit that array. So editing an element of that object will edit that array. And that's the difference between value types and reference types. And here's an example over here. If the cup is an integer, actually this is the case for cup being an integer. If cup was an integer, so if cup was int, simply int, then when we're passing it around, we're actually passing in a copy of that integer. And whatever the fillCup method does, it does to the copy of the integer. But when we're passing by reference, if cup was an integer array, if this was an integer array over here, when you pass it around, you don't really pass around the cup, you pass the location of the cup. And whoever does filling the cup, whoever executes the fill cup operation, will go to the actual cup and fill that. It won't fill a copy, it will fill the actual cup, because you're not passing around the actual cup over here, you're passing around the address of that cup, where that cup is located in memory. And that's why this fill cup method actually fills the original cup. So if you want to understand it simply, value types, primitive data types, double, int, short, byte, char, boolean, all of them get copied by a value, meaning that if you supply them to a method as a parameter, that method receives a copy. Whereas arrays are not copied. Imagine how long it would take if each time you sent a method inside, if each time you sent an array inside a method, all of its elements were copied every single time. That would take a lot of time. That's why these sort of objects, arrays, and actually strings also, and string builders and scanners and a lot of other stuff we're going to be seeing more and more from here on out, in future lessons. All of that stuff, it doesn't get copied entirely. The only thing that gets copied is its address. So someone else gets the business card of that object and can visit it by looking at what the business card says. So when they visit the business card, they're visiting the actual object. So what you're passing around when you're passing in arrays or other objects of that type, you're passing in a business card that has the address of the array. And when you go to that business card's address, well, you see that array. So that's the big difference between passing by value and passing by reference. Value types are located actually on the so-called program stack, whereas reference types are located on the so-called dynamic memory heap. And those objects on the dynamic memory heap are pointed to by objects from the stack of values of value types. So when you have an object, let's say this is an int array, that's actually just a stack variable which points to the actual object in memory. That's why I said that this array isn't the actual object, it's an address of that actual object. The actual object is over here, this new int thing which we've initialized. So you have as many objects as you've seen the keyword new. If you've seen the keyword new once, like here, and you have one array and then another array in a method, then probably both of these arrays are actually not copies of the array, not probably, but exactly. These arrays are not copies of the array, but they both point to the same array. They're just addresses of that array. Okay, so if that seems a bit cryptic for you, don't worry. All you need to understand is that primitive types, for now though, when we're talking more and more about objects, you need to get used to this concept of reference and value types and how they're stored in memory. But for now, it's enough for you to imagine that integer types, integers, chars, booleans, floats, doubles, and so on, are just copied. You just get a copy in the method. Whereas arrays, or strings, or scanners, or whatever, are passed by reference, meaning that whatever this method does, it does to the original object. So accessing elements of the object modifies the object itself. So that's what a reference and a value type are. And we have these examples which I just showed you. What happens when you pass in an integer number to a function, and what happens when you pass in, well, in this situation, what's going to happen? We have a number 5 and we try to increment it with 15. And what happens is that this number over here is just a copy of this number 5 over here. And you modify the copy. Whereas if you get an array and pass that array in, what happens is that you're modifying the array itself. Which is this array? Well, here's the array. This is the object itself. here's one way of accessing that array, but here's another way of accessing that same array, because why is it the same array? Well, because it's been passed in as a parameter, and this parameter arrives by a reference, so this value type is addressed by the number's reference, and since only one object exists, both of these point to that same object because no other objects have been created. The only thing that has been created is a new pointer to that object, a new reference to that object. So editing items inside that object will change the original object. Okay, so that's all you need to remember. Value types get copied, and reference type, value type objects get copied. Reference type objects get only their business cards copied, and whoever accesses whatever's on the business card accesses the original object itself. Okay, so let's continue on to the last parts of our lecture for today, our lesson for today, which is going to be how we can overload methods. Now, what is overloading and what is a method signature is something we'll explain now, and then we'll continue on with examples. So, a method signature is the part of the method which can be, which is obvious from where you call the method. So, when I go to the code which I had over here, which is which increments a number, or okay, let's go back to the power. That's a bit more interesting. So, if I have a method power, and if I call that method power with the number 3.5 and the power, let's say 3, so this would raise the number 3.5 to the third power, and I assign it a value, and x equals that value. Oops, it's actually not an integer, it's double. Never mind. So when I'm calling this method, and actually if I ignore the setter, the getting of the value and setting it to a variable, when I'm calling this method, what happens is the Java compiler looks at what parameters I'm supplying to this method and decides based on the parameters I'm supplying which version of this method should be called. Now, what do you mean by version of a method? Well, we'll see in a bit. So, when you say raise this number to the third power, what Java actually sees is the power method has been called, and it's been called with a double parameter and an integer parameter. That's all Java sees. It doesn't really care about the values you're supplying it. At least that's what the Java compiler cares about. During execution, of course, the runtime cares about the actual values. But during compilation, what the compiler sees is just the name of the method and the parameter types of the method and the number of these parameters. Now, this thing over here, what you're seeing here, is called a method signature. The method signature is the combination of the method name and its parameter types, not its parameter names, but its parameter types and the number of those parameters. So if there are 3 parameters, well, it's going to be a method with 3 parameters, meaning 3 data types for these parameters. So this is the method signature. And here, the method signature for print looks like so. Print accepting a string. Again, the compiler doesn't really care about your name, the name of your variable. It only cares about the name of the method and the data types of the parameters. So that's a signature. Now, how does that matter to the concept of overloading methods, and what is that concept at all? Well, the signature is what differentiates between two methods with the same names, or actually the signature is what differentiates between methods at all, because it includes the method name as well. So the signature is actually the thing that distinguishes methods. So a method isn't simply its name, it's its name combined with its parameters. So two methods with the same name but different parameters are different methods from the point of view of the compiler. The compiler doesn't really think of the method print, which accepts a string, the same way as it thinks about the method print, which accepts an integer. So for the compiler, these are just two different methods. Now, if you have two methods with the same name and the same data types for parameters, then you'd get a compilation error. The compiler will not allow you to have two different methods with the same signature, because the signature needs to be unique. So when you have the same name for a method, but the signature is different, meaning that the data types are different, what you're what you get is the so-called overloading. This is a term in programming which simply means that you have different versions of a method which accept different parameters. And if you go over here and check out the system.out.print method, you'd actually notice that it's not one print method, it's a lot of print methods, one of them accepting an integer, another accepting a boolean, another accepting a character, another accepting a long, another accepting a float. You get my point. They are the same method name, but they have different parameters and they behave differently based on their parameters. So you can have the same method name with different parameters, and that's what we call overloading. Okay, so the example, the common example is exactly with the print function. If you receive an integer number, you call one print function. If you receive a double number, you call another print function. I will give you another example of overloading. Let's implement a getMax function. What will that getMax function do? Well, let's say it returns an integer number. It's a static method. It returns an integer number and it returns the maximum of two values, the value a and the value b. Okay, so the signature of this method is what? Well, the signature of this method is getMax int, int. So getMax which accepts two integer values. Okay, and what would getMax do? Well, if a is larger than b, it would return a. Otherwise, it would return b. By the way, do we need the else here? We don't. Why don't we need the else here? Because we can't reach this return value, this return statement. We can't even reach this return statement if this was true. So if we get a true over here, we get into this condition and then immediately break the method, leave the method, and never reach this return b. So when you have multiple returns inside the method, you can skip on, you can cut corners by not doing else's like this. This else here is redundant because there is no way we can get to this code without, if this code has executed. And that's the whole point of the else. The else ensures that you don't get into the code block if the condition was true. But if the condition was true, there is no way we can reach this code block anyway because we're returning over here. So this is a getMax method. It returns the maximum of two values. So if I say max equals getMax from 4 and 70 and 82, the result will be 82. Max will receive the value of 82. Okay, so this is what getMax does. Now, if I want to implement a getMax which takes 3 elements, so I want to be able to calculate the maximum of 3 elements, not just 2 elements. Well, I need another function, static int getMax again, because it's doing the same thing. So if a method should do the same thing, why not use the same name, even though it accepts different parameters? So let's say this is A, B, and C, and immediately what is the signature? What does the signature look like to the compiler? Well, it looks like getMax, integer, integer, and yet another integer. So 3 integers, which is different than the signature of the getMax with 2 integer parameters. Okay, so how would we implement this getMax method? Well, I'd say int abmax equals getMax of A and B, and whatever the maximum of A and B is, let's compare that with another getMax with C. So the maximum of the first two compared with C should give us the maximum of all of them, right? So either A is larger than B or B is larger than A. The only one we need to compare with C is the larger one. So we get the larger one of these two, and then we say again getMax of the A, B max and C. So what I'm doing here is actually I'm having one method which is an overload of another method, but I'm delegating back to the simpler version of the method which accepts 2 parameters. So that's a sort of a hack you can do with overloading methods. You can have the same method which delegates to it's not really itself. This is a different method. Don't be confused by the fact that they have the same name. The compiler doesn't see them as being the same method. Only we humans see them as being the same method, but these are actually completely different methods because they have completely different signatures. The same way humans have last names, right? So even though you have the same first name as someone, it doesn't mean you're the same person because you have a different last name. And here it's the same thing. Well, sure, they have the same first name, the method name, but they have a different last name, the method signature. Actually, the method parameter types, the signature is the whole thing. The signature is the full name. Okay, so this is one utility of overloading. You implement different behavior. The get max of 3 values is very different behavior than the get max of 2 values, but it essentially does the same job. So overloading is a concept used so that essentially the same operations, the same effect on the output of your program is achieved with methods of the same name but which accept different parameters and may use those parameters in different ways. Okay, so that's typically what overloading is. It's just the option to have the same name of a method which accepts different parameters due to the fact that the different parameters actually supply you with a different signature which the compiler sees as an entirely different method. Okay, and here's another example of this print method, one version which accepts an integer, another which accepts a string, and another which accepts a string and an integer and does something completely different with them. So this is again a completely valid overload of a method. Okay, so the method's return type, something you need to keep in mind, is not part of the signature. Why isn't it a part of the signature? Because there's no way that I can write get max just like this operation. Now, you might say, well, fine, can't the compiler see what I'm assigning it to? Well, not if I'm not assigning it. There are situations where I'm not going to be assigning it, or I'm going to be assigning it to something which can be different values. So the return type is not a part of the signature. If you have a void print method and a string print method, those two, and if they have the same parameter types, those two are not different methods from the point of view of the compiler, and this code will not compile. So the return type does not affect the signature of a method. Keep that in mind. Okay, so I already implemented the getMax method for you, so we'll skip over this function. The only thing you need to do is implement it for different data types. Implement it for a character, implement it for a string, implement it for an integer, and so on. You can compare strings and integers, strings the same way you compare integers, so the code is going to be basically the same, but you're going to allow that method to be called with different value types thanks to overloading it with different parameter types. Okay, and now once we've talked about what overloading is, and once we've seen a few examples, let's talk about how programs get executed. Okay, so I kind of showed that to you in one of the first lessons where we were talking about the debugger. Let's look at one of the things we were doing here, and I'll delete everything else because we don't... Actually, I won't delete anything. Why should we delete anything? It might be useful when we get to the point of naming methods because we have to go back to that to cover again why we name certain methods in certain ways. Okay, so let's get back to this print increasing sequence method and the print triangle method. So let's go into the main method and do the scanner initialization, then do the scanner input, so read the next integer from the scanner. We're solving again the task with the triangles. So let's read the next integer from the scanner and say this is the width of the triangle. And now let's call the print triangle method with the width over here. And now let's start the debugger and see what happens with our program. Now, the way computers organize code that's executing, the way Java code is structured into the executable memory of a computer, and how other languages are structured into that memory too, is the following. Each time you go into a method, that method gets pushed into the current program stack. These frames over here in the debugger in IntelliJ are the so-called program stack. What's a stack? Well, you've probably washed dishes in some part of your life before, so dishes ordered on top of each other are a stack. The only way you can safely take one of the plates from here is by taking the top plate. You can't take the bottom plate because everything else will fall apart. So you push onto the top of this stack, so you go home, you decide you want to eat, you eat one plate of something, then you eat another plate of something, and then you eat another plate of something, and then you eat another plate of something, and let's say at some point you reach to eating the dessert. And when you go to wash the dishes, you first have to wash the plate with the dessert. This is the dessert plate. Dessert plate. You first need to wash the dessert plate. Why? Because that's the last plate you pushed onto that stack of plates. And once you've washed the dessert plate, then you can wash the main course plate, for example, and so on. So that's, of course, assuming that you eat dessert after everything else, but you get the gist of what I'm saying. So the last thing you put into a stack is the first thing you can pop out of that stack, and that's actually the terminology. It's pushing into a stack and popping out of a stack. So this adds items, whereas this removes items. Popping items removes those items from the top of the stack. Now, why is the stack important? Because notice what's going to happen here. So we're going into the main method. So what happens in the so-called program stack in computer science is that the main method comes over here and becomes the first item in the program stack. And it stays there along with all of its variables. For example, this arcs variable and the scanner variable and this width variable and so on. So main is the first thing on the stack. Then it calls scanner.nextInt. And scanner.nextInt gets placed on the stack. So nextInt gets placed on the stack. NextInt executes, and at some point it returns a value. It returns that value to main. And when it returns that value and assigns that value to, in this case, the width variable, this thing gets popped out of the stack, meaning this thing gets removed from the stack, and width now has a value, for example, 5. Okay, and now when I say print triangle arrives on this stack, on top of this stack. Okay, so print triangle gets executed, and it accepts that width parameter. And print triangle on its turn, starts executing for loops, which call what? They call the print increasing sequence print increasing sequence method. And that executes once, and then it gets removed from the stack. And then it gets added again, and then it gets removed because it's in a for loop. And then it gets added again, and then removed, and added again, and removed, and added again, and removed, and so on and so forth, until the print triangle method stops calling the print increasing sequence method. And when the print triangle method finishes its execution, it gets popped out of the stack, and we arrive over here at the end of the print triangle call. So when this invocation ends, all of the stack information for this print triangle gets popped out of the stack. And when that ends, since we're reaching the end of the main program as well, when we get to that point, the main program will get popped out of the stack and removed, and when that main method gets popped out of the stack, the program ends its execution. This is how code gets ordered when you're calling methods. You get methods on top of methods on top of methods on top of methods, and only the topmost method gets executed, and when that one gets executed, the next one below it continues its execution. So that's the program stack, and we can now see how that happens. So currently we're in the main method, and you can see that on the stack. Okay, so now if we navigate into this nextInt method and place a breakpoint over here, and press F9, notice how now in the program stack, in the frames, we have main, and on top of it we have nextInt, which means that nextInt needs to finish its execution before main can continue from wherever it was. It left its control to nextInt. So here, main leaves the control to nextInt. It delegates the control of the program to nextInt. And until nextInt gets executed, main will not continue. It will stay at this part of the code until nextInt completes its functioning. Now, when it does, this nextInt method will get popped out of the stack and only main will remain. So, pressing F9 again. Of course, nothing is happening currently because we're waiting for the input for nextInt. So let's enter, for example, 4. And now, if we go back to the debugger, we can see that only main remains because scanner.nextInt completed its execution. Okay, and now we have print triangle, and if we put a breakpoint over here and press F9, we'll notice that print triangle appears on top of main, and this means that print triangle needs to execute fully before we can return to main. Okay, so now, going into this for loop, we're still on the print triangle method, but the moment we call the print increasing sequence method and get into that one, we're going to get that one added on top of the stack. So notice that how we're over here, and on top of the stack we have the print increasing sequence method, which is now finishing up because I placed the breakpoint at the end of that method. And if I want to see where at which part of the code I got to navigate into the print increasing sequence, well, I can click on this stack trace over here. This is called a stack trace. Well, it's actually called a stack. It's called a stack trace if you see an error which describes line by line in which method what thing failed. Okay, so print increasing sequence in it were here, but that was called from over here. Okay, so if I press F9 again, since I'm in print increasing sequence, that will leave the print increasing sequence method and return to the next call of print increasing sequence. So this will get popped out of the stack. We will get back to print triangle being on top of the stack. It will execute the next iteration in the for loop, and then it will pop up it will push in the print increasing sequence on the stack again. So we're seeing that in action now. I just left the print increasing sequence method, and now I'm on the next iteration of the loop. Notice that I is now 2. Okay, and now I'm going to push this print increasing sequence method back onto the stack. So pressing F9 now, we're back inside the print increasing sequence method, and now we can notice that the print increasing sequence is back on the stack. And now we can let this continue on until it completes, and wherever this method completes its execution, meaning that when we get to this point at the end of the method's body, print increasing sequence will, let's remove this breakpoint, print increasing sequence will no longer get added on top of the stack because we just asked IntelliJ to navigate to the next breakpoint, which is at the end of this method, meaning that all of the calls to print increasing sequence have been already done. Now print increasing sequence won't be added anymore, and even print triangle will be leaving the stack because we're reaching the end of its body. And when we reach the end of its body, we will pop that out of the stack and reach the end of the body of the main method. So here we are at the end of the body of the main method, and notice how the main method is the last thing on the stack, and after this breakpoint continues forward, after we continue forward from this breakpoint, the next step will be for the main method to be popped out of the stack and for the program to finish its execution. So that's how the program stack works, and that's how you can navigate with the debugger through that program stack to check the values of variables at each of those states. Each of the times I paused somewhere in the program stack and navigated up and down on that program stack, I could have examined the variables on that program stack. I even showed you, for example, the I variable and its change in value. So that's how programs encoding execute, and we have more examples over here. And let's see an animation of how that programming stack works. So if you have main, and that calls method A, and that calls method B, then main will go onto the stack, and then method A will cover main over the stack, and then that will call method B, and that will put method B on the stack, and when method B completes its execution, it will be removed from the stack, and then when method A completes its execution, it will be removed from the stack, and then only main will remain. Let's see that. So we start by putting main onto the call stack, then if main calls method A gets pushed into the call stack, and then if that one calls method B, that one gets pushed onto the call stack. Now when method B returns, it gets removed from the call stack and control is returned to method A, meaning that program execution continues from where method A left off. And then when method A completes, program execution continues from where the main method left off, where it called method A. And when it completes its execution, it gets removed from the stack, and the program finishes its execution. So that's what the call stack is, and it's important for you to have a visual idea of how it looks like, because it really helps with debugging and figuring out which part of your code executed after what. Okay, so we have another task over here, and since it's really similar to what we've already solved in previous lessons, we have a number, and we should split that number into evens and odds. So we should start dividing that number and getting the last digit of that number, and if the digit is positive, we need to add it into a positive so if the digit is even or even or odd, we need to multiply in the appropriate multiplication in the appropriate product. So we'll have a product for all the even numbers and a product for all the odd numbers inside this value of 1, 2, 3, 4, 5. And what do we need to do? Well, we just need to pop out the last element from here, check whether it's even or odd, and then multiply it into the appropriate product. So since we've already done separating values, separating a number into its component values, and since we've already done something similar with calculating the even sum of an array, this is pretty much the same as doing an even sum of an array, even and odd sums of an array. But instead of iterating through an array, we're doing it over the digits of a number, which we've already done. And instead of doing sum, we're doing a multiplication. And that's all we need to be doing over here. So you can try solving this problem by yourself by using the things we saw in previous examples. And before we go on to the summary of this lesson, let's go back to the naming conventions which we should be following. So what I mentioned earlier was that I was going to go back to the naming conventions and best practices for when we're writing methods, after we know what methods are and how they are organized and how their program stack works. So here are your guidelines for how you should be writing your methods once you now know what they are. So the most important thing you're going to be doing is giving meaningful names. Now notice how I have been naming my methods. Print triangle. Now this might not be obvious if you don't know the task it's solving, but within the context of the task, print triangle is a clear enough name which describes what this method will be doing. Inside it, we have a more generic method, which is print increasing sequence. Now, the moment you see the print increasing sequence, you will probably notice that this is a method I can be using in a lot of other places, in addition to using it inside the print triangle method. So that's why I'm naming it so generally. Print increasing sequence is something I can call from pretty much anywhere where I need to have an increasing sequence of numbers. Whereas the triangle is very specific for the task at hand. So since it's very specific, I'm giving it a very specific name, which is not very useful outside of the context of the task. But print increasing sequence is valid in any case. It doesn't matter what program you're writing. Print increasing sequence is pretty clear on what it actually does. So try for names like this more often than names like print triangle. But if you have a context specific method, that's also okay. So this is okay, but this print increasing sequence name is better for more general reuse. For non-general reuse, for single use purposes inside a single program with a specific aim, it's okay to have a more non-general name. Okay, what else do you need to know about method naming? So meaningful names, and your name should answer the question, what does this method do? It should contain some sort of verb, some sort of action being executed. So whenever I read a method, I should know that this does this operation. For example, system.out.println, print line, tells me that there's going to be printing involved. So I know this method is printing. Now you could use non-verbal, non-verb method names. For example, the math libraries have a lot of those, like cosine, absolute, max, and so on. But that pretty much only applies for mathematical functions or something very domain specific, something very specific for the task you're solving. So try to use verbs in the names of your methods. Now, if you can't find a good name for a method, that probably means that your method isn't supposed to be a single method. If it's doing 5 things at once and you can't name it with a pretty short name, well, it probably means that you need several methods to do those 5 things, several separate methods. So a method should do one thing. It shouldn't do several different things. And the reason for that, you're probably thinking, okay, isn't it better if a method does a lot of things? Well, it's only better for the situation you're using it in currently. So for the exact specific place you're calling it. Yeah, it's better because it shortens your code, but it's actually not better because you can't reuse it. If it does a lot of things and you need to reuse some of those things somewhere else, well, you can't do that if it's a single method. Whereas if there are, for example, if your method does 5 things, if there are methods for each of those 5 things, then you can recombine the uses of these 5 things in any way you wish. You can use, for example, the first 2 things, or the first and the last, or the middle 3, or whatever combination you actually need to do to execute your code. Like, it's a bit like our print triangle method. So print triangle actually does a few things, but it's also subdivided into smaller methods, print increasing sequence, which can be reused anywhere. So even if I don't reuse print triangle, I can always reuse print increasing sequence, which is the more generic method. So the more generic you make a method, the easier it will be to reuse. Now, that's not always the aim, but it's more often than not the aim. Okay, so parameters should first of all complement the method name. So you don't need to, for example, this parameter last is clear enough in the print increasing sequence context. You don't need to name it last number in increasing sequence because the method already says that. And just saying last, well, obviously it's going to be the last number in the increasing sequence. What else is it going to be the last of? So don't overdo it with naming the parameters. Name the parameters in such a way that they are clear. After you read the method name and then you read the parameter, you understand what that parameter will mean for that method. Now you should use camel case just like you're using for variable names. That's pretty standard, so it's not really weird. Basically, parameter names should follow the same rules as variable names, but in addition to that, you should think about the method name and you should avoid repeating words from the method name unless it really is necessary. And again, they should be meaningful. Another good thing to keep in mind about parameters is that if you're using non-standard unit systems, or if you have a project in which it's not clear what unit systems you're using, you should probably supply the unit names for that parameter. So if you're supplying speed in kilometers per hour instead of meters per second, for example, which is the international physical standard for measuring speed, if you're measuring speed in kilometers per hour, you should probably mention that in your variable name at the end to just indicate in what unit you're expecting the values to be. And font size in pixels is also a good name because it indicates that you want to measure the font size in pixels, not, for example, in percentages or in ems or in some other weird unit. Okay, so your names should be meaningful and they should sometimes mention the units which they are using if they are using some type of unit. Okay. What else? Avoid stuff like underscores and capital letters on the first word of the variable, just like you would do for variables. So these rules are pretty much the same. Now, as I said, methods should do one thing. They shouldn't do 3 things at once. Especially, they shouldn't do 3 different things. My getMax method gets the maximum value of 2 values. It doesn't also print that on the console. There are other methods which print. So I have a single getMax method, and then I can decide what I can do with that getMax method. Whereas, if my getMax method instead printed a value on the console, I wouldn't be able to use that value for calculations. I would only be able to print it on the console. So methods should try to do one thing. If they can, they should try to do one thing, and there should be another method which uses their return value as a parameter and, for example, prints that to the console. So, another thing you should avoid is very long methods. Now, what does method longer than one screen mean? Screens are different these days. It's not back to the old days where all screens were the same. Every screen is different and special these days. Well, what does one screen mean? It depends on the team you're working with. Most of the time when you're coding, you will be working with a team, and you will probably have a standard definition of what's the acceptable length of a method. It's typically 40-50 lines of code, but it really depends on the team, it really depends on your screen, it really depends on you personally. So the point is, follow some sort of convention. While you're a student and you're still studying, well, get your screen size and kind of try to have your method shorter than your screen size, so that one method doesn't fill up your entire screen. And if it starts filling it up, well, extract more methods from it. If you have that much code inside a method, think about, can't I get this piece of code and move it into another method which I can just call from my method? The same way you extract code from main into methods, you can extract code from other methods into other methods. You don't need to only extract code from main. Okay, so this print receipt method in this case can have a print header, print body, and print footer methods which it calls. And this is also self-documenting, because once you see the print receipt method, you don't need to wonder how it works. You just need to know, okay, so semantically this thing prints a header, then prints a body, then prints a footer. If I care about what these consist of, I'll go navigate to the method definition and see that. By the way, if you go to, I've told you this before, but let's repeat. If you put your cursor on a method and you press Ctrl B, that will navigate you to the method definition. So, or you can right click and press Go to definition. Okay, how do you format code? Well, the same way. How do you format method code? The same way that main is formatted. So you follow the code standards of main. It's pretty similar to what you would do for loops and while loops and so on, with the difference that instead of a for loop, you have the static, the void, and the method name, or the static and the method return type followed by the method name, and then the parameters. Now, in Java, it's standard for the method name to be glued together to the brackets, and the arguments to also be glued together to the brackets. But again, check out how the main method is structured, and structure your code like that. Now, very important, use correct indentation. And if you don't know what the correct indentation is, input your method and then use Ctrl-Alt-L to reformat your code with IntelliJ so that your code gets formatted with proper indentation. Indentation is actually pretty important because humans are visual creatures, and it's much easier for us to detect what parts of a code do what when we have when we have these parts of code indented in a way that makes them stand out as part of that code block. So indentation is pretty important. Use Ctrl-Alt-L to format your code. Now, if you're writing multiple methods, try to leave blank lines between them. Not just try, just do it. Leave blank lines between methods. Okay, and same goes for loops and if statements, and sometimes you would like blank lines from different pieces of code where you indicate that this is a part of code which does something, then there's another part of code which does something else, and so on. Okay, so another thing you should try to do is avoid long lines and complex expressions. What do we mean by that? Well, if you have a very long line in a method, shouldn't that be a variable or maybe another method call? Think about that. Don't have very long lines that are as wide as your screen, or even up to 70% of your screen gets like too much. Okay, so that's some advice for code structure and formatting. Now I know that all of these things will take time for you to create into habits, but that's why we're telling you these things early on. You won't hit everything spot on the first time you're trying to write code, but every time you write some methods, go over these namings and best practices. That's why they're so so much in the start of the lecture. That's why we've placed these slides over here, even though semantically we should be talking about them at the end of the lecture, like I'm doing now. So when you've written some piece of code and you're happy with it and it works, go over these conventions and see if you're meeting them correctly. And if you're not, think about how you can restructure your code so you can follow these conventions better and these best practices. Okay, so what did we talk about today? We talked about how we can split large programs into small, easily testable, easily understandable pieces of code called methods. And we said that these methods contains declarations, signatures, and bodies, and we call them using their name and their parameters. If they have parameters, if they don't have parameters, we just leave the brackets empty. We also said that these methods can return values, and if they don't return values, we mark them as void. And we also said that when a method returns a value, it immediately breaks its execution, meaning it stops its execution and returns the control of the program to whoever called that method. And we talked about how we can trace the execution of a program and what the program stack is and how we can see that in the debugger. And I hope this was useful for you. I hope you learned something new, and I hope you can now use this newfound knowledge to organize your code better and to write it faster even. And of course, if you have any questions on anything we've discussed today, please ask them in all the channels we've supplied for asking questions about the lectures. Happy to have done this lesson to you. Done this lesson. Yeah, I definitely did this to you, didn't I? So I'm really happy that I could teach you this concept of methods. It's a very important concept in programming. I hope it was useful for you, and I will see you next time.